Yeah. Hello, everybody. As you're joining, this is Dan Noble, one of the organizers of the California Bioresources Alliance Symposium, beginning right now. We'll get started in just a minute as we get a number of attendees on here. Okay, I think we should get going. So whenever you're ready, Hussein or Lauren, you can introduce the symposium.
Okay. Let's get that on here. Okay, hello, everybody. This is Lauren Fondal. I'm the co-chair of the California Bioresources Alliance Symposium, and glad you're all here. I let Hossein from UC Davis start out with some housekeeping rules. So Hossein.
Hello, everyone. I just wanted to go over a couple of housekeeping rules for the Zoom webinar for those of you who might not be familiar with it. So to reduce disruptions, we've disabled the chat feature, microphones and videos for all attendees. You'll notice there is a Q&A feature that you can use, and that's available at all times to ask questions when you want. You can also raise your hand if you want, although, and we can send you an individual message. The link there is to the EPA website, the California Bioresources Alliance Symposia website. If you would like to take a look at the agenda, you can use the shortened link, or you can scan the QR code. The webinar is being recorded, and a link to the recording will be made available after the symposium in addition to presenter slides. Thank you.
And this is Lauren again, and just a couple of notes, and then Dan Noble from American Composters is going to give an overview and then start with the first session. We're going to be having all the slide presentations on EPA's website, as well as everybody's bio, and hope you can stay for the last session where we open it up and everybody gets to discuss what's on their minds. That will be tomorrow afternoon. I'd like to say thanks to the people at UC Davis, Hossein and Molly and Alan for all the logistic work they've done on this. And then I'll turn it over to Dan to give us a preview of the sessions.
Okay, great. I thank you, Lauren. I'm going to put on a brief introductory slide presentation. I'm hoping everybody can hear. So the title of this symposium this year, this is the 17th symposium that we've done, and it's called Bioresources Technology, Collaboration, and Innovation. But we see it in a broader context of managing the transition to local circular economies in California. But for those of you who aren't in this space all the time, what are bioresources? We are defining them as primary, which is basically the agriculture and fiber and timber industries, what we normally know and being regulated and overseen by the US Department of Agriculture, which includes Forest Service. But what we've defined is within this same space is the secondary bioresources, or what is called in California statute as organic waste, which includes mainly landscape clippings, food scraps, manure, and so forth. And you can kind of see that that picture of both living materials, you know, from microbes to macroorganisms, but also non-living, inorganic, and organic materials. All of those are part of the secondary bioresources. The secondary bioresources or organic residuals are manufactured into a whole suite of organic product categories, or bioproducts, as we sometimes refer to them. And those are organized in kind of 5 broad categories, or 9 or 10 subcategories. The soil products, mulch, compost, biofertilizer, which you'll hear about today, as well as biochar. Animal feed, which is its own marketplace, separate from, usually we don't usually do presentations on that, although those exist in other associations and symposia. But electricity, biofuels, chemicals, and materials are kind of the other side of that equation. And of course, the processing in the center of all of the different technologies that convert organic waste into bioproducts is our focus. You'll be hearing presentations on all of these manufacturing, most of them anyway, today. But it's based on a bigger concept that all of us are becoming familiar with, and now CalRecycle has adopted this concept of moving from a disposal toward a regenerative economic system. Take, make, waste to a circular system. And these ideas are not new. They're adopted from ecosystem ecology, and they've been used in the marketplace for decades. For example, the publication of the official publication of the US Composting Council, Biocycle, has been using the circular and cyclical concept for over 60 years now. But this is gaining new traction, and this diagram is sometimes referred to as the butterfly economy, because you can divide this the circular economy into 2 broad wings. Biological nutrients, or I would say bioresources, is the whole left-hand side, which this diagram is colored, that's what the green bin is composed of in our municipal recycling systems now, and now that's the law of the land here in California. And then the right-hand side, which I could call georesources, although these researchers call it technical nutrients. And the big challenge with the circular economy is that in our linear economy, both of these kinds of resources get all mixed up in products and manufacturers and service providers, and then it becomes exceedingly challenging to separate them back out. But that's why we created the 2-bin system. And the goal is, while we can get some energy recovery from that, a lot of it goes into the landfills. My company, well, and also this is a whole bioeconomy discipline, which is composed of, you know, the engineering, the life sciences, biotechnology, as well as information technology, because as many of you know who are in biology, and it's an information science every bit as much as a molecular biology, a molecular or chemical science as well as physical. I'm presenting the idea of bioresources are unique because in their formation, you get paid coming and going. You get paid to receive a tipping fee for the waste material, and then you get income potentially on product sales. And I have this stack of percentages here because even within the compost industry, which is, I'm the executive director of the Association of Compost Producers, which is the California state chapter of the US Composting Council. We have composters that make all of their money on the tipping fee and little or no money, and sometimes they pay to distribute the product to farmers usually, or to other applications. But then we also have composters that are kind of in between, with some composters called the 60-40 rule. They get 60% of their income on the tipping fee of the feedstocks, and then 40% on the product. And similarly in the retail markets, for example, one of our board members and the founder of our association, Kellogg Garden Products, has to purchase finished compost, almost finished compost. They cure it, mix it, and then distribute it. So they make 100% of their money on the bioproducts. So the economics in this, at this part of the circular economy, is very relatively complex, and that's why we've been developing economic models. But what you see is the structure, the basic structure is feedstock to processing to bioproduct. And then if it goes on the outside loop, rather than the residuals going to the landfill, of course, the whole goal in California is to draw those residuals down to zero. Right now, the current job is to get them from 50% recycled to 75%. So the secondary bioresources across the top, the primary on the bottom on this diagram, and this represents an economic model. In addition, there's a whole bunch of influencing resources, which I have started to call tertiary bioresources, that all influence the secondary. And that includes air, water, energy, logistics, which is mostly transportation and storage and curing and all of that, carbon sequestration, the technology itself, which you'll hear a lot about in the next 2 days, capital providing, and the capital providers don't understand how to throw their money into this cycle. It's like putting a delicate garment in a washing machine, and you're afraid that it'll come out all torn up. So that we focus a lot on using these models for capital provision. But I've isolated so far about 18 different secondary bioresources and divided them into 2 lists: pre-processing and people and biome influences. When you throw all this together, really what it starts to look like is a new culture and a new economic system. So that's just an introduction, and our whole conference for the next 2 days is divided up into sessions: 2 sessions on feedstock, 2 sessions on manufacturing, or what we call site and treatment, and 2 sessions on bioproducts. So that's 6 sessions total there, 1 through 6. And then we talk about, we have a whole session on 1383, which kind of tries to tie this all together based on that new law. And then we're going to have a discussion of a number of our panelists at the end. So that's a brief overview and introduction to the symposium. So now we can get started. So I want to, hopefully all of our panelists are ready. Let me put on the first 2 sessions are here. And so the first session, which I am moderating, is, I don't know how I stopped sharing. Oh, I see what the problem is, sorry. I'll start by introducing Mike McCullough, who is a professor at Cal Poly San Luis Obispo, and he is I think the appropriate title is Executive Director of the California Clean Biomass Collaborative. Mike spoke last year, and now he's going to give us an update on this program. And I will stop sharing, and Mike will be highlighted by Hussein, and then we'll take it from there.
Perfect. Thank you, Dan. Let me share screen. Wonderful overview of the whole bioeconomy, which I think is so important to understand when we're talking about all the different feedstocks and how everything moves through. So yeah, I want to give a update on the California Clean Biomass Collaborative. We've been going for around a year now. This is a collaborative that's focused specifically on looking at the woody biomass generated from agriculture in the San Joaquin Valley, and then kind of blooming out from there. So it ties in really well. We've had some a lot of things going on. So I'm just going to jump into it and look forward to our discussions and whatnot later on. Just disclaimer right up front, anything that I say that is not just based on what's going on out there is my own opinions and thoughts, not representations of official California Air Resources Board or California government determination or policy. Standard. All right, so what I would like to do in my allotted time is to give you a little bit of a background on what the California Clean Biomass Collaborative is, and then talk about what's been going on in the last year, and then really just pose some questions that have been brought up and some things that we have seen over our discussions and our site visits and whatnot, and then pose some ideas about where we can go from here and what things we can be looking at into the future and moving on. So for background, in 2005, SB 705 substantially reduced agricultural burning in the San Joaquin Valley. The San Joaquin Valley Unified Air Pollution Control District, or the district, has pretty much prohibited burning from a majority of agricultural crops, including tree trimmings, vine trimmings, and whatnot. But it still existed in portions throughout, and the practice has been fairly common, with a few hundreds of thousands of tons of biomass being burned every year. A lot due to technical restrictions and whatnot. In 2014, restrictions have reduced ag burning by 80%, so quite substantial. In the meantime, between the 2002 and 14, we've seen a significant reduction in biomass cogen plants. So loss of state incentives, a lot of other challenges that have contributed to this. So we had over 20 cogen plants in the 80s. We're down to 5 plants today. A lot of the woody biomass coming from agriculture was directed to these cogen plants, and that was the primary source of taking care of this ag waste. And because we don't have those anymore, we've had to look for alternatives. In 2021, this last spring, recommendations from the district and backed by CARB said we need to phase out pretty much all ag burning in the valley by January 1st, 2025. So the majority of it is going away. There's lots, like Dan put out, lots of value-added alternatives that exist to burning. And really, adoption revolves around key areas, or the hindrance of adoption revolves around some key areas. Removal, especially in the case of vineyards with metal trellis systems, is a big part of it, a really big part of it in terms of ag. Removal equipment inventory has been very short, certainly in the San Joaquin Valley. There's, we'll talk about it in a second, a lot of state investment that has been going on right now that's helping that. There's been some restrictive statutes, regulatory barriers to adopting alternatives, and a coordinated supply chain, thinking about that whole bioeconomy and what that supply chain looks like. There's a lot going on. So having coordination in that supply chain has been moving along, but not as fast as we'd like. And then finally, financial support has been a barrier to adoption. And a big part of that's the assumption of risk and where things are at, right? There's a lot of risk involved in a startup, especially new technologies, and where you put that, as Dan pointed out, where you put those funds is a delicate thing. Wow, what a wonderful analogy. So in preparation for the phase out, in accordance with the recommendations, the district and CARB created the California Clean Biomass Collaborative, which I've been facilitating over the last year. It's been tasked with identifying, evaluating alternatives to agricultural burning, specifically in the valley. Where do we go? How do we do it? What are potentials? How do we get there? Our mission statement is to identify technically and economically feasible and sustainable strategies to achieve that near phase out of burning. The collaborative provides a forum for stakeholder groups to identify and overcome issues that have inhibiting development and the advancement of some of these projects. And we very much believe in representation across all stakeholder groups and have been trying very hard to make sure that we hear from everyone. Just a really basic outline of the supply chain that I think Dan put in, the circular bioeconomy outlined very well. We're looking at specifically for us the biomass inputs from vineyards and orchards from the perennial crops, citrus orchards and nut orchards. We've looked at different technologies throughout. And then we think about, okay, how does that fit into our outputs? And then how does capital fit through all of these? And so thinking about this as a supply chain, as opposed to just one specific issue on the biomass supply problem, the input supply problem, where do things exist in that whole supply chain? So the collaborative has looked and has discussed a lot of different points within the supply chain and roadblocks. So where are we at a year later? Well, the district governing board allocated $25 million in local funds as a pilot program as proof of concept to support alternatives to burning. It was very successful. And so subsequently, the state has provided nearly $180 million. And this has been in coordination with some strong local advocacy in working and adopting alternatives to burning. So significant effort by the district, by CARB, by local advocacy groups that in outreach and education, and very successful outreach and education programs. And right now, I think if we're looking back over the last few months, the state program is distributing about $5 million a month of that 180. So very good uptake of the program, and it seems that participants are willing to do it, wanting to adopt alternative practices to burning. The state program since 2021, in the last year, nearly $30 million in new chipping and grinding equipment. So 55 pieces funded to date. That might have been a couple of weeks ago. I don't know if a couple others pieces have been funded, but this is provided. This was one of the main roadblocks, right? And the biomass supply chain was getting it chipped, ground out in the fields. Nearly $80 million in support for alternatives to ag burning. There's up to $1,400 per acre per farm, depending on the crop and the farm size. The funds are directed towards smaller operations first, less than 500, and then less than 100 acres, which the operations that initially had a hard time just contracting for chipping and grinding equipment. So they've had larger directed funds in the beginning. Most of these alternatives to burning, however, have been are chipping and soil incorporation, and that's what 3.3 million tons as of this last September have been chipped and incorporated into the soil. This really brings to the point of the talk is, okay, where do we go from here? We've seen successful uptake of the program of alternatives, and so what do we want to know? And this is a big part of what I want to pose for the rest of the conference, is to think about some of these questions that we've come up, and what are we going to think about? The first one is, this transition funding is not going to last forever. Because it's been successful and people have been taking it on, it's going through fairly quickly, and we'll run out of funding fairly quickly. So what are farms going to do when the funding support runs out? And I think importantly, will this disproportionately affect smaller farms, those farms that initially were unable to to even get equipment that's out there. The second, is there a natural limit to healthy soil incorporation? And if so, what happens when it's reached? Most of these alternatives have been in soil incorporation. Is there going to be issues then? I don't know. Third, what are the sustainable alternatives to soil incorporation? We've looked at and we visited different technologies and talked about different technologies, but the current scale is not sufficient to take in the hundreds of thousands of tons of biomass that's produced every year, specifically in the valley. And for those alternatives, is there some optimal share? Is there some sort of mix that might look appropriate in different parts of the San Joaquin Valley? Do they depend on the type and quality of available biomass, and how does that mixture look like? Should these investments be targeted towards large-scale projects that can handle large, consistent supplies of biomass? And for those large-scale projects, is there some economically viable amount of supply that needs to be there every year? So what are the real economics on these different types of technologies and projects? That's what we really need to think about as we establish this bioeconomy moving forward. Some more questions. What's the role of state support? Is it initial investment to help cover initial capital costs for doing these, or is it long-term support in terms of price supports or tax credits? I don't know what's the most appropriate thing. What plausible non-biased market solutions exist? And is there a complementary? I think this last questions, and we'll see and talk about a lot of these different technologies over the symposium these next 2 days. Is there, and so one thing, looking at this as a bioeconomy and everything fitting together and being holistic about it, really thinking about the complementary nature between municipal organic waste, forest biomass, agricultural biomass. How does this all fit into the processing and moving through and value added? And then what are the barriers? What are the current barriers to alternatives? What are the barriers to adoption? In our review, a lot of these barriers have tended to be regulatory nature, locally based differences in the way the different communities where the technologies are being implemented view them and whatnot, and it really kind of brings to question how this all fits in, and especially since we're going through our 5th climate assessment right now, how we're viewing the bioeconomy in the state is important and should be addressed. So I think my thoughts on where we should go from here. I very much believe it's not a one-size-fits-all. It's not one technology that's going to win out. It's a combination of lots of them and a lot of different things. And I think one thing I'm very excited to look through is the state really charting a path forward and thinking about what we want to do, what are our goals for the state. And so I just wanted to posit this last thing. Oops. And it's the idea of some of the folks from the collaborative have come up with. It's the California Biomass Scoping Plan. So developing a scoping plan for biomass and our goals as a state. So solidifying goals of biomass use in California, and this is all biomass use, not just agriculture. And then looking at communities, stakeholders, and thinking about their perceptions of different alternatives. And particularly what we want to do in the collaborative is think about alternatives to burning, but what are the perceptions of all different alternatives, all those different products, evaluating the economic efficacy of various public and private policies that might incentivize or support or kickstart some of these alternatives, thinking about the efficacy from an economic standpoint of the biomass markets, reviewing regulatory barriers and being diligent about thinking on how those fit in with our goals. And then finally thinking about provisional licensing or things like techniques that we can use from a policy perspective to make it easier for some of these alternatives to come on board. That's it for my update. I'm very, very much looking forward to the symposium and discussions, and am welcome to questions, comments, regards to research, other types of things, or the collaborative. And yes, thank you very much for your time. And again, look forward to the next couple of days.
Great. Thank you, Mike. Mike, if your video, if you could keep your video on, Hussein, because we have some time for questions just for Mike before we go on to the next panelists. Great, thank you. I'll ask some questions, and to all of you attendees, I see a list of you all. I have that on my screen, and you can, okay, I see one question. This is from Paul Hensley. Paul asks, my question is about other parts of the state other than San Joaquin. Without the incentives, how are the economics in, for example, northern Sacramento Valley?
Yeah, that's a really good point. It's tough, right? And I think especially without the markets established, which they're not as established as we'd like them to be, the economics aren't there quite yet. The San Joaquin Valley has got, because of the burn mandate and the prohibition on burning, this transition has to occur right now, and so that's why the incentives were put in place down there. But we know that the rest of the state's going to have to follow suit, especially in regards to burning and alternatives to that. The incentives that exist right now, I'm thinking back on, it's only a few $100s an acre, and it primarily is in trying to get the equipment here, assuming that we can get more equipment in the state, and we can get that set up so that we can create, or we can transform the biomass from the trees, or from whatever it happens to be, the vines, the whatever it happens to be, into something that's transportable. I don't think things are gonna move very quickly. So a big part of it's turning it into something that can be moved, and I think that's what we've seen in the forestry industry as well.
Yeah, I have another question that, and in fact, I know you're going to be on the panel tomorrow afternoon, correct? If you could bring all those questions to the panel,
yeah,
we can start that conversation. Something that I have been doing in the healthy soil world is inviting composters to the table.
Yeah.
Because government agencies tend to not work with private sector directly, because the problems of the Brown Act and corruption and collusion and whatever. And I think we got to overcome those to create the circular economy, because we have all the regulators and the government money that is going into that, like the biomass money that you've been working with. The Healthy Soil Initiative has got tens of millions of dollars going into it, most of which goes to farmers, and 70% of that money is going to farmers to buy compost. So I think, I think your idea of a scoping plan is awesome, and that has to be in context with not only, I kind of see the biomass or the bioresources as renewable carbon management, and we've used that as a title for this conference in years past. But renewable carbon management has to be managed with renewable nitrogen and renewable water, because they all go together, right? Ag is very constrained by water. I'm starting to think of water as the primary or essential bioresource, because there is no bio without water, right? So, and biomass is the lowest water containing material compared to the leafy or the food, or, and certainly the biosolids and manure. You always have to deal with the water in your technology. So I'm interested with the scoping plan. What kind of organization might that arise out of?
Right.
What do you have in your mind?
Yeah, it's definitely got to be something that's collaborative, and it's got all the stakeholders to the table. If one group doesn't want to participate in it, from any perspective, it's not going to go. We have to have buy-in from everyone.
There has to be that critical mass. That's what I've realized, is that the circular economy is really made up of a lot of spokes.
Yep.
And the hub, if there's no hub, then
Yeah.
it's kind of chaotic or
Yep.
chaos.
Yeah.
So I'll put this down now, and then we'll move on to the next speaker. Would you be willing, not only through Cal Poly, but I mean, that's the institution that you work for right now. But I'd like to form, what we've just started forming in the healthy soil world is the Healthy Soil Roundtable. So what I'm hoping we can do is form the Healthy Soil, or maybe a Bioresources Roundtable. And it will take 2 or 3 anchor tenants to make that fly. Probably 3, in order to have 3 spokes on the wheel. One from academia, one from private sector, and a bunch from government, or balancing those. So
yeah.
Let's talk about that in the final session. I think that's maybe the way that we can roll out through this. So thank you very much, and I look forward to working with you too.
Absolutely.
Okay, now we have Megan and Jenny, who've shown up on the screen. Thank goodness. I was a little worried there for a bit. Megan Eibach is a product and zero waste specialist for the Southwest, including Southern California. And for years, her passion has been supporting local food systems, and most recently, she ran sustainability for a dining program at a university. After seeing the sheer volume of food waste, recycling, and trash generated from the main dining hall, waste diversion became her thing. She's spent the last 5+ years understanding the full cycle of consumption and finding creative solutions to end our linear model of living. Now working for Eco Products, she's excited to network with composters and communities to discover creative solutions to keep us as much useful material out of the landfills as possible. And her associate in the same company in Eco Products is Jenny Slepian, and she's the product zero waste specialist for Eco Products, and she has a master's in sustainability and environmental management from Harvard. Ooh, that's cool. A master's in regional and resource planning from University of Otago in New Zealand, and a BA in geology from Bowdoin. Is that how you pronounce it, Jenny? Bowdoin. Okay, thank you. So Jenny helps Eco Products customers in the Pacific Northwest and Northern California implement zero waste strategies connected with composters and composting technology to ensure they comply with local and statewide legislation. Recently, Jenny was a governor appointee to Oregon's Truth in Labeling Task Force, and prior to joining Eco Products, she was sustainability analyst for the city of Lake Oswego. The reason we keep having compostable serviceware manufacturers at the table is that's another absolutely essential networking opportunity, because as I showed in the butterfly diagram of the circular economy with the 2 wings, that it becomes a source of plastic, and these folks have been working mightily. Both Eco Products and Vegware have been members of our state association, and of working with composters to rectify and harmonize the feedstock issues on the front end of secondary bioresource utilization. So I now leave it in your capable hands with that, after that long introduction.
Great. Thank you, Dan. That's a great introduction. We appreciate it. And we're really excited to be here. Thank you everyone for being here, and it seems like a really good attendance. I hope everyone gets a lot out of it. So yeah, we are here to talk about compostable food serviceware, embracing it as a compostable feedstock. And so Eco Products is a food serviceware manufacturer. We make single-use food serviceware that is either certified compostable or made from recycled content. And about 80% is the certified compostable. And we work really hard to make sure that our products are tested, that they work in various compost piles, and that they also work in your hands in the applications that restaurants, arenas, stadiums, universities need them. And we recognize that there are impacts of disposable packaging. And so we really work as a team and as a company to build circular systems that enhances food waste collection. And then, like I said, the products are successful in their applications and then in their end of life. And we promote reusable as much as possible. We really want reusables as a society, but we all know that we are far, far from having reusables be the one and only answer. So I think, as Mike said, you know, there's just not one single point and one single solution. So, and we also want to give a shout out to Vegware. Our counterpart, Ellie Ventura, really helped with this presentation. And Eco Products, we acquired Vegware within the last year, and they're basically like the Eco Products of the UK. And they have a phenomenal set of really unique products that help restaurants and large venues really achieve their goals as dining operations. So let me get my mouse here. So certified compostable packaging does get more food to piles. There's been, and we'll go over some studies that have been proving that there's a lot of food that gets missed when in front of house does not get collected. But we do recognize there are lots of challenges and opportunities with using compostable packaging in compost systems. Food really is the secret sauce to a happy compost pile. And but packaging does provide some carbon value. Certified compostables really, they aren't contamination in a lot of systems, but they get viewed and kind of lumped together with contamination. And we think that is in a huge part to do with lookalikes and the greenwashing that is just rampant in our community. And frankly, many people, consumers, even restaurants, don't even know what is what and what's supposed to be compost, recyclable, and trash. And one thing that we recognize that is very challenging across this country is every system, every community kind of has a slightly different process. Red Solo cups might be collected and recycled in your community, but not in many, many others. So that is really confusing. So we think the responsibility from food service product manufacturers is very important to properly test and label products. We put the certified compostable logo on our products. We put BPI certified. We get it field tested. And we really encourage other manufacturers to do the same, because we really need to get on the same page and the same language to help clear up some of that confusion that consumers face. And obviously legislation is a big one. Here in California, it's wild and probably the most robust. But there's a lot of opportunity with that. With SB 1383, obviously there's a huge goal to increase food waste diversion to 75%. And that's an enormous number. And obviously infrastructure has to catch up. A lot of systems have to catch up. But without accepting compostable food serviceware, there's a lot of food scraps that get thrown away and put into the landfill. And so we're really excited about some of the creative solutions that are coming about in today's world, because there's decentralized compost systems. There's some really unique in-vessel systems where large venues and universities can actually compost on site. And we have been testing with a lot of those companies to make sure, and are finding success, that our packaging is breaking down and not causing any negative effects, and really just kind of becomes more of that bulking agent. So what else was I going to say? The home compostability part's really tricky, right? Because I know even a lot of my friends are like, oh, it says it's compostable. Why can't I throw it in my backyard compost? But there is that difference between, products that you don't want composting in your hand. They actually need to be sent to more of an industrial setting, which isn't available to people nationwide or even, from one community to the next. So this is another reason why I think there's actually a lot of interest in testing, and we're heading in a direction, we hope, of more products that are functional on the front end, but actually can end up in home compost piles. And I know as a company, we're definitely working on that. Compostable packaging is typically more expensive than its petroleum-based counterparts, but there are a lot of positive impacts about that packaging being a better option, especially when it can find its way into a compost pile. And I know we all know awareness, education, and understanding are huge. You can even see that in the recycling industry. I mean, how many decades have we spent trying to get people to understand what happens with recycling? So I think this is a really huge, important process and an important focus that as communities, we all can work towards. But again, that proper labeling, getting on the same page and using the same language, and then using those third-party certifications to build composter confidence can really help consumers and composters alike. And as a company, we really value the importance of the finished product. And that's why we really want to make sure none of our products contaminate the stream, that they work in piles. We test literally with individual composters across the country to make sure efficiencies and that unsuccessful breakdown of our compostable packaging. And while this still won't prevent the dog toys or the glass bottles from entering anyone's stream, certified compostable packaging is designed to break down given enough time, and it should not leave any harmful residues. So we're going to cover towards the end of the presentation, but there's some opportunities that composters have to test their finished product just to make sure that they can be confident of that. And so with all these challenges, there we go. With all these challenges and many opportunities, we at Eco Products and Vegware have a team of specialists all across the country. As you can see, all of our shining faces here. And literally our job is to work on the front end. So work with restaurants, stadiums, universities, all of the operator side, help make sure what they're using, if they're not using reusables, to make sure everything that they're using is accepted at their composter. And Virginia's going to go into that value chain of our system solution, of the different steps we take. But our job is to work on the front end and then also network with composters, like I said, to test products, to build their confidence, to know what they're accepting is going to successfully break down in their piles, and then all of the things in between. And so thank you so much, Dan, for that introduction. I don't think I need to say too much more. I'm just really excited to be here and talk about this with you all. Jenny, if you want to say anything else about that.
Thank you, Jenny.
Dan? No, I think let's keep going. All right, so now it's my turn. If you hear some grunting, I have a slightly needy and grumpy pit bull at my feet who might have some things to say while I'm presenting this thing. I'm going to go through how we ensure that we have better separation at the source. I think one of my favorite expressions out there is one that Surfrider uses that's called keeping it clean upstream. And that is something that we definitely take to heart at Eco Products when it comes to our products ending up at a compost facility. So the main points that I'm going to go through are how do we get our customers to choose the right products? How do we make it easy as we can? What education and training resources do we provide? The importance of having a strong relationship with your hauler and then collaborating with your composter. Next slide. So I'm going to go through this a little bit out of order. Legislation is definitely the first step in guiding procurement of the right products. I think it didn't used to be that way, but we do, particularly in California, have some really strong state and local legislation that's providing guidance for customers on what they can and cannot buy when it comes to either single-use plastics, which in a lot of communities is banned, or specifically what types of compostable products that they can buy. And so when we're working with our customers, that is often where we first start, is looking through the legislation, paring it down, trying to make sure that they can understand what the legalese means. It can be very, as someone who came from 6 years in local government, I know that we don't always write clearly in a way that everybody can understand. So our product and zero waste specialist team is that resource for our customers. We work with a lot of procurement teams, whether that's just somebody working in a local boba shop wondering what they can buy, or some of the really large Aramarks and Levy restaurants of the world, in guiding them on toward where to look. So first we look at what is needed at that business, and then once we know what types of products they're looking for and that they're willing to go to compostable, we really try to encourage them to only use BPI certified. And if you're not familiar with what BPI is, that's the Biodegradable Products Institute, and they do lab testing of compostable products and then certify them as compostable. The other option is CMA, which is the Compost Manufacturing Alliance, and they do field testing of products in ASP systems, windrows, covered ASP, in vessel, you name it. They test in all different types of compost applications. ASTM compliant, that's just to make sure that the products are meeting the ASTM standards for compostability. And then, as I mentioned before, are these products locally accepted, not just locally accepted under the existing legislation, but are they locally accepted by a composter? Is there somebody who can actually take that product and have it be part of the feedstock for the compost? And once we have all of that information, then we can recommend a bundle of products that can be used in that community. So where it gets complicated is we have a chain of restaurants all over California. We really have to dig deep and make sure that each one of those restaurants is using the products that is compliant in their community, which isn't always popular with a restaurant chain owner, but it's necessary to make sure that the composters are getting what. Next slide. So we try to make it easy to do the right thing, and that is in terms of education and outreach. So we have basically 3 tools that we rely on, which is a triple bin system. I know that there are a lot of places where landfill bins are not used, but we strongly encourage it, the reason that I will explain. We can provide comprehensive signage, and we encourage everybody to use a lot of images. I think any of us who have worked in this field for a long time know that people don't read signs, especially if they're in an airport or they're on vacation or they're skiing. The last thing they want to do is stand by some bins and read some signage about where their plate should go. So we try to make it as clear, use lots of pictures, make sure that language is not a barrier in understanding what goes where, to try to get everything into the right bin. And then using all compostables. Where we really get into trouble is if you have a compostable cup with a plastic lid on top, or plastic cutlery with a compostable plate. People are definitely not going to look and try to figure out where the fork goes versus the plate goes. So we encourage our customers to use all compostables and not mix and match. With supply chain issues, we understand that can be a real challenge, but that is something that we are always trying to do. We will do custom signage for our customers for free, just to make sure that everything is going to the right. The reason that we do encourage a landfill bin too is that, as Megan mentioned, commercial composting is not available everywhere. And so if or a composter will want fiber, but they might not want PLA. In that case, that PLA needs to go into the landfill bin. It's not what we want. That's obviously, we don't want to be contributing to the single-use disposal world of sending to landfill, but it is better than sending something to a composter that a composter does not want. Next slide. Education and training is something that we take very seriously. We like to come in all phases. And so a lot of what we can do, a lot of the tools that we use for education and training will often start with a waste audit or a waste characterization study. We offer continuing education. So for some of our long-term customers, we can go back year after year and make sure that staff understand what is expected of them in places like a ski resort where they have a lot of seasonal workers who may be coming from other countries, speaking other languages. It's important to make sure that as that staff comes in for the season, they know what the rules are. And if they're being asked to waste sort, they really need to be shown. How do they waste sort? How do you do that? For us, it seems it's something that we love. I think a lot of us here don't mind getting our hands dirty, and it seems pretty intuitive, but that's not something that everybody necessarily enjoys or understands how to do. And it's something else that's really important is having internal, having a food and beverage manager or somebody higher up in the organization who makes it clear to staff, whether it's through a letter or through an all-staff training at the beginning of the year, that this is what they're doing and explaining why they do it, not just how, but why are we doing this is key for getting everybody on board. We also really suggest, if possible, going on a tour of a compost facility. We took one of our big distributors this summer to a compost facility outside of Boise. They're selling eco products, they're selling all sorts of products, but showing them the whole process and then the amazing finished product that this composter produces was just really mind-opening for them. And one of the guys from that company just really, it changed the whole way that he does his business and the whole way that he looks at compostables. It was such an amazing educational experience, something that we can't explain, but you need to see it in person. So whenever possible, going to a compost facility is a huge part of the educational training. All right, next slide. The hauler is key. Right up there with looking at legislation, one of the other first things that we do is we look at who the hauler is. And establishing a relationship with them. We know there has to be somebody who is going to get all of that food, all those organics to the compost facility. And sometimes that's not available, and we need to know that right off the bat. So having that relationship with the hauler is one of the first things that we do. The hauler will also help us define what is acceptable, what can they haul. They will be the first eyes on the product. In a lot of communities, maybe they'll slap an oops tag on it if they notice contamination. They will get in touch with the customers if they're noticing that things aren't going right, and they'll reject the contaminated loads. So they're doing it as well as they can. They're trying to protect the compost facility that they're working with, whether they own it or they just work with it. Keeping that working relationship with the hauler, even moving forward, is important. When rules change, programs change, relationships change, small haulers get bought by big haulers, and then everything can change. And changes in service happen all of the time. So we try to make sure that whether we know a lot of our customers don't have the time to maintain that relationship, so we try to maintain that for them wherever. Next slide. So again, as Megan mentioned, what we're really wanting is to make sure that we're contributing to a high quality compost at the very end. And so composters, we try to stay on top of what composters will accept. And this is another area where, rightly so, the rules are changing all the time. So we understand that in every community, every composter, the timeframes that they're running through can be different. The types of technology that they're using can be different. What they want can be different. We have a couple of composters in Washington that will not take sugar. They do not want molded fiber products, and that's just because of the way that they are. That's just because of the system that they're using and the temperatures that they're running their panels at. And that's really surprising. They'd rather have PLA than fiber, and that's unusual, but that's important information for our customers to know. We know that their final goal is to produce a high-end compost. So we know that composters should try to vet all their customers. That's not always possible, but they're open to inviting people out, and that really, as I mentioned, makes a big difference. It is their house, it's their rules. So we really need to make sure that we are respectful of that and that we're encouraging our customers to be respectful of that. Clear labeling is super important. The state of Washington just passed a labeling law for compostables that will require big green stripe, compostable, cutlery has to be brown or green. And this is really frustrating for certain businesses, but it's protecting the composters, and we'll definitely support that. requiring certifications, BPI, CMA, and being really clear about what substrates they.
Somebody muted
There we go.
Jenny. There you go.
Megan, can you go back a slide, please? Thank you. Rejecting contaminated loads happens all of the time, and composters just deciding that contamination is too much for them also happens all the time. And so that's another area where we just try to work with them and continuing to test our products, and then working with our customers on double, triple, quadruple sorting to make sure that they only get what they want. It's a constant effort, and we feel very committed to doing that. All right, now you're next one. So what this slide is showing is that it basically all starts and ends with the composter. There are opportunities for education all along the way, but ultimately what the composters will accept drives that initial procurement process. As I mentioned, I love that we're always working to keep it clean upstream. So whether that's through clear labeling, constant sorting, educational opportunities, working with staff, all of those tools we do to support that final goal of contributing to a good, high quality compost product. So I know I ran through this really fast, but I wanted to leave Megan some time to go through these really fascinating case studies that she found. So I will now turn it over to Megan.
Thanks, Jenny. Yeah, so there are studies and there's field testing, there's people that are proving that compostable packaging does contribute towards the compost pile and does not contaminate. So this is a really interesting study that took about 18 months to compile. It was sponsored by the Food Service Packaging Institution and was a collaboration between a lot of other parties. And they looked at four different types of restaurants in Chicago. So there's a full service restaurant, museum that was quick service, school tech cafeteria, and a university quick service cafe. And what they looked at was different kinds of data on how they operated, and then what was comprised of their waste streams. And it suggests that venues, their findings were that venues that adopt compostable food serviceware and then have those favorable conditions. So similar, so what Jenny was talking about, good training, consistent signage, the 3 bin systems, less items to sort, less choices for the consumer. All of those practices, they actually found that contamination levels were lower when there were more compostable items adopted. And they also were able to collect higher food waste streams. So unfortunately, we would love to say that people at restaurants and all these cafes eat 100% of their food, but that really isn't the case. So this study definitely proved that at all these venues, there is valuable material that is being wasted at the post-consumer level. But when you really focus on supplying compostable packaging that is accepted by the composter, there really can be a lower level of contamination and a higher level of food waste collection. And this is literally our system solution in action. So yeah, it really, a lot of these strategies reduces confusion for staff and consumers and composters alike, which is really important. And then I was just going to highlight quickly a couple of third-party studies that really demonstrate that compostable packaging is valuable. Click. All right, so there was a study by the Biodegradable Products Institute and the Food Service Packaging Institute in 2018 that evaluated compostable packaging as a feedstock. So they used 2 different sites, one in Washington and one in Colorado, and they really super loaded piles with compostable packaging and evaluated the impact from the composting process and the quality of the finished product. And the results are really positive, showing that of all the factors evaluated, compostable packaging provided the same benefit as traditional carbon and bulking agents found in yard trimmings. It actually adding a significant diversity of food service packaging did not change the quality of finished product. And like I said, the packaging performed just as well as other traditional feedstocks. So thinking of compostable packaging as a carbon source, as a bulking agent, it does not negatively impact the quality when obviously contamination is its own beast. Another study, this was a ways ago, 2016, is actually really interesting. They studied 5 different venues. So there was like a full day festival, there was a grocery store, a quick service restaurant, a small farmer's market, and then like an evening concert. And basically their goal was to identify the maximum quantity of food that compostable packaging could divert from all of those different venues. And one thing I thought was really interesting for the full day festival, there was over 22,000 pounds of material collected in the front of house. So we think that front of house is typically all packaging, but really there can be a significant portion of it is that valuable food waste. And of those 22,000 pounds, 50%, almost 50% was food waste. And then the little images I have showing for you, basically this study proved that recycling alone would not help any of these venues in like true waste diversion. But when you couple recycling, front of house, back of house composting, and food service packaging that is also compostable, you get much, much higher diversion rates. So obviously there's still going to be diapers. There's still going to be maybe like a souvenir plastic cup that's shared at whatever venue. But you can really achieve a much higher diversion rate when you successfully implement all of these things. And I know with the large festival, they actually had staff and volunteers at food waste, the bins, the 3 bin systems at the end, which we always recommend if venues are able to do that, to have help consumers, help guests with that decision making, just to really help reduce contamination from the start. Another study was from EcoCycle. Now EcoCycle is a nonprofit and a hauler, actually. They do amazing things here in Colorado. And they studied 18 different front of house food service front of house collection services. And their studies with all of their different outlets, they found at least 56% of the material collected in front of house was either food or napkins. And again, this is contrary to that belief that front of house is just only packaging. And this just shows that front of house collection, compostable food serviceware really can capture more of that valuable product that composters want. All right, so we mentioned, I'll give this back to Jenny to talk a little bit more about testing.
Yes, so we mentioned that there's a few different ways that manufacturers of compostable products can test their products. And again, we encourage all manufacturers to do this. That definitely is not the case right now. BPI has this no-cost testing program where they will work with composters to test their overs, which is the overs are what is left over from the first cycle of composting. So after things have gone through the piles and they've been able to sit for a while, whatever is left, some composters will then take those overs and then run them through the process again. One of the values of doing overs testing is to screen it and see what compostables have not broken down in that first phase of composting. And so this is a free service. So we definitely know that there are some compostable products that might end up in the overs and could go through another round. So this is great. It's free, especially if you're a composter who wants to run your overs through multiple times. This is a great program to take advantage of. The other one is run by CREF, the Compost Research and Education Foundation, which I believe Dan is pretty involved in, right? Yep.
Yes.
Yeah. Dan, do you want to share any notes about this field testing program? Do you have here?
No, go ahead. We've got to bring your presentation to a close so that Mary can also speak.
Great, okay. So again, you can read through this if you want online, but field testing is great because BPI does mostly lab testing. And so some products may behave really well in a lab, but not, it might behave differently in different field environments. And so doing field testing is really crucial. And so this is a great program that's provided by Samaria. Now I will stop talking because I definitely know that we need to move on to the next presentation.
Yeah, we'll just close with, oh, well, yes, this
Yeah.
one.
So these are just a variety of third-party certifications that are out there. I won't go through all of them. The top are for products, and then the bottom are the different compost certifications that are mostly related to being organic listed or organic certified for application on organic.
Awesome. And lastly, we'll just close, you know, together as communities, as human stewards of this earth, let's make circular economy a reality. We really need to move towards this regenerative model of living. And in terms of packaging and serving food and eating and consuming, let's all reach for reusables as much as possible, and then work to make the single-use part of the cycle not the problem. So yeah, we'll just leave it at that. Thank you so much.
Great. And it turns out rather than having question and answer right now, what we'll do is we'll let Mary give her presentation, because that kind of rounds it out. She's in a food scrap collecting program in Sunnyvale. And then hopefully we'll have enough time after that to bring all 4 of you back, and we can have, you know, some Q&A there up to the break, which isn't for another half an hour anyway. So thank you very much. I know we had some questions, but also some interactions from one of our attendees, and we'll try to fold him in as well. So I want to introduce to you all Mary Lindemuth, who has more than a decade of solid waste industry experience, and she implemented, as I mentioned, Sunnyvale's first commercial organics recycling program in 2011. So her responsibilities include education, outreach, and monitoring of Sunnyvale's commercial sector for regulatory compliance, as well as championing the zero waste programs. The city's liaison to the California Green Business Program and the California's Product Stewardship Council. She also serves on the California Organics Recycling Council, which I also have been on for the last 20 years. It's a good place for us to network and get to know each other's programs, and which is a technical council of the California Resource Recovery Association. So Mary, take it away.
Hi, thank you, everybody. Thanks for the introduction, Dan. So I'd like to talk a little bit today. Let's see. Everybody see my slides?
Yes.
Yes, okay. I'm trying to advance the slide, but it is not advancing.
Uh-oh.
Uh-oh.
Is
Let's see.
it's on your computer. You did your own share.
Yeah, I did, and it advanced during the practice. Would you
Of course.
be able to advance my slides?
He will have to share from his own screen. Hussein, do you have?
I'm getting them up for you.
Okay,
I'm sorry,
great.
I don't know why they won't,
That's okay.
the controls don't work now.
It happens. That's one of the reasons why we want to get everybody's presentation for just such occasions.
Yeah.
Hey Mary, my computer's freezing a little bit. Let me
Uh-oh.
give me a minute. Why don't you start talking?
Sure. So Sunnyvale does have a unique organics collection program. I'm going to talk a little bit today about why we collect food scraps separately from yard trimmings, the benefits and the challenges of having a food scraps only program. So why do we collect food scraps separately? For one thing, we had a waste composition study that showed about a third of the city's waste stream was food scraps. We're also a zero waste city with a strategic plan to divert 90% of waste from landfill by 2030. And our council adopted a zero waste policy in 2008. We also work in the regulatory, sphere. We have state mandates, AB 1826 and now SB 1383. And we find that you get higher value with recycled food products. We found more markets using recycled food. And we also have a lower yard trimmings and tip fees and a higher value compost with clean green. Let's see, here we go. Okay, want to advance the slide? Great. So today's topics, what we're going to be talking about, move on to the next one, please. So I talked a little bit about why we collect food scraps separately and some of the drivers. Next slide, please. So we've been at this for a while. 6 years after beginning commercial collection, we rolled out what we call food cycle to our single family residents. And food cycle collection includes all food. The only paper we accept are paper coffee filters and tea bags. And this prevents about 8,000 tons per year of food going to landfill. Next slide, please. So I'd like to take you on the journey that led us to a food-only collection program. In 2011, we began commercial compostables collection. Our experience, I think, was pretty typical of a compostables program. There was a lot of contamination and confusion about what was compostable. The first picture shows a slide of a compost bin. They threw in the pots, the soil, everything. And then we had the leaky bin and the wet load problem. The truck in the picture had just serviced a nursing home. The driver was pretty cranky about all the leachate dousing him in the truck. He had to call the supervisor to help clean off the windshield and the surrounding mess. So one of the lessons learned was that our hauler developed specially lined bins for the program. And then another issue was right sizing, and again, confusion about what is compostable. That last picture is from one of our tech companies. They were thrilled to death to begin a compostables program. And they seemed to believe that everything that they had was now compostable. So you can see maybe a little bit of the innocent green bin peeping out from under the bags of garbage. And generators in this area, we have a fairly large tech presence, and they gave us more packaging than food. We had 40 to 60% of some loads being entirely disposable foodware. And of course, it was mixed foodware with plastics. They have a lot of vending machines, so we had lots of plastic wrappers mixed in with this. It was very difficult to get source separation. And it turned out there really wasn't a whole lot of food that we were getting with the compostables program. So in 2016, we tried to rebid our compostables contract. We went out to bid and we requested from more than 12 different facilities here in Northern California. The response was minimal or not at all. And while a couple did indicate that they would accept compostable foodware, they specifically excluded cups. And this was of concern to a lot of our commercial generators. They had invested heavily in compostable foodware, and they were putting a lot of pressure on us to accept this material, but at the same time, we really couldn't get a compost facility to accept it from us. So we attributed this to market signals for this material. Next slide, please. And by contrast, we had no trouble finding markets for our source separated yard trimmings, which we've collected for decades and very successfully composted. It produces a very clean, high quality compost that can be used on agricultural land here in California. Our residents provide us very clean material that we collect weekly. And by contrast, the commercial material that was coming in looks like that picture there on the right. Next slide, please. So we designed a pilot program to evaluate food scrap collection in our residential neighborhoods. Our data collection included lid flipping, where we assessed material quality and volumes. We did floor sorts at our MRF, opened up bags to see what kind of food scraps people were placing out, making distinctions between leftovers, spoiled food, and so forth to better target our outreach. We audited carts along 5 different routes, and it was really interesting to see the differences in the different neighborhoods. In neighborhoods with a lot of renters who worked at tech companies, there wasn't a lot of food to be had. We realized they were eating at work and not bringing much home. By contrast, there's one neighborhood with a lot of ex-retired military. We're right next to Moffett Field here in the South San Francisco Bay Area. And there are a lot of immigrants in the community, and that neighborhood tended to have a lot more food scraps in their bins. So finally, we mailed out a written survey to evaluate what residents liked and didn't like about this program. And one of the things they didn't like was the reduction in garbage capacity, because we provide service in split carts, as you can see, and so that does reduce garbage capacity. However, we considered it successful, and our city council approved a citywide rollout. Next slide, please. So that's our mayor on the left and the GM of our hauler on the right, showing a split cart. So we did change up the split cart ratio to increase the garbage. We offer 3 sizes of carts. A central divider keeps food scraps separate from the garbage, and our collection trucks are split body. Food scraps go on one side and garbage on the other. And we had to design the carts to align with the collection truck hoppers so that spillage doesn't occur. You saw that one slide of the truck in the initial program. And so it's a huge technical challenge to get the truck hopper to align with the cart so that you don't get spillage. All the food scrap compartments are 23 gallons, no matter the cart size. Residents do complain that it's too big. You expect us to waste food because no one makes 23 gallons of food scraps in a week. So even though it's larger than what they generate, again, the challenge is spillage on the street. Because there are so few source separated food scrap programs, cart manufacturers have little incentive to design or build specialty carts like this. So that's the current challenge we're working through. Next slide, please. And then residents had very different responses to this source separated food scrap program. It took about 12 weeks to roll the program out citywide to all the neighborhoods. So after each successive week of a new neighborhood receiving carts, our phones would blow up week after week. We were inundated with questions and comments. And while some residents sent us thank you notes on scented paper, others took concrete action. They removed this cart center divider. They duct taped or zip tied the food scrap side shut. Oh, they sent more direct messages as well. And then others were genuinely confused. You can see that one picture where they didn't get that they were supposed to take the bag of food scraps and place it inside the compartment. And so instead they would put food scrap pails inside the compartment or put the food scrap pails on the curb next to the bin. So, you know, being something new, that was confusing to a lot of people. Next slide, please. However, we were pretty pleased with the rollout. In 2018, we did divert 3,000 tons of residential food scraps from disposal. It decreased residential garbage tons very quickly by 18%. The following year, residential garbage rates decreased instead of increased. So every year we would get complaints from residents when fees would increase. We got not a single comment from anyone that their garbage fees actually went down the following year. Next slide, please. So one thing I want to talk about is the ick factor, because it's significant in running a food scrap program. It requires you to convince people to separate food and put it in a separate collection container. In all the years I've been doing this, I think it's easier to do a commercial food scrap program than a residential one. Commercial food service employees understand food, and they're usually pretty happy to participate in the program once they understand what we're doing with it. Behavioral change is one of our big challenges. So an advantage to a more common compostables program that mixes food scraps with paper and yard trimmings or even foodware is that it does tend to sop up the liquids and does help reduce odors. Some of our residents still they insist on calling food scraps garbage when they call in, and they're still repulsed by the program. They might be a minority, but they are a vocal minority. And it seems once you're done eating, the food you so enjoyed now becomes disgusting, and you want to get rid of it as quickly as possible. People don't like messes, and they really don't like stinky garbage carts. So we've used a community-based social marketing approach to overcome barriers to participation. To mitigate this ick factor, we allow residents 2 free food scrap cart cleanings annually. And to make participation easier, we allow paper, clear plastic, or compostable bags to contain the food in the carts. And because this is not a compostables program and bags are screened out, we remain agnostic about bag material. The commercial sector, I will add, really appreciates the cheaper, sturdier, clear plastic bags. Next slide, please. So I want to talk a little bit more now about the specifics of a source-separated food scrap collection and the processing of it. This is where we do our pre-processing at the Sunnyvale Smart Station. We are located at the southern edge of the San Francisco Bay. We're permitted for 1,500 tons a day. We're a fully permitted solid waste facility, currently doing about 1,000 tons a day. And this is where we installed our food scrap pre-processing equipment. Next slide, please. So in the top picture, you see a collection truck dumping source-separated food scraps directly into the hopper below, and the hopper is at grade. Those sumps are pretty nasty, so having it at grade is definitely a benefit. One challenge we're trying to solve is the length of time it takes to unload. Commercial loads average about 10 tons and take 30 minutes to unload, which is a long time. This backs up subsequent loads, resulting in long wait times for the drivers, and makes the drivers, again, pretty cranky. So again, the trucks have a 70-30 split, and they go out, they weigh, we track all of the tonnages, they come back, and then they reweigh after they've dumped the food scraps. Next slide, please. So here's how the food scraps are converted to a nutrient-rich food mash in this process. Pre-processing elements include a coarse shredder to tear open the plastic bags and an auger to further help open up the bags and liberate the material. The auger also helps move the material through the hopper. Next slide, please. So here's what it looks like in the real world, and I'd hope to be able to run the video, but I'm not live. It's kind of fun to see the material move through, and it is a loud process, but the food scraps are shredded using big rotating knives, and large contaminants are manually removed. I will share that recently, since we've begun routing our multifamily properties to food scrap service, contamination has increased substantially. A couple of weeks ago, we pulled out a full auto battery from one of the loads. So the contamination from the multifamily properties is significant. Next slide, please. So a conveyor belt moves the material to this pictured biopress machine there on the top, and it separates out a nutrient-rich mash, sort of like making cider, and the residue, still rich in nutrients, is separated out. We're attempting to improve diversion and are looking at other equipment. The biopress could recover more organic material, which is currently being lost. We're in the middle of an RFP process to upgrade the equipment. Rotating paddles are an option, and they do appear more efficient at extracting organics. The residue and overs in this bottom picture are sent from the smart station for further processing, either that or landfill, depending on, often what's available on a daily basis. Next slide, please. So in the next step, a tanker truck pumps out the clean mash, a slurry, from the holding tanks that we have at the smart station to a private company in Santa Clara about 3 miles away called Sustainable Organic Solutions for further processing. So you can see that the mash there's tubing, and you see the picture of the mash in the background, and it goes through a dehydrating process. It gets dehydrated into, it looks initially like coffee grounds, and then it can be further processed into pellets. These are high value end products that are made possible due to food only collection. Next slide, please. So our city council has been very supportive and encouraged food scrap collection from all of our apartment buildings as a justice measure. And we did get complaints from the multifamily community saying that we were not allowing them the same opportunities for diversion as we were the single family homes. So council deemed that we would begin food scrap collection in our multifamily properties prior to completing the commercial sector. And even several years before we were able to offer multifamily properties food scrap service, we were obliged to place a drop-off bin at the SMART station for food scraps, and people would bicycle in, drop off their food scraps. It was pretty well received. So this is a picture of a food scrap cart at our multifamily property. You will notice that it is brown. Under SB 1383, food scrap collection must have a brown color separating from green, which would be a compostables program. One of the downsides to been an early adopter of organics diversion programs is that we bought a lot of green bins initially, and we're going to use the green bins for food scrap collection. And then SB 1383 had color requirements for bins, so we were obliged to go out and purchase a lot of brown bins. So we have had a delay in getting trucks due to supply chain disruptions, but we do hope to have commercial routed completely to food scrap collection by September of 2023. Next slide, please. So talking about the future, the SMART station is co-located with our wastewater treatment plant in the Sunnyvale landfill, which we closed in 1992. Since 1994, we've piped landfill gas to our POTW, displacing fossil gas. Over time, landfill gas production has decreased, while energy demand continues to increase as we build a new primary and secondary treatment facility. We're planning anaerobic digestion of this organic slurry at the wastewater treatment plant in the next few years. In 2019, we ran a 6-month pilot to test if food mash could effectively be co-digested along with the sludge and used as a supplement for energy production at the plant's digester. The pilot showed very promising results in terms of gas production and greenhouse gas emission reduction. The excess ammonia produced by the additional food waste requires a new deammonization system and a solids thickening process modification to more efficiently blend food waste with solids before digestion. The design for these changes is underway as part of a Clean Water Program secondary treatment project. The additional estimate for the entire project, including design, construction, and support services, is about $18 million. The design includes the capacity to handle 140 wet tons per day, which is about 30,000 gallons of food wastes. The project is anticipated to be completed in 2026. Next slide, please. Through co-digestion of diverted food waste in the anaerobic digesters, the POTW will help achieve SB 1383 mandated goals while producing and making beneficial use of biogas. The food mash or slurry, along with the food juice, can be easily digested, and it's not an energy-consuming process. Total emissions transporting the food mash from the SMART station over to the facility in Santa Clara, 3 miles away, are 26.56 metric tons of CO2 equivalent, whereas the emissions from transporting the same material from the SMART station to our co-located wastewater treatment plant are 0.57 metric ton of CO2 equivalent. So the energy in biogas produced on site will reduce the amount of energy that would otherwise have to be purchased from our local utility PG&E. So this project is an excellent candidate for any future grant opportunities offered by state and national level agencies for co-digestion projects. Next slide, please. So in 2019, we applied for a CalRecycle grant, were waitlisted, and finally approved for funding this year. Funds will be used to retrofit and upgrade the food scrap processing equipment. As mentioned before, we want better, faster in feed. We're considering a depackager for more contaminant removal. Our goal is to increase diversion up to 85 to 90%. And our plan is to rerun the residue in the overs over our MRF line for further diversion. And I will close by saying there's always a tension between feedstock purity and the volumes recovered. And so the challenges continue. Thanks very much. Next slide, please.
Thank you, Mary. Thank you very much. We do have about 5 or 10 minutes for questions if the other panelists can be put on. I didn't have any specific questions in the Q&A, but I did have some general questions for you and the panelists throughout the presentation. In particular, let's see, we have everybody there. Yeah. It looks like and this is a question for our tech support. It looks like I've lost the capability of unmuting an attendee or even putting on their camera.
Who would you like to unmute? The person who asked that question in the chat, the Q&A.
Correct, Ahmad.
Let me allow him to talk. All right, he should be able to talk now.
Top of the day, everyone. Can I be heard?
Yep, we can hear you.
Okay, great. Thank you, everyone. Wonderful presentation. Very inspiring. I'm in Stockton, San Joaquin County. I was kind of surprised to see that the data was very San Joaquin heavy, but in very pleasant surprise. I asked a few questions, so I'll just go through them again. One is in terms of fiber textile composting. I work with a group called Fiber Shed. They're in this same area, Northern California area, and they are actively running a fiber composting project that I would love to connect with this effort and also amplify and expand for folks. So that's one. The other has to do with workforce development, which is something that I'm passionate about, specifically on food waste composting. And I enjoy the pleasure of serving with different groups in terms of that, both farmers as well as municipal groups and organizations, CBOs, the whole gamut. So very interested in bringing job opportunity, workforce development opportunities to my area. And lastly, shortly, I'll be joining another meeting of the SURF committee or team. That's a huge grant initiative. That's a tri-county initiative. So we really have an opportunity to amplify everything that was spoken about today across those groups and sectors. And again, I would love to facilitate. Lastly, I'm more specifically involved with BIPOC opportunities, but I definitely do not exclude any opportunities for this very wonderful circular economy transition. So I know that was kind of a lot, but everyone here is very impressive and intelligent. So even I'll put my email in the chat. So if there's any follow-up or opportunities that you want to go deeper into the weeds, I'll be very happy to make connections and continue the conversation offline. And thank you again. Really excellent.
Thank you, Ahmad. Ahmad and I have been in touch in terms of collaborating between composters and his process. And one of the challenges, so this kind of goes back to something that Mike, we talked about in terms of the bioresource, plan development for the state, but also how does that integrate down at the local level where some of you like, well, Mary is working, at the local level, and we do minimal collaboration there, but then the product producers, that's another level. And fiber composting isn't part of the food system, but it's a big issue for composters as to whether they'll even get into that business. And again, it's the same problem with food of, synthetic versus organic fibers. So if you just maybe speak to your forms of collaboration with producers as well as you folks in the collection business, and what this points to is that there is a feedstock segregation issue, and you all have touched on that. The biomass is, we're looking at the biomass as part of how do you add more nitrogen back to it, or do you need to? Because we'll have some more discussions later on about fungal dominated compost, or what's called biocomplete compost, that maybe don't need the nitrogen. And then we'll have some other talks about the biofertilizers, where you're trying to maximize nitrogen, your C to N ratio, your carbon to nitrogen ratio. And that begins with the feedstocks, which is why we wanted to put the feedstocks at the front of the conference. So anybody have any comments? I've kind of dominated there.
There was a question that one of the panelists actually had for Megan and Jenny. The question was, what feedstocks do they use to make your vegware materials?
Good question.
Vegware, eco products and vegware use similar substrates. So we use the gas, which is sugarcane. We use just other types of fiber. We use PLA, which is a corn-based substrate. We use wood for cutlery. Vegware does. We use paper cutlery. I don't think I'm missing any, but we have that. Those are kind of our main substrates.
I will add, Vegware actually uses this thing called Nature Flex, I believe, and it's a cellulose blend that actually adds some transparency, but also some heat tolerance. So it's a really cool, like, if you think of a lot of like baked goods and boxes with windows, and that's one thing as I'm learning more about vegware, since I actually started in April with eco products. There's some really interesting uses of that cellulose, and it's completely, I mean, it's so compostable, it's amazing, but it also adds a lot of value to the front end.
Great. Okay, great. Well, we actually are right on 10:45. So this is time for, really appreciate all of the presentations. And I share Ahmad's perception as well. I was really happy to have all of you guys present and sort of set the stage for us. We have a second panel on feedstocks as well. And what we were trying to do with the double panels on each subject, feedstocks, processing, and product sales, formation, and distribution, is to understand the interconnections between all of those, as well as currently, and then how do we solve the problems. I was really appreciative of all of the panelists' orientation towards not just sitting with unsolved problems, but taking them as challenges and eventually as opportunities to build a new economic system. And we're kind of right halfway there. So we'll continue the discussion after a 15-minute break with Aaron Levine of World Centric, and the moderator will tell you about her background, as well as Steve Kafka, who's been in the biomass and the biorealization business for many years with UC Davis, but is going to be talking about manure feedstocks. And then also Hussein, who's been our technical person, is PhD student, and we'll be talking about utilizing dairy manure as a biofertilizer. So we'll see you back here at 11 p.m., 11 a.m., excuse me, not p.m. Take care. Talk to you. See you all soon. Kevin, do you have the recent list of the bios?
Yes, I'll be talking through
Great.
that in the presentation.
Perfect. Okay, great.
How you doing, Kevin?
Oh, good. Great to hear
Wow.
from you. Glad you're able to be in the session.
Still there, thank you.
Yep, I'm definitely ready to be spotlighted, Hussein.
I found somebody wants the list of all the other attendees, and so they can't actually access it now, but I could email them the emails from Eventbrite. What do people think? Do you think we should send it that way?
I think sending it in multiple ways would make sense.
Okay.
I'm sorry, is Jenny or Megan available to answer a question in the Q&A about PFAS coding?
Did you say my name?
Yeah,
Megan?
Megan? Yeah.
Yes.
Mhm.
Oops.
Can you get into the Q&A and see the question that's to you?
Yes.
Okay.
There are concerns what you ask.
You can answer that by typing in an answer.
Okay.
That
Cool.
would be
I'll do
great.
that.
Super. Thanks.
All right, so we have reached 11 a.m. and it's time to start session 2. So first, hi everyone, I'm Kevin Esslinger, and to give you a little background on myself, I specialize in cows and cars at the California Air Resources Board over the last 15 plus years, as well as during my environmental studies within transportation and animal science graduate programs at UC Davis. Beyond transportation, greenhouse gases, and livestock, I manage a number of grants, including the California Clean Biomass Collaborative that you heard about during the first talk today. The collaborative is facilitated by Cal Poly San Luis Obispo with the PI Professor Mike Picola, and is working toward the near elimination of agricultural burning in the San Joaquin Valley by 2025. So for session 2, we're continuing on the same theme of bioresources feedstocks from session 1. For all attendees, remember to use the Q&A feature on the bottom of your screen to post your questions throughout the presentation, so we can ask questions at the end of each speaker's presentation, as well as at the end of the session Q&A. So I'd like to introduce our first speaker, Erin Levine, who is a resource recovery manager at World Centric. Erin has been involved with resource recovery for 18 years, and in the last decade has focused specifically on the sales and marketing of finished compost. She has supported commercial compost facilities throughout the West Coast and has worked closely with the end users of compost, particularly the agricultural industry. Erin is a certified composting professional through the U.S. Composting Council and a certified compost programs manager through the Solid Waste Authority of North America. All right, go for it.
Thank you, Kevin. Okay, let's share my screen. Does that look okay?
Yeah, but you need to be highlighted by Hussein.
She is.
Oh, okay. I'm not seeing her picture, her video.
I'm seeing the presentation just fine.
Okay,
You're good to go. The webinar is spotlighting Erin. You can see her.
great. Okay. So hi again, everybody. I'm really happy to be here today. This is actually my first CBA symposium. I am the resource recovery manager at World Centric, and my primary focus is on claims and certifications, but truly ensuring our food serviceware is properly discarded. At WorldCentric, we also have our own product development and R&D group, and their primary focus is to create better performing and regenerative compostables that are designed with the end of life in mind. So I wanted just to start by sharing a little about WorldCentric's background and history. And if you're familiar with WorldCentric, then you know that we're a giving organization, but you might not know that we have roots as a nonprofit. So WorldCentric actually started as a nonprofit to raise awareness of humanitarian and environmental issues. In 2005, we began selling compostables to fund the organization and our outreach funding. But the business grew, and WorldCentric eventually converted to a social enterprise for profit, and shortly after became the first certified B Corporation, in addition to being a California benefit corporation and a minority certified business. So with sustainability and impact in our DNA, WorldCentric continues to donate 25% of profits year over year in a combination of grant funding, product donations, and also carbon giving. And our funded projects are highly vetted to generate as much impact as possible. Some examples of our projects focus on extreme poverty, sanitation, healthcare. We really aim to drive systematic change to achieve self-sustainability within communities. And in 2021, we gave over $1.8 million and are on track to double that for 2022. It's pretty exciting. So WorldCentric is committed to our mission of being of service to the people and planet. So we have committed our resources to being active with these organizations. In addition to our giving program, we also commit 1% for the planet. So 1% of our annual sales goes directly to approved environmental, sustainable nonprofit organizations. And further, being a part of US Composting Council and of course ACP and the California Compost Coalition is really vital because we're huge advocates for closing the loop and ensuring our products are properly discarded. And lastly, being a member of the Sustainable Packaging Coalition, in particular participating with the Compostable Packaging Collaborative, really helps keep us informed, and we really value being a part of the bioeconomy. Because of WorldCentric's strong sustainability commitment, we source materials as responsibly as possible. In fact, 95% of our eligible paper products are from FFC certified sources, and we're replacing wood fiber with bamboo and sugarcane where possible. It's also critical to us that our products are sourced ethically and made with integrity. So further, we work with USDA's BioPreferred program to test our products for their bio-based content under ASTM standards. We also test our products under the ASTM and EN standards. My colleagues from Eco Products alluded to some of these and explained a little about the claims on commercial compostability. We do work with BPI, CMA, and TÜV to verify our products, to verify our testing and then certify or approve our products. And due to the strict thresholds they have for PFAS and for ecotoxicity, we know that what we're bringing to market is safe for the consumer and will be beneficial for composters. So now I'd like to talk about the future of materials and considerations when designing foodware with the end of life in mind. So the first thing to consider is what the product is made of. Is it a material of natural origin? Is it bio-based? Is it an agricultural byproduct? Basically, is it naturally occurring biopolymer that's not chemically modified? So considering the material and how it's and how it will ultimately contribute to the nutrient cycle is really critical. Materials of natural origin will be positive contributions since they ideally have zero toxicity and have minimal processing. An example of this is like a coconut shell. So one could take a coconut shell, break it open, clean it out, use it as a bowl. That might sound great, but might not be realistic to make the product suitable for all applications, nor scalable, nor at a price point that consumers want to pay, or acceptable for all compost systems. So let's dive into some of the limiting factors I mentioned. So first would be the functionality. One needs to consider how people are using the product. For disposable food service ware, the average use is more or less about 2 hours. So an item will need to maintain its integrity for the duration of use. It needs to withstand heat, oil, and moisture, depending on the application. It needs to safely perform, like not melt in your hand. The surface needs to be acceptable to come in contact with food, so it needs to comply with FDA food contact regulations. Next, we're making a product that's scalable. So we would ask yourself, is it feasible to produce items efficiently, in high quantity, and are the materials readily available? Basically, can you meet the market demand? Of note here that producing foodware is energy and water intensive, so minimizing your impact for those fronts should be a consideration. Next up would be price, of course, is price. Can this product be made, shipped, and sold at a desirable and competitive market rate? And last but not least is the end of life. So is it reusable? And if not, how will this product degrade? Is it suitable for a commercial compost system? Will it meet ASTM standards for compostability? Will it easily decompose in a home compost system? So will a composter consider the material contamination, or is it truly beneficial feedstock to the composter? There are a lot of considerations in designing a natural, functional, scalable, fair-priced, compostable foodware item. So now that we've talked about the considerations, I'd like to, design some considerations when we're designing optimal food serviceware. So I'm going to give some examples of materials and products and just some things that have come across my desk. Well, let's start with plastic straws. So plastic straws, they're banned. They're in many communities, and for a good reason. They're really challenging to recycle. They can persist in the environment. They can pollute the ocean, and eventually they may become microplastics. World Centric actually stopped making even bioplastic straws since they're so pesky and they're not designed with the end of life in mind. So alternatively, there's a paper straw, which is derived from material of natural origin, paper, and it's preferably sourced from a sustainably managed forest, but it's not minimally processed. There are several steps involved with manufacturing, like pulping, forming, gluing, not ideal in that regard. And it functions for a short period of time, but that's again compared to a traditional petroleum-based straw, which lasts indefinitely. Is it scalable and at a desirable price point? Yes and yes. But what happens at the end of life? So being derived from paper, especially since most become soggy with drinks, they will easily degrade. And if compost is, they will easily degrade and compost. And if it's just, especially if it's I'm getting stopped up here. If it's discarded in a compost system. However, it may contaminate a recycling stream due to being food soiled, and may easily get discarded in the landfill bin and sentenced to a long life of slow anaerobic digestion. And just of note, if any biopolymer ends up in a landfill or our ocean, we've lost the value that could have been recaptured by the organics processing system. So alternatively, coming to market are pasta straws. Yes, straws made from pasta. I'm not endorsing these, and World Centric is actually not even making these, but I just find them intriguing, so I'm sharing them. So the question, are they material of natural origin? Yes, and not heavily processed. Do they function? Yes, but best with cold beverages, and they tend to hold up and not disintegrate for a fair length of time. They might be a bit brittle and would need to be handled with care, but overall pretty sturdy, and bonus, they're edible. Are they scalable? I'm not too sure exactly, but they seem to be, since they're trending and they're popping up in more restaurants. And a bonus there would be if local manufacturing, or if these could be manufactured locally, it could drastically reduce the carbon footprint from transportation on these items. Price point, from what I can tell, they're offered at a pretty competitive market rate. And then end of life, full material, material of natural origin, inherently compostable, would positively contribute to the nutrient cycle. Again, just some examples of alternative foodware that's designed with end of life in mind. More interesting items that I've come across lately that I think are going to be trending in the future that might be worth a mention as potential bioresources for packaging. One is mushroom foam. So mushroom foam is coming, it's made from hemp hurd and mycelium, and it's a great material of natural origin, but some challenges, it's not quite scalable for commodity use or competitively priced, but again, fully plant-based, compostable, great alternative. Next would be chicken feathers. Chicken feathers are an excellent source of keratin and a fibrous protein. It can make for a wonderful biopolymer. Shrimp shells, great source of chitin, a fibrous polysaccharide. An example of this is the company Cruise Foam, who came to market with replacing polystyrene using shrimp shells. Next, peanut shells. They're made of cellulose and lignin, and it's a really innovative example of an agricultural byproduct that can act as the bioresource for fiber paperboard. Not pictured here, but worth a mention from my R&D team is cornstarch foams, rice hulls, and hemp, all pretty interesting materials. Generally, trending is materials derived from cellulose, chitin, and protein. They seem to be, to me, the future. I think it'll take some time for investment in research and development to refine these materials as viable biofeedstocks for compostables, but I'm really grateful to all the creative thinkers and innovators out there doing all the work. Speaking of innovators, so I'd like to shift my gears and tell you a little about how World Centric has taken strides to have made the fight against PFAS is real. So PFAS for years was used in molded fiber items to act as an oil and grease and moisture barrier. It's now banned in a few states and potentially may be banned federally soon. So in order to comply, World Centric decided to invest in research and development to come up with our own proprietary solution that we call Leaf Plus. So we're really proud and excited to be bringing this solution to the market this year. And you might ask why we would pursue our own solution when there's already some easy fixes out there available. But I think it stems back to original learnings with oil and grease barriers that we might have what's regrettable. So as you'll see on the next slide, it takes a lot of time and resources to create a solution with R&D, and there's always risk involved. But as a triple bottom line company, we wanted to be able to guarantee our customers a safe and functional, non-regrettable replacement to PFAS. So as we know, PFAS has functioned as the oil and grease barrier. So marketing a product that can withstand the high heat and grease and oil, yet also be plant-based, huge challenge. So as important as it was to our external assurances, as well as it's also important to us internally to make a product that's safe. So by creating our own solution, we were able to control the vertical supply chain and to ensure ourselves and our customers that we're making a fully plant-based product or solution through and through. So we have successfully tested the final product for its bio-based content, of course, for its total fluorine, so PFAS-free, and for its compostability. And here's a glimpse at the work that went into produce our own proprietary solution. Our R&D team started the work on Leaf Plus in 2017, 2018, that time frame. So, and then 2019, we had focused in on the basis for Leaf Plus, and we were conducting successful lab trials. And then in 2020, we submitted our patent and we began factory trials last year. And this year we're beginning production. It's really exciting, using the solution, which will start with retail plates and very soon to all of our molded fiber products. So going back to why we would pursue our own solution, we really wanted to ensure for, again, ourselves and our customers, we're providing safe, non-regrettable solution. So we began to look for third-party validations. And this is when we learned about Chem Forward and what's called the SAFER designation. So we participated in a study with Chem Forward, and they partnered with NSF to do an assessment on our new solution for toxicology. So it was a chemical hazard assessment. So it was evaluated and it very easily passed. Although our solution is proprietary, we can boast about the safety to our customers and composters because of this. So to conclude, I'd like to just mention, so I'd like to say that aligning material innovation with recovery infrastructure and then capturing value should be a priority when you design circular products. It all starts with sustainable, or better yet, regenerative materials. Materials of natural origin with minimal processing are optimal. And really further considering what the materials, their carbon uptake and the fertilizer usage is big as well. Next up would be functionality. The final product needs to serve its purpose for its intended use. However, consumers also really need to shift expectations. Like the example I gave with the paper straws only lasting a short period of time, consumers that want to make a more sustainable choice on foodware should either go with reusables or they should start to expect a time limit on using compostables. Next would be scalable. So agricultural byproducts that are truly unusable, that are considered quote unquote waste, should not be treated that way, instead as a resource that really needs to be recovered. It helps if the materials are consistent and we can make the feedstock readily available. Next is price. So if we can recover the ag byproduct resources and minimize processing, it should really allow for less production costs, and keeping it local could keep the shipping down. Hopefully then that would allow the final product to be more price competitive. And finally, being inherently compostable. So bio-based, something that looks and feels earthy, not synthetic, not plastic feeling. Could we really reduce the confusion and chances that the items will make it into the commercial compost system, or even better yet, a home composting system. World Centric was one of the first food serviceware companies to come to market with unbleached molded fiber, because it requires less refinement and chemical processing, in addition to preventing any potential water source contamination. Although not as aesthetically appealing, we wanted to really break the mold. I'd also like to note that setting the standard on acceptability nationally, along with consistent labeling and will aid in the contamination reduction and ensure more biomaterials are getting captured and recycled. So in summary, it takes resources, innovation, and willingness to experiment with materials as one designs a product with the end of life in mind. So as someone I've worked directly with agriculture over the last 10 years in California, what I would hope is that as a state, we deeply consider using local renewable materials of natural origin as bio feedstocks to aid in the removal of all this unnecessary plastic waste. I also, would hope that foodware can act as a vessel for food waste being diverted from landfills, and it will recirculate in our economy and benefit California by building healthy soils and sequestering carbon for years to come. Thank you.
Awesome. Thanks so much for the informative presentation, Erin. So yeah, a lot of different products and approaches and philosophies and environmental impacts. Definitely very interesting. And just bringing up even the origin story of World Centric with the sales of compostables for funding of your original mission, and designing the full product life with that in mind, from product qualities and functionalities, and even the added value that you want to capture of the nutrient cycling at the end of life. I'd definitely like to hear more, and I have some thoughts, but we'll first start with a couple questions that we received.
Sure.
One of them might have already been answered in your presentation, but the question was asked whether vegwares are PFAS free. Do you know that?
Oh, I can't speak to vegwares.
That was for a prior panelist.
Oh, gotcha. Okay.
For Megan. But I think this next question about compost subject to PFAS, that might be something she could answer.
Yeah, absolutely. So Jacob Collins asked if composters are subject to PFAS or PFOA future regulations, what source controls are being discussed to reduce potential point sources from entering the inbound stream?
From my understanding, composters aren't subject to it yet, are subject to tests for total fluorine in the final product. And I think that there's some challenges with actually the testing protocol. I'm not an expert on it, but I've heard that for total fluorine and testing specifically for PFAS, then really the test that exists is for water sourcing, water contamination. But I know it's been talked about a lot amongst composters because of obviously the concern that it can carry through and migrate to food, and there's a big concern. But of course, yes, addressing it upstream and it being eliminated So AB 1200 coming online in California starting in January will takes that out of the equation in California, because it will no longer be allowed to be sold or distributed in food serviceware. So that's one pain point that will be eliminated. So hopefully then the reduction, we won't see it in composting facilities.
Oh, great. I think there might be one more question that came in. No, just a previous question. So I was kind of curious to dive into if you have much experience on the B Corp side of things, because I think in our kind of science field, we tend to not dive into kind of these business nuances of how these things kind of start and can come to be. You said you've been with the company for quite a while. Do you have a perspective on how maybe a broader picture of like B Corp playing a role in kind of getting all of our goals met?
Well, I've actually only been with World Centric since January. So
Oh,
this-
January. Oh, okay.
yeah. So I'm just 11 months in now. So it's my first time actually working with a certified B Corp, but it's been a real pleasure. And we are in the process of doing they do a review every few years, and we're actually going through that right now. Overall, it's been and then like from an ESG standpoint, does it align with goals all the way around? Absolutely. And I feel like the auditing process is pretty diligent and yeah, I'm not sure. What do you mean by your goals? Did you want to clarify that?
Oh, just kind of like the general goals of what we're all here for.
Oh,
Yeah.
right. Yeah, I know it's definitely I find that it's a benefit. I mean, yeah, I don't know if I want to say too much about it. I know there's other B Corps on here as well, but
Yeah, and actually it's something we could probably bring into when we all have our Q&A from the session, and then at the end of the conference symposium on tomorrow evening or afternoon. So cool. Well, thanks so much for the presentation. I think we'll probably move on to the second speaker. So thank you so much.
Share my screen.
Yeah, you can start, and I'll give you a quick introduction, walk through your bio. I am happy to introduce our second speaker, Dr. Stephen Kafka, who I've actually also worked with previously at CARB in this dairy arena. And he's a professor of extension and a specialist in the Department of Plant Sciences at the University of California, Davis, and director of the California Biomass Collaborative. He has advised several state agencies on biomass, energy, and sustainability issues in California, including the California Energy Commission and the California Resources Board. He has also participated on several national and international bioenergy studies, including a National Research Council's committee producing the recent report titled The Renewable Fuel Standard, Potential Economic and Environmental Effects of U.S. Fuel Policy. Current biomass energy crop research includes winter annual oilseed crops like canola, camelina, and castor, sweet sorghum, and sugar beets, and several manure management projects related to the state's short-term climate solutions plan and its dairy digester research and education program for alternative manure management programs. Current work focuses on alternative winter forage crops for dairy producers and manure nutrient recovery and reuse technologies and policies. So take it away, Dr. Kafka.
Thanks, Kevin, for the introduction. Can everybody hear me? Is that coming through? Okay.
We can.
Yes.
Okay, good. All right. So I want to talk about some results from a recent report funded by the California Department of Food and Agriculture on dairy manure nutrient management, particularly on recovery, removal, and recycling of nutrients, especially nitrogen, from dairies to non-dairy farms. Let me just start briefly by talking about the regulatory problem that dairies face, or the problems, probably should be plural. The state's dairy industry is faced with what are effectively two very difficult challenges. One is on improving groundwater nitrate management. There are lots of places in the dairy regions of the state where there have been exceedances of groundwater nitrogen contamination. And that's partly related to the presence of those dairies and nutrient management, particularly from manures in those areas. They have a second challenge, however, which is actually related, and that's more recent in origin, and has to do with groundwater availability for irrigation and all water availability for irrigation in general. It's likely to decline for dairies, and that will interact with their ability to manage nutrients. So economic pressures in the dairy industry generally, not just in California, but generally in the United States, and you would argue probably in most developed nations where you have modern agriculture going on, modern dairy agriculture, tends to favor or tends to result in an increase in herd size. So this is from the USDA study, milk productivity by herd size class. And productivity tends to improve with scale, or at least with size of dairies. So those are real economic forces. That comes from technology, it comes from prices, both for materials purchased and for prices for products received. In any case, it's been an ongoing force that's affected dairies and affects dairies, particularly in California as well. So in other words, there's always this pressure to have a larger herd. However, while you have economic pressures to increase your stocking rates on your farm, these other regulations that I've just mentioned, CV salts and the nitrates program and SGMA, Sustainable Groundwater Management Act, tend to force dairies, or at least put pressures on dairies to at least moderate, or in other words, adjust somehow for those higher stocking rates. They're conflicting pressures, and it's a significant challenge for the industry what to do. Our study focused on particularly the high priority nitrogen management zone areas. These were organized under the CV salts program to try to address groundwater pollution for both salts and nitrates. And 5 regions in the Central Valley were identified as high priority regions where farmers in general and dairy producers in particular have to help compensate for groundwater nitrate exceedances financially. So they tend to be the highest priority areas where the problems have been identified as the most acute. There are other priority 2 areas which will eventually be regulated in the same manner. But our study focused on these red zones, or these 5 nitrogen management zones in particular. It turns out that the majority, there's a very large number of dairies, the majority of the dairies in the Central Valley region are located in these zones. Now, there's a very large literature, and there's been a lot of work done in California, but certainly elsewhere as well. But let's focus on California, particularly on nitrogen balances, whole farm management, whole farm nitrogen balances, and nitrogen balances for the dairy industry as a whole. And generally, they all more or less agree that there is a large amount of unaccounted nitrogen. In other words, nitrogen that either has been lost to groundwater or lost some other way. When you look at the balance between the amount of manure that's exported off the farm, the amount of manure nitrogen applied, and the amount of manure left over based on what cows actually produce on a daily basis. Interesting study that relates to that was a nationwide analysis, a multi-regional analysis that Rotz et al. Just published a few years ago, and identified sources of ammonia emissions, for example, in different areas. You can see how they vary across the country. The arrow points to the region where California dominates. And you can see ammonia emissions from housing are quite large. It's not the only pathway in which nitrogen is lost, but it just indicates that, at least in our region and our climate, under our conditions and our types of housing, that's a significant source and probably goes into the unaccounted nitrogen category. But so also does losses to groundwater. So let me describe briefly some of the results from our surveys from the database that we were able to acquire from the Central Valley Dairy Regional Monitoring Program group that was involved in helping to organize mitigation programs for the priority 1 nitrogen management zones and other areas in the valley. But first, a caveat. When we're thinking about when we study manure, when we manage manure, when we try to regulate manure, and this is not just true for dairies, but it's true for all manures, and especially in concentrated livestock feeding operations, but manure in general, even in grazed pasture-based systems. Manure is really a very dynamic material. It's living. It's full of living organisms that are constantly active in terms of causing transformations of the materials in manure, especially nitrogen is dynamic, and you can have transformations to all kinds of forms of nitrogen. So depending on how you manage it, you get different types of emissions. There's no way to avoid all emissions, and trade-offs are unavoidable. You can have nitrates that result, you can have nitrous oxides that result, you can have inert nitrogen N2, which is the common gas in the atmosphere. You can have ammonium and ammonia emissions. And so those are all possible products and sources of loss or sources of reuse. And the other thing to keep in mind to start is that cows make a lot of manure. It's something, if I remember correctly, around 150 pounds per cow per day of wet materials. They don't take Christmas off. They don't take New Year's off. It's every day. It's a very large amount of material. And so the more cows you have on your farm, relative to the amount of land that you have to apply manure, the larger the nitrogen surplus will be. And you can see basically as you go up, this is simple, just a simple linear relationship between the amount of nitrogen produced per year for cows plus replacements or cows alone, just simply increases linearly depending on how many cows per acre you have. And so at large stocking rates, the amount of nitrogen in surplus can be quite large, at least on the basis of the amount of nitrogen in the raw manure produced. So this is based on the data set that we used that derives from about 2018 and 19, created, as I said, by the Central Valley Regional. Based on, this is publicly available data, but it has to be kind of organized to be able to use, and we were able to get it from the Central Valley Regional Dairy Water Monitoring Coalition. Anyway, the number of dairies in these high priority nitrogen management zones is roughly 150. The average number of cows per dairy is roughly 1,460. The average number of acres available for manure application was 554. But you can see that there were, across these districts, quite a bit of variation. In fact, the number of farms was highest in the Turlock nitrogen management zone. You can see what the average stocking rates are for these farms. Now, I also put in the medians. And so roughly half the farms are below about 3.3, 3.4 cows per acre, stocking rate, cows plus replacements per acre. But and then the other half are larger. So you have large farms that are contributing to the higher average than the median. This gives you kind of a distribution of the mature cow population per dairy. And I don't know if my arrow is visible on my screen. Anyway, there are certainly some large dairies out here. These are kind of anomalous data points. You can see it's mostly skewed. The largest population of dairies is basically 2,000 cows or so or less. There are a number of them that are larger, but most of the dairies are here. And there's quite a few dairies that in the valley still that report less than 3 cows, plus or minus 3 cows per acre. So that's the very way the population actually looks. This kind of information points out that it's not just a homogeneous dairy industry. It's highly diverse. And that diversity is going to affect how much nitrogen, for example, or phosphorus, or both nutrients or compost can be recovered from these farms, and how far it has to be moved and how it can be used. Let's see if I can do the next slide. So I broke this down a little bit further. And by the northern part of the region, that's the Turlock, Modesto, and Chowchilla districts. And then the southern San Joaquin Valley would be the Cahuilla, Kings, and Tule districts. And so here's the mature cows per farm and mature cows per acre. And you can see there's, it tends to be the case in these two regions that the farms with the smaller number of cows tend to have the higher stocking rates. Why might that be? Well, these probably are farms that couldn't readily expand their land area, but to stay in business had to add cows. As I remember that first slide I showed you about the pressure to have larger numbers of cows. So the high stocking rate issue tends to be concentrated on the farms with a smaller number of cows in the state. This is again mature cows per acre and the number of dairy farms when you look at stocking rates. So the stocking rates are 0 to 1, 1 to 2, 2 to 3 cows per acre, up to 9 to 10 plus. There are some dairies with many more than 10 cows per acre. And again, it's divided by the northern part of the San Joaquin Valley and the southern part of the San Joaquin Valley. And I think what's particularly interesting here is the Turlock district, because you can see that there's quite a large number of very high stocking rate farms. Remember, those are, again, smaller farms that were there, probably for historic reasons. They're there. And you can see in the southern San Joaquin Valley, a little bit left skewed, but a little bit more evenly distributed. So these kinds of issues will affect, the ability to deal with these surplus nutrients when you have large numbers of very high stocking rate farms co-located, for example. Now, what do we mean by surplus nitrogen? From the dairy perspective, the surplus manure, and we need to keep this in mind, manure is a very valuable fertilizer. It's been valued historically over all time and in all places as an important source of nutrients for crops. And so important to management of nutrients on dairy farms is crop uptake. And these are typical silage systems that you see in the San Joaquin Valley, where you have a cereal silage grown in the winter and a corn silage grown in the summer. You might have a 2-crop system and you might have a 3-crop system. The yields, the number of crops and yields achieved affect the amount of nitrogen in surplus. So the higher the crop yields and the larger the amount of biomass produced on the farm that's taking up and removing or recovering nitrogen, the lower the surplus might be for any given amount of manure produced. So to account for all this, and I have the equations and the assumptions, you have to make a lot of assumptions to be able to do these calculations. And then I have in supplemental slides at the end of this presentation will be available for you. You can look at some of those assumptions and equations. So basically, here's cows per acre, stocking rate on the left, the amount of nitrogen that would be generated on a raw excreted from cows and replacements. And you can see that actually, if you have a low stocking rate and a fairly reasonable crop uptake program for crops, you might actually be in negative balance. Because not only you can't use these raw excreted values because you have losses of manure during collection and storage. And we mentioned, ammonia losses, for example. Also, there would be that's a particular important pathway for loss in California dairies. And so the amount that's excreted isn't the amount that can be applied. You have to actually collect and conserve that. So if you make assumptions about how much is collected and conserved, either on concrete and freestall dairies or on open lot systems and corrals, you come up with different numbers of amounts of nitrogen that is surplus beyond what the crops are estimated to need and beyond what you're allowed to apply by regulation, which is about 1.4 times crop need. So we decided to use a break-even point of about 4 cows per acre, knowing that in general, 4 cows per acre or greater stocking rates are going to have surpluses that typical cropping systems will not be able to utilize fully. And the other thing that we're trying to think of is where, if you were a technology provider, where would you go to find large amounts of readily available surplus nitrogen or phosphorus that you might want to recover for redistribution to other uses? And those would generally be these farms with the higher stocking rates. So here we are breaking down, again, the 6 districts, the northern ones on the left, the southern ones on the right. You can see the distribution of farms and the percent of distribution of farms by stocking rates. I didn't go beyond 10, as I mentioned, if it was 10 or greater is what that means. And the percent of cows, percent of dairies with stocking rates greater than roughly 3.4 cows per acre at the bottom. There's a lot of data here to see, but you can see that Turlock has, there's a number of dairies. There's a large percentage of dairies in the Turlock district, for example, more than half that are above 4 cows per acre. Also true for Modesto, for Cahuilla, Kings and Tulare are closer to 50%. And so here's the surplus nitrogen calculation. There's a lot here. And really, when the report, we're going to have that report available shortly on the biomass website, and there's a lot more detail in terms of the methods used for these calculations. But I broke it down between lagoon manure nitrogen surpluses and solid manure nitrogen surpluses. And you can see by district the number of dairies, percent of dairies, and the acres receiving manure. And then you have manure nitrogen surplus in terms of tons per year in the range between freestall and open lot dairies. Open lot dairies are going to have predominantly solid manure collection. Freestall is going to have predominantly liquid manure collection. And then I have a solid manure category here as well. I think the most important point to make, or one of the important points to make and takeaways, the dairy industry. This shows you that how diverse dairy industry is, and that optimum nutrient management solutions are not likely to be the same for all dairies or in all regions, depending on how dairies are distributed and land availability. So we're going to need real creativity in policy and regulation to support diverse solutions to this nutrient management problem. It's a real challenge for us all, especially in the regulatory community. So here you can see, where you have these clusters, for example, of dairies, which are all near each other, and you have very high amounts of nitrogen, or in this case, I just have the nitrogen figure here, where, you're not going to be able to easily distribute surplus manure, solid manure at least, to your neighbors, because after all, they don't need it. And so you have to go past that. And so here's a figure that we generated that shows potential crop demand, which is the focus, for nitrogen and phosphorus, in land areas that are near where these dairy clusters are. And this comes into play when you're thinking about distributing solid manure in particular, which has transportation and application greenhouse gas costs plus direct costs. And so I've circled the areas, that I showed on the previous slide, where you have clusters, large numbers of dense clusters of dairies, and where the demand, the non-dairy cropland nearby is. And it gives you kind of a visual picture of where, how those materials might be moved. Let me just talk briefly to wrap up about some of the technologies that we evaluated in the report. They were particularly focused on the liquid fraction. Now, there are a lot of manure treatment technologies, and I recommend you take a look at the Nutrient website. It's a rather remarkable website that has done a great job of trying to categorize and compare nutrient management technologies. So ones that are highlighted here in bold are the ones that we focused on, with the exception of struvite crystallization. I decided not to put that in at this stage in this report. We only had about 6 months to do this report, so it's just a first cut. And this kind of gives you an idea of, as I said, manure is complicated. You have all kinds of different ways in which manure might be handled on these diverse dairies. That's a function of how new the dairies are, and stocking rates, their locations, and so on, and what technologies and systems they've adopted for doing this. They vary all over the state. You have a lot of organic dairies with just simple manure pits and little, sometimes solid separation on the coast. And then you have these rather more high-tech dairies in the Central Valley that have more advanced manure management systems and tend to rely on lagoons, and that's where the anaerobic digesters, by and large, are being employed and developed. And then you can have secondary processing, post lagoon or pre-lagoon, sometimes, depending on whether you have an anaerobic digester or not. And there's various ways in which those materials can be processed. And then you can have recovery systems, and there are different kinds of recovery systems. So, I tried to kind of break them down here in solid and liquid systems, and you can have surplus nutrient reduction, recovery, and reuse, or basically reduction would be composting. Composting actually loses some nitrogen from the raw manure. You could have technologies like pyrolysis and so on, gasification. Recovery and reuse, you could simply sell your dried corral solids or your compost. For liquid manure, there's things like algae raceways, duckweed-based systems. We looked at anaerobic digestion, evaporation. We looked at ammonia stripping and chemical flocculation and membrane systems. And then you can have nitrification and denitrification, like vermiculture. Vermiculture basically denitrifies large amounts of nitrogen from the liquid manure fraction. It goes back to the atmosphere. These are flow diagrams for the technologies that were evaluated. I'm going to go a little quickly here. You can look at them later. I mean, you can't, it's a lot to kind of take into account. Each of these systems has different ways in which they manage solids, in this case, liquid mineral materials. These are some costs for the Trident, which is a kind of a solid nutrient. They were based on a study from Indiana with a 7,000 cow dairy. This technology, you can see the dollars per cow per year. And then there's the vermiculture or biofiltro costs, and you can see again dollars per cow per year, which are less. The Sedrin Barcor system business model anticipates rather minimal costs for the dairy. They think they can recover the cost of operation and capital and operating expenses from the sale of high quality organic organic nitrogen materials. That is yet to be tested. There are some systems that are developing around the country where they're trying to develop that model. So we don't have costs for those for that reason. Now, each of these systems has also some solid materials as well as some liquid materials that come out of it. And the use of those materials are either more or less important as products, but they're largely untested. And so as part of our work, we have started some initial testing of the fine solid materials or the concentrated solid materials that are byproducts or sometimes the direct products of those systems. So we have compost, we have vermiculture compost, dissolved ammonia flotation, LWR is much like that product, and then the Sedron fine solids material. And these are the characteristics of the materials that we received from the vendors for testing. You can see that they have different carbon and nitrogen amounts, they have different carbon and nitrogen ratios, and other characteristics. This work is still ongoing, but this was these are short-term results from about the first month's mineralization studies, laboratory tests at different temperatures and when added to clay and sand soil types. And basically, the fine solid materials from dissolved ammonia flotation, the Sedrin Barcor product, mineralize at a much higher rate. They're also temperature dependent, but at a much higher rate than the typical compost or the vermiculture compost, which has some wood chips in it still when it's finished material. So this is important information because if we want to know what the value of these products are as fertilizer substitutes, then you have to have some idea of what the availability of the nitrogen in the system might be when they're used. We also did life cycle assessment because it's important not only to evaluate the nitrogen recovery systems, but since, as we all know, the state is very focused on greenhouse gases. And so what might be the greenhouse gas consequences of using these manure handling systems and for nutrient recovery and reuse. And so these are basically the mass balances. More detail again is in the report by the waste treatment system. It's kilograms per kilogram dry matter. And so that the scale is comparable across them all. The aqueous ammonia distillate, in terms of nitrogen replacement value, is considered equivalent to commercial fertilizer. It is, after all, simply ammonia. And so it's similar to ammonia fertilizer or to urea fertilizer. And then you have comparable nitrogen replacement values as estimated from the literature and to some degree from our work, which is still premature. And then these are emission factors, again, kilograms per kilogram dry matter with respect to methane, nitrous oxide, and nitrous oxide. And these systems are compared here in this figure. And, there's more ammonia from composting than there is from these systems, more methane emitted from these systems than from composting from these systems. So there's an improvement in that case. And 2.0, we don't have a value for windrow composting. There's a large number of values out there for that purpose. They're roughly comparable, all of them, with respect to nitrous oxide emissions as these things go. These are the the flow diagrams that were used for life cycle assessment for the systems. And I won't really dwell on them. Basically, you have a production side on the left, you have a treatment side in the middle, and you have products for distribution on the right for each of them. And you can see the analytical boundary for the system analysis for each of these systems that was used in life cycle assessment. This summarizes a lot. It's a little complicated, but you can see basically the red and brown colored bars are tons CO2 equivalent per year from the nitrogen management zone dairies. This is the actual dairies in the that were the data from the dairies that are in the system, and you can see the nitrogen, the CO2 equivalent emissions from the applications of these treatment facilities to potential surpluses, again, for about 4 cows per acre surplus values on these dairies based on the actual dairy stocking rates by nitrogen management zone. The red and yellow colors are without anaerobic digestion. In other words, you have a lagoon and or if you have a open lot system, you have your solids and system, and then the blue lines bars are if you have an anaerobic digester, and then you also add these technologies to it, and you can see really the big difference among them for the most part is with and without anaerobic digestion with respect to greenhouse gas emissions. The other thing that's important, if we have solid products, so you can have, remember I mentioned that we looked at the mineralization of these recovered nitrogen products. You could also have composted, or in this case, solid manure, transport costs, basically when you're going through these treatment systems, you get much less solid material, and it's much more concentrated in terms of its, or at least fermentable material, in terms of its nutrient content. The dairy herd, this graph increases dairy herd size from left to right, and you can see herd size also on the left, and there's no real relationship between dairy herd size and transportation costs, really as a function of location in the valley. So this shows that, and this is just for, on the left, is just for the Trident technology and composting as examples. These are transportation costs, potentially to move from the dairy locations to nearby cropping land that would be susceptible, be potential customers or users of the nutrients and or the compostable materials. And so even Turlock, remember I said that's where you had these large surpluses and high stocking rates, but there's a lot of available cropland that's closer in that case to the centers of manure, nitrogen, and phosphorus deposition than there are farther south, at least in our analysis. So just in conclusion, I've gone on a little long, I'm sorry, but we did focus on the potential for surplus nutrient recovery and removal on dairy farms. The dairy industry is really, it's not monolithic. The farms in the state are diverse in structure, cow numbers, and manure management systems. So there's large regional differences. The farms with larger stocking rates have large amounts of nutrients on average can be recovered by annual forage crops and by nutrient recovery systems based on the data used here and so on. So that's why we use these higher stocking rate farms. If you're going to put a recovery technology on a farm, probably is most beneficial to put it on a farm with large amounts of surplus or in the middle of a cluster of farms with large amounts of surpluses. There are lots of different technologies out there, not all of which have reached commercial development. We picked 3 that did have already commercial development, at least if not in California, elsewhere. Each have benefits and disadvantages and involve trade-offs among costs, amounts and types of nutrients recovery, and potential for non-dairy farm use. They mostly reduce greenhouse gas emissions, but less than anaerobic digestion. So to maximize greenhouse benefits, I think they're best deployed in sequence with AD systems. But remember also that there are surpluses in the form of solid manures, and particularly on the open lot dairies, which collect less manure on concrete, therefore have less liquid manure. That was a design feature of an open lot dairy. So there's fewer ways to treat solid manure, and widespread distribution commonly comes with high greenhouse gas costs for transportation and application. So there's a challenge that remains there. I know we're going to have a speaker next who's going to talk about that, which is very helpful. And really, to do this well and preserve the benefits of the dairy industry, we're going to need a very creative and sensitive regulatory process to optimally improve manure management. I think there's not going to be one solution that fits all uses. Okay, that's all I have.
Oh, great. Thank you so much for that. As a dairy person myself in grad school and in career, it was really helpful of walking through so much detail on that. And I could talk about this forever. I'm looking at the time, and I noticed we didn't have any questions in the Q&A. So what I will do is reserve my questions until we have our kind of end of session group Q&A. For this presentation, just to make sure we give enough time for the next speaker. And I assume we'll have at least 10 or 15 minutes at the end to kind of round up everyone and ask final questions. So thank you again, Dr. Kafka, for that. So the next speaker, Hossein Adelanti, is a PhD student in the Department of Biological and Agricultural Engineering at UC Davis. He is advised by Professor Roihong Zhang. His research focus has been waste management and recoupling value in food waste and agricultural residues by recycling them on the farm. His projects include producing concentrated biofertilizers from anaerobic digester effluent, studying the efficiency of solid liquid manure separator technologies on California dairies, and quantifying the resulting methane potential reduction from dairy manure lagoons. And most recently, this project on recycling dairy manure and almond stick and twig waste as organic soil amendments of California almond orchards. Take it away.
Thanks, Kevin. Appreciate the introduction. So thank you all for attending today. I'll be talking, as Kevin said, about utilizing dairy manure as a biofertilizer and as organic matter amendments. This talk will show how we took dairy manure and we produced pathogen-free and pelletized products. I know this is a biofeedstock session, not a bioproduct session, but I'm cheating a little bit and I'll be talking about both. You'll see how particularly separator solids, solids that were recovered from solid liquid separator systems were composted and then converted into pelletized products. And I wanted to share this just to give you an idea of what those products look like in terms of their NPK value and also their bulk density. The pelletizing doubles the bulk density approximately. Other features of this project were to take those products and then go back and apply them into almond orchards. So things that we did was we looked at the physical chemical properties of the products. We looked at the products in terms of pathogen and E. coli. We also looked at the almonds in terms of food safety. We did some measurements in the orchard on the trees. We looked at almond yields. We looked at pathogens on those almonds. And then we also did a soil emission study in the orchard. I won't be presenting all of this. This project was made possible from funding from the Healthy Soils Program and the Alternative Manure Management Program, as well as funding from the Almond Board of California, the California Dairy Research Foundation, and the UC Davis BAE department. So the objective was to recycle dairy manure, and actually it wasn't just dairy manure, but I'll be focusing on the dairy manure part of this project, but we also used stick and twig waste from almond processors and to recycle them into nutrient-rich, safe, and organic matter amendments while sequestering carbon and providing economical and sustainable benefits to the soil, crop, and environment. And I'll focus on the first 3 points there in those objectives: evaluating the performance of the advanced mechanical solid liquid separation system, with centrifuge to separate solid manures from flush manure on a California dairy, investigating on-farm composting of dairy manure and producing pelletized amendments, and then applying the loose and pelletized amendments using a conventional orchard applicator. So in terms of the dairy industry, these figures are probably known to many of you. It's the #1 agricultural commodity in the state. We produce approximately 20% of the U.S. milk and cheese, or we account for 20% of the U.S. milk and cheese production. We're the #3. California dairies are dairy industry is the #3 agricultural export, and about 2.5 out of the 5.2 million cattle in the state are for the dairy industry. 1.7 of those million of those are milking. Challenges are increased herd concentration, impacts on our air and water, tough regulatory and business environment, and generating tons of manures, things that the last presenter touched upon. In terms of manure management on dairies, cows produce approximately 120 pounds of manure per day per cow on a wet basis. The amount of manure generated by dairy cows is equal to the amount of the California human population, the amount of manure produced by humans in California. About 50% of our methane emissions have been said to be contributed from the dairy industry or from dairy cows. There's a challenge with nitrogen leaching impacting water and air quality, as Steve mentioned. And as you can see from the chart below, the industry is consolidated over time. In 1982, there were 4,600 dairies. The average size was 204 head per farm. And in 2016, that had increased to, or dropped to just under 1,400. We're less than that now. And the average dairy farm was 1,250 cows. So considerably consolidating in the last 4 decades. And if you look at what a typical flush manure management system on a California dairy looks like, not all dairies in California use flush manure management. Some of them are pasture-based, some of them are scrape dairy systems. But many dairies in California do use flush manure management systems, which means that many of the cows are in freestall barns all day long. Sometimes they go out, they have exercise pens, as they call them. But when they excrete manure in those freestall barns, they sleep there, they eat there, and then they generate manure there. That manure is then flushed using different kinds of water sources on the farm. It depends on the dairy operation, but it might be water from the lagoon. It might be recycled flush water. It might be water from the milk operations. It might be fresh water. And then that water goes to a solid liquid separation system. Solids are removed, and then that liquid, the remaining liquid goes to a settling basin or a lagoon, and the system goes on. Why do dairies use solid liquid separator systems? Many of them don't necessarily do it because they're trying to reduce organic loading into lagoons, which is a huge source of methane production. Many of them do it because they want bedding and compost. The separators do reduce organic loading, so that does reduce methane emissions. A lot of the separators that are in California are sloped and scrape screen separators, like the 2 pictured on the right. Other technologies include weeping walls and other more advanced systems, like the one pictured in the bottom, and which was used in this study. And they can be good alternatives because digesters can be expensive, although there are some great grants programs that are helping to drive that cost down. And I mean, the digester management itself is complicated, although you'll see that a lot of digester systems will also incorporate separators because the dairy farmers still want bedding. They still want to get some of those solids. And also because the digesters want solids, but not too much. So actually from 2017 to 2021, we studied an advanced multi-stage separator system in the California Central Valley, in addition to 5 others, but all focused primarily on this advanced multi-stage system. We evaluated the solids removal efficiency of this system, and then we composted solids from the separator. In 2021, the farmer installed an add-on centrifuge system to that separator system. So I'll show you some data on how that centrifuge performed. This is what the manure management diagram on this farm looks like. Water comes in and flushes the manure. It's a combination of different water sources. It goes to a primary coarse rotary drum separator. I think it's about 3 millimeter screens in there. They remove some solids. Those solids are composted, primarily used for bedding, some of it exported. The water that comes out of those screens go into a settling tank. And then that settling tank basically allows those remaining solids to settle. And the sludge at the bottom is then pumped over to a finer rotary drum separator. And more solids are generated there. And then the water goes to an earthen settling pond and then to one of 2 lagoons. This is an overhead view of what this system looks like. The reception boxes where the manure comes in from the freestall barns, then it goes to the coarse separators, then to the sand removal tank, then to the settling tank, then to the fine separators, and then to the settling pond and one of the lagoons. You can see a picture of the solids there as well. This dairy has about 2,600 milking cows, 700 dry cows and heifers. They use Jersey cows. The milk is used for cheese production. And you can see the information about the screens for those separators. It's a pretty advanced system. It's very fancy. It's got a really nice interface system. It's got, I believe it's got also an online mobile app that the farmer uses and has alarms set so that he gets messages at night when something breaks down. It's a picture of the rotary drum separator. That's the settling tank. That's just using some water to agitate the top. And this is a picture of the coarse and the fine solids. The data there is 1 day of solids production from 2017, fall of 2017, generated 60,000 wet pounds of coarse solids and 105,000 wet pounds of fine solids. Now the centrifugation system was added at the end of the system. So the water from the fine separator then goes to a centrifuge, and then that water then goes to a lagoon and the solids are collected. And we actually took the solids, the composting, the pellets that you'll see are composted fine manure compost, but we will do centrifuge. We will compost centrifuge and fine manure solids and pelletize those later. So that's a picture of the centrifuge. And this is just some data. I didn't go through all the pictures of how we collected the data, but we basically sit there on the dairy and collect samples of different input and outlet ports and measure solids and weigh them and bring them back to the lab. And you can see this is data from the original study and then data that we collected back in June of 2022. The first stage removes anywhere from 6 to 10% of solids. The settling tank accounts for anywhere between 40 to 60% of the solids. The flush water actually comes out of the settling tank. So a lot of those solids are constantly flowing through the system back and forth as they're recycled. The second stage removes another 10 to 15%. The top number is the solids with respect to what comes in at the first stage. The number in parentheses is the solids removal efficiency with respect to what comes in at its own input. And so the BioLink system removes, which includes the first and second stage, removes anywhere between 60 and 80% solids. In June of 2022, we estimated that the centrifuge removed another 11%, bringing the removal efficiency of the entire system at about 85% for that time point. And then what we did is, for the composting, the data all shows actually composting only of the fine manure stream, but we took the dairy manure. This farmer has a lot of space. He has about 350 acres connected to his dairy and another 650 acres that is not directly adjacent to the dairy, but that he can amend solids on. But he does a lot of windrow composting. So we just plugged into that and we took measurements. We did active composting for 8 to 10 weeks. Then we took those soils and pelletized them. And then the 2 different treatments were applied in a nearby orchard. And you can see the experimental design. This actually included 2 other treatments as well, which was dairy manure co-composted with sticks and twigs from almond processors and pelletized dairy manure co-composted with sticks and twigs. And you can just see how the windrows are created. The piles are regularly turned once or twice a week. And in terms of the next slide where I'm going to show temperature data, you'll see points 1, 2, 3, and 4 are 4 midpoint. We split up the windrows into 4 sections and then took temperature readings right at the midpoint of each of those sections just to see how hot are these piles getting, how's the compost performing, how much solids are being lost. And these are results from composting experiments in 2019 and 2020. The yellow lines on the left are ambient temperature, and then the gray, orange, black, and blue lines are the different points in the windrow. And the only reason you see a temperature drop is because every time they turn the windrow, we would pull out our temperature sensors, and that would account for the drop. But very quickly, the piles reach, as high as 60, 65, 70, even up to 75 degrees Celsius. At about 5 to 6 weeks, they start to lose temperature because they start to lose moisture. The moisture starts to drop. And this is 2019 data that shows what the initial and final moisture content of the windrow was, how much mass was lost on a wet basis, how much total solids mass was lost, how much organic matter, volatile solids mass was lost, and the total drop in moisture water. And then after the composting process, we pelletize, use a flat die pellet mill. This dairy actually got a grant to install a full scale, I think it's a one ton per hour pellet mill. But we use the lab scale pellet mill for the initial work, and the full size pellet mills in the process of, it should be ready actually this month to start taking material. This is a picture of the pellet mill that we use on the farm. It can process about 100 to 150 pounds an hour. And this is the setup that we used. Again, this is just the composition of the material. So bulk density increases by about 2-fold. There's no real change in the C/N ratio of the material. The material goes in through the pellet mill really quick. It is hot. It is, anywhere between 90 to 150 degrees Celsius, but it's not really in there that long. The electrical conductivity slightly increased. The NPK between the 2 different products is pretty much the same. And when we applied this material in the orchard at a rate of 4 dry tons per acre, that's equivalent to applying 100 pounds of nitrogen, 28 pounds of phosphorus, and 72 pounds of potassium. And when we did studies on the products themselves, we found no sign of salmonella or pathogenic E. coli. We also tested the soil, and we also tested the almonds themselves, and have not detected any pathogenic E. coli or salmonella. This is what the pellets look up close and in the applicator. And this was just a calibration test that we were doing. But the left and right, you can see the compost and the pellets being applied. So both of them flow pretty well out of the applicator. This shows yield data from the orchard experiments. You can see whole nuts, hulls, shells, kernels, and field trash that we hand harvested. We hand harvested 1 tree per plot. It also includes data for the manure stick and the pelletized manure stick compost, but we didn't find any differences in the harvest yield in 2020 or 2021. And this is the historic yield. So you can see the data that we collected in our harvest versus what the farmer's getting for what he's taking to the processor. So we're getting right about the same amount that he's showing. In conclusion, this project was follow-up work from a project that happened in 2017 and 2018, where we studied 4 different types of solid liquid separation technologies on 6 different farms in California. What I've presented today focused on the advanced multi-stage separator system. He added a centrifuge to that system. The original study determined solid removal efficiencies of 62 to 80% volatile solids removal for the system, and in the follow-up study we found additional total solids removal efficiency of 73% and an additional 11.3% removal from the centrifuge. The centrifuge removed about 50% of what came in. Further work that's going on is we're supposed to do this work. We're studying the centrifuge for a year, so 4 seasons. We've done 3 seasons so far. We got one more sampling to do. There'll also be a field day and a workshop for this project. So listen for that. Look out for that call. And there'll be more data hopefully for us to share. We're currently analyzing a lot of the data on the soil and the almonds still. Composting after 8 weeks, the initial moisture content dropped from about 77% to 40%. Again, the mass dropped by about 76%. Water in the piles dropped by about 87%. The total solid concentration dropped by about 36%. The volatile solids concentration in the compost piles dropped by about 62%, a little bit more than half. Things that we learned from pelletization, less than 20% of moisture content was way too dry. Over 35% was too high. Less than 20% plugged up the dye. And in the pellet mill on this farm, probably a lot of it had to do with a lot of sand that the farmer has. The soils out there were really sandy. Greater than 35%, you get crumbling pellets. But higher moisture content for pelletization means less of a need for drying after composting. We anticipated that we would need to dry the compost down to about 10 to 15% to pelletize. In terms of application, the higher bulk density means more pellets can be loaded into the applicator and less runs. We were successfully able to apply both compost and pellets, and we didn't find any differences in yields. Thank you again to all our project sponsors, and thank you all for listening to this presentation.
Great, thank you so much for that. As a manure nerd myself, I can talk all day about the last 2 presentations and ask all sorts of questions. I think a question just came in from Steve McCorkle. Do you have any growth yield data of the pelletized manure as compared to manure-derived biochar? That's a very specific question. I don't know if either of you could dive into that a little bit.
Biochar wasn't part of this study, so the different treatments that we were looking at was manure compost and pelletized manure compost, or the manure co-composted with sticks and twigs and the equivalent. So biochar wasn't. The idea was to take the farmer's manure, compost them, pelletize them, and apply them in a nearby orchard.
I'm not sure you would compare biochar to manure pellets as a fertilizer in any case. Biochar is an organic amendment that may facilitate nitrogen recovery from soils or retention in soils, but not necessarily a source of nitrogen. For example,
thanks for that clarification. That makes sense from what I understand. I don't know if Dan wanted to add to that, or if we're good there. All right, and we have another question. Brian Fuchs from, I don't know the organization, but the question is for Hossein and myself from CARB. How is open windrow composting an accepted form of composting when VOC reduction is required in various air districts? So that's a very technical question. And I would say there are a lot of nuances to composting management systems that can have differential impacts to VOC reduction. How's that for the political answer? So when you have so many different systems, I really can't give a straightforward answer on that. It looks like Dan Noble is interested in diving into that a little bit. Dan, would you like? Go ahead.
Yeah, well, I think it mostly has to do with who regulates those facilities, if they're permitted under the LTF system versus under the ag system. My understanding is that they were all exempt, but I could be wrong on that.
Well, and I think the bigger picture is not. I think it's getting at the what are the various emission sources and the various kind of goals from the air districts for reducing ozone precursor emissions and things. And yeah, there is a lot of exemption for a lot of these different processes. I think once we get into like a facility scale, I think there are
I'm not
air district level kind of controls and things depending on the facility.
Yeah, I would say I'm not sure what the rules and regulations are for the district that this dairy is located in for them and for specific dairies, but they're not a certified composting facility. When he does this winter composting, he does it for his own use, and so maybe the rules I'm imagining are less stringent if you're not selling this as compost and a certified compost producer.
Yeah, there's definitely a lot of tiers of kind of potential regulation there of whether you're utilizing on-site, processing on-site, selling off-site, giving away off-site. Yeah, it's very nuanced, but it's not always a impact to VOCs depending on how the management system is being implemented. So it's kind of complicated, but that's I think the best answer we can give for now.
I'd like to make a comment, Kevin, here. It's that to have a wider distribution of the solid fraction of dairy manure, of those surplus nutrients, something needs to be done about contamination in the solid manure fraction. That would be weeds, that would be pathogens. So composting is typically the method for doing that. But there are, in some parts of the valley, there's large amounts of material that might be composted, especially in the dairies that manage manure mostly as a solid form. So it's an important regulatory question to resolve. And I would do it from a cost-benefit perspective, actually, but there may be absolute limits in terms of the air quality districts.
Yeah, and as you know, back to Aaron's original thing is we need to look at everything from the whole product life cycle, from birth to death, and what's happening with the nutrients. Where are they going in the groundwater? Are they going in the soil? Are they going in the crops being grown? Are they going into the air? Like Dr. Kafka just mentioned, the various impurities or pathogens in the feedstocks can impact the whole system, and maybe pelletization at a certain temperature can solve a lot of the things that composting is designed to solve by maybe combining and changing the time frames that things are managed in different parts of the system. It's definitely very complicated. And even back to the nutrient cycling that Aaron mentioned, maybe some of the fiber, like excess fiber from production, could be actually cattle feed, depending on the co-location of facilities, and post-producer post-consumer waste could, depending on contamination levels, could actually be fed to various animals, depending on whether it's a fiber stream for cattle or something that could be digestible by swine with leftover food, and maybe edible pastaware, right? There's a million different things that we could talk about in all these systems. I think we have a hand up from Dan Noble. Did you want to say something?
Just one more comment. I can't activate my video, but that's okay. I don't need to. Just for further conversation, and particularly at the end of, in our final session, where we go into maybe some sort of bioresource roundtable, because part of, over the next year, because we're right now just trying to get more ag composters in our association, but our association is mainly made up of municipal composters, both biosolids and food scrap and green waste. So how does the manure question get in here, both from all CAFOs, all concentrated animal feed operations. So I think that's for, and then the regulators we need to solve these problems because it's both air and water, but we want to get more carbon in the soil and less nitrogen lost, as well as VOCs produced. So, and that's what we're doing in the compost facility, and that's where Brian's question came from, because they do, aerated static pile, covered aerated static pile systems. And so I think, and there's right now, there's a grant on the street that we're working on from USDA, FPEP, probably heard of it, the manure or the fertilizer production, where USDA is trying to get more fertilizer production based on natural feedstocks and also at home and in the community. So we're not buying fertilizer from the Middle East and that sort of thing. So I think this is an important discussion, and his question, I think, is well taken, because there's a lot of discontinuities in the air regulations between the districts, but also between different industry sectors. So,
and the utilization, like the on-farm, off-farm, and everything. Yeah.
Well, exactly that as well, and the need, from Stephen's presentation on the excess manure that has to go somewhere, that excess nitrogen, so that you're not overloading those small, those intensified environments.
Absolutely.
And watershed and, the groundwater and all the rest of it. So great panel. It's kind of interesting to see how the input, the feedstocks of coming from the municipal system, particularly the food system and the serviceware that Aaron was talking about, is also related because, in ag, producing a lot of food, and there's spin-offs from the whole production environment. So
yeah,
working together is part of this challenge.
Yeah.
Anyway, just some comments, some thoughts.
Yeah, so I think overall we're out of time now, but hopefully we can bring a lot of these kind of overarching, kind of system connected kind of musings and ideas into the final session that we have tomorrow. Kind of open panel that we can ask these questions and get people talking and thinking, because I think there's a lot of interfacing that needs to happen on a lot of levels, whether it's a bioresources scoping plan or just even focusing on maybe 1 or 2 or 3 industries, interlinking on a time scale and an economic and business kind of scale that can really, flourish and create solutions to problems and barriers that we currently have. So thank you everyone for joining the session, and I think we're just going straight into lunch, and we'll be back at 1:30.
Thank you, Kevin.
Then are we ready to get started? Okay, I think we're ready to get started here. I'm Lauren Fondal, the Biosolids Coordinator of EPA Region 9, and I've been the co-chair of this symposium since it started in 2006. One of the issues in 2006 was silos. At the state level, the air, water, and solids people were all in their little silos. And I think since then, there's been a lot more communication, although if you want to site or operate a facility, you still have zillions of permits to go through. Our first speaker this afternoon in the siting and operations sessions is Jason Dow. Jason is a general manager of the Central Marin Sanitation Agency wastewater treatment plant. And they have it's a mid-sized facility, and they have several biosolids use and disposal options. And they have a particular challenge. They get the discharge from San Quentin, the federal facility, and they used to have a big problem with things getting flushed down from San Quentin. And a few years ago, they talked about how they were dealing to avoid getting all the contaminants from there. Today, Jason's going to talk about food wastes and how they're now taking food waste at the wastewater treatment plant. So, Jason?
Hey, thanks, Lauren. Hi, everybody. So I'm Jason Dow, manager of the Central Marin Sanitation Agency, and I'm going to share my screen now for my presentation. Okay, so my presentation is called the Organic Waste and Power Receiving Program for our agency. And I gave a similar presentation a few years ago at this conference. So if any of you attended that, this will seem familiar, but it's been updated. So what I'll talk about is a little bit about the agency, and then generally about our organic waste program and how it works. And there's three components to that. There's a food waste program with the local solid waste hauler, Marin Sanitary Service. Then we have a program where we receive fats, oils, and greases from private haulers. And then we're starting to receive other types of organic waste from other haulers, and that will be expanded into the future. So I'll focus really on the food to energy program with Marin Sanitary, and then just some benefits we see for the program and some various high-level metrics that we track on. And those metrics are from 2019, and I'll explain why they're a little older. And then I'll move into our power generation program, which the organic waste program is a huge part of that. And then just a little bit about what we're doing next. So we're a regional wastewater agency, and we're in the city of San Rafael, Marin County, right across the Richmond-San Rafael Bridge, and there's Highway 580 in that little picture there. So in this Google map, there's a bird's eye view of our facility. So really, in short, all this wastewater comes in at the top of the little map. It runs through various treatment processes and equipment. At the bottom end, the clean water flows through a big 7-foot diameter pipeline that runs about 2 miles out into the central San Francisco Bay. And everything that's removed from the water, which is, wastewater sludges, are processed further, and they go into those anaerobic digesters. Those little green domes you see over by the forested area. And we produce renewable products from that. We also produce recycled water. So, we're a regional wastewater agency. We serve about half of the county of Marin. It's a small county. Our population is about, 260,000 people. We serve about 110, including San Quentin State Prison, as Lauren mentioned a moment ago. Our government structure is we're a joint powers agency. So we're very similar to a special district. And we have 4 districts that we work with on our wastewater business. And so the water that comes into the plant, it varies throughout the day and the season. So during middle of the night, about 1 million gallons of water comes into the plant. And that peaks out around 10 o'clock when everybody's up and done having breakfast and taking showers. That might be 13 million gallons per day comes in. So over the course of a day, most of the year, about 8 million gallons gets processed. Then, of course, during major rain events, we have a lot more water that comes in through cracks and sewer lines and home laterals. So like last October, remember we had that big rain event over the 19th through the 21st. We saw 129 million gallons come in for that day, which is a huge increase. That's why in this photo you see all these empty tanks, because most of the year we don't need them. And then we have contracts with 13 other local public agencies in Marin County where we provide a variety of wastewater services to help them out. So like my board and a lot of, elected representatives, they like this diagram because it's kind of a nutshell what the program is. On the left, you have all this organic material, food waste, fats, oils, and grease, other types of organics. It runs through a bunch of processes, including anaerobic digestion. Then the main product is a biogas, which is like a lower quality natural gas. So like natural gas has about 95, 96% methane. Our biogas might have 64 to 66% methane. Good fuel though. This little cartoon shows a little more detail. So you have on the left the organic wastes. They get collected. The food waste go to the solid waste haulers transfer station down the street. That's Marin Sanitary Service. And they pull out contaminants and process it. Other organics come in by tanker truck. All of that eventually makes its way into a couple anaerobic digesters. And I'll talk more about what happens there in a few slides. But there's two products essentially. One's a biosolids, and we have 3 different beneficial reuses for that. And then the other product is the biogas, which with the methane content, it's a perfect fuel in an engine, which turns a generator to produce renewable power, which we use internally. And then we produce extra and we sell that to a utility. So back into 2013, this is the first fats, oils, and grease truck that came in. It's about a 5,000 gallon load. And these companies go around, they pump out grease traps and interceptors at restaurants and markets. Those can be in the kitchens, they can be out in the parking lot. Essentially, they collect all the grease so it doesn't get into the sewer systems, and these trucks pump it out. Now they can bring that to us, and they just connect out that hose there you see in the diagram, and they pump it into this underground tank. You'll see the tank also has these hatches that are opened up. That's where the food waste goes in. And here's the first load of pre-consumer processed food waste that's being dumped into that tank. So every morning, a load of that comes in, maybe 8 tons. It's mixed with the fats, oils, and grease over the morning, and then that's pumped over to the digesters. So this food energy program has been a great success with Marin Sanitary Service, and it's a partnership that started up back in 2008 timeframe, where we started with different planning level activities and feasibility studies, how much food waste they can collect, how much capacity we had, gave presentations to city and town councils and the board of supervisors, just getting support for the overall program, which they all thought it was great. Then we designed and built our facilities, which I'll show in a minute. But this little map here shows central Marin County next to the San Pablo Bay. And you see the area within red, that is the service area from Marin Sanitary Service. And then the area within green is our service area. So we have a lot of common customers. So not too much about their program, but essentially what they do is they collect pre-consumer food waste from restaurants and markets. And this is the food waste that's collected from kitchen activities, which has a lot less contamination or potential contamination than you have from post-consumer, which is in the eating areas. And right now they have about 218 different, food waste generators, the markets and restaurants that are in their program. But over the next couple of years, starting pretty soon, they're planning to expand their program where they collect food waste from other sources, schools and, nursing homes and other types of facilities to help their local jurisdictions that they have contracts with comply with the landfill diversion, regulations in Senate Bill 1383. And we have the capacity for all that too. So their program really has a lot of outreach. They hired special, staff several years ago to go out and identify these eligible restaurants and facilities, train them about, how they, separate the food waste and contaminants, what are contaminants, what doesn't go in the containers, retrain them, monitor their performance and so forth. So they have different, kind of garbage cans. They have their recycled can, the blue one, which is collected separately. Then they have their solid waste can, which goes to landfill. That's black in the middle. Then they have their food waste can, which is that green one. So those stay in the kitchens. And this happy guy here, he's just scraping off the food waste into the can. Then that goes outside, and it looks that clean, which is great for us. And then a special food waste collection truck, collects that. Then it's eventually delivered to their transfer station. As I mentioned, it was about a half a mile down the street. So starting on the left, it's dumped on the floor in the transfer station. Some of their staff picks out any contaminants, plastic, bones, metal utensils, other things that can't be processed in an anaerobic digester. And then a loader picks that pretty cleaned up food waste and it dumps it on this piece of equipment you see in the middle, which is a kind of an angled conveyor belt. About half the length of that conveyor belt, there's a platform, and there's usually one or two people standing on that platform during their operation, and they can, increase the speed and decrease the speed on that conveyor belt, and they hand pull out other types of contaminants. And then that goes through a grinder system, which dumps it into that green bin there. Then a truck picks up the bin and just drives it down the street to us. And this is a picture of their food waste load. This isn't a staged photo, which you guys think. This is actually what the food waste looks like when it's dumped in their transfer station. So it's very clean material. So then this is our facility, and it's an underground, say 30,000 gallon tank. And then right next to it, closer to those trees, there's a kind of a, not underground, but it's lower than the ground level where there's various equipment. There's grinder pumps and hose pumps and piping and instrumentation and other things. So the truck, you see where the truck pulls up on that kind of concrete pad that's a little farther away from us in the picture, connects the hose there. The closest pad is where the solid waste hauler discharges. Everything's mixed, and then it's pumped to that little machine you see on the platform, and that's a screening machine. So that screens out other types of fibrous materials, little pieces of plastic and other contaminants, and that gets discharged in that green bin in the Marine Sanitary Service, picks that up. Sometimes it goes in their compost if it's contaminant free, sometimes it goes at the landfill. And at the end of the presentation, I'll talk about a project where we're expanding this facility with some above ground tankage, so we have more capacity. So from that little tank, what we do is we pump that mixed up, material slurry to one of these two digesters. So these are 1 million gallon digesters. They're about 80 feet in diameter. We wish we had a third one, but they're about $10 million to build, plus or minus. So then the digesters are full of different microbes. There's different species of microbes, and they each do different types of work. And the final group of microbes, they produce the methane biogas. So that's removed from the digesters, and it runs into those two white tanks you see behind the digesters that are in the picture at the bottom of the photo of the screen. And these tanks have a material in it, kind of like a sand, but it's a carbon-based material, and it's designed to remove hydrogen sulfide gas from the biogas. That's to help comply with our air permit. Then from there, that partially clean biogas runs through some compressors, so it's pressurized. Then it flows into this little facility you see up on the left-hand side of the screen, where it runs through a heat exchanger to cool it off. Then it runs through a dryer, which then removes all of the moisture. It's nice and dry. Then it runs through those two vertical tanks, and those have another type of granulated activated carbon type material that's designed to remove siloxanes. And siloxanes are silica-based compounds that are in toothpaste and makeup and various personal care products. You don't want the siloxanes in the combustion area of a engine, so you remove those out to minimize maintenance. So then that dry, clean gas goes to a generator. So the one at the bottom photo is the original generator we had, which is about 3/4 megawatts, Waukesha, and it's essentially an engine very similar to what's in your car, except instead of gasoline for fuel, it uses the biogas. Then it spins a shaft, which then connects to a generator, and it produces the renewable power. And we just installed this newer, about a 1 megawatt cogenerator made by Jenbacher. They're from Austria. So that was just installed during the summer after about a year of work, and it's in commissioning phase right now, but it is producing power to run our facility. So at our wastewater plant, we have about 17 different little kiosks that have computer screens that show all the different areas of the plant. So we can monitor, our operators can monitor everything, they can control systems. This is a computer screen that kind of shows the organic waste receiving facility and the underground tank. So you see all the valves and the pumps on there. Green means they're on, red means they're off. So we receive the material in the morning, usually up to about noontime. Then it's mixed together several hours, so it's nice and homogeneous. Screen runs to the paddle finisher, so the contaminants and screening materials are removed. And then we start slowly feeding both the digesters, usually over about 12-hour period, sometimes a little more, sometimes a little less. And we feed each digester maybe for a couple hours, then it goes to the next digester. So we distribute the feed to both the digesters, so we don't have too much of an organic impact on either one of the digesters. Very important to maintain the health of the digesters and all those happy microbes inside. So here's some of these, some of the metric information. We measure a lot of different things and track a lot of different metrics. This is just kind of a little summary of some. And this is 2019 data. And the reason that I'm showing this old data is because it's representative for a full year of the program. In 2020, we had COVID, so a lot of the restaurants shut down, as you know. Then they started opening up. Some of them opened up, and they only had takeout service. So there's a lot less food waste being generated. They weren't generating the grease. So the feedstocks for the organic waste program was significantly reduced in 2020, started to increase in 2021. But bad news for us, one of the covers on the digester ruptured. So about 6 months it took to train the digester, buy a new cover, install it. So we didn't have the program up and running. Then since we did that on one digester, we decided to replace the other cover, and that's just got wrapped up about a week ago or so. So this is the most current data for an entire year that's representative. So you see there's different boxes. So you have the digester health. This is some of the things that we measure. Very important to keep the digesters healthy. The two red areas are where what we track on real close. The pH of the material, really important to keep it around 7. If it gets too high, something bad's happening with some of the microbes inside, the acid producers. Then you have this other metric, the volatile acid versus alkalinity. Alkalinity is a buffer. So you want that to be really low. So this is really good data here. Then you have that feed little box. So the sludges we produce at the wastewater plant are the primary sludge and the thickened waste activated. That's the TWAS. Then you have the organic material. Then the last column shows the percentages of the volatile, or what can be converted to energy. So several years ago, when we were looking at expanding our power delivery or production and delivery program, we were working with a lot of consultants doing planning level studies, and they told us, well, nationally there's various studies that were done that the amount of organic material that can be co-digested with wastewater material in these digesters is only like 30 to 35%. So we are already at 30% in 2019. So we were kind of concerned about that this may be a limitation for increasing our organic waste program. So we bought a couple 600-gallon digesters, set them up on a skid, and for about 2 years, we ran a pilot study where we slowly increased the organic, content of the feed to the digesters and just monitored their health. And eventually we got up that feed rate to about 55%, which was great news for us. And then you could see the last box at the bottom there on the right is the biogas usage. So we averaged about 18 hours a day of renewable power generation. So if you look on an average week or so, maybe 4 or 5 days, we are 100% energy self-sufficient, and we delivered some power. In other days, we didn't have enough biogas. So it was about 18 hours a day on average. So here's a list of benefits that we identified for having this program. One, it is a local renewable energy project, which is great, and that aligns with a lot of the state's goals for renewable energy. It does, by diverting the organics from landfills, it complies with some of the requirements in the Senate Bill 1383, which is great. We had a lot of underutilized capacity in our digesters, like the whole digesters, capacity almost. Then we had, additional capacity in our co-generators. So we're utilizing that unused capacity, which was already paid for with public funds. So that was good news. And we deliver renewable power to the grid and get paid for it, which is great. So now I mentioned that the organic waste program feeds into the power delivery program, which is really those co-generators operating. So once we were starting to plan to increase organic waste, produce more power, and eventually achieve energy self-sufficiency, then start delivering some, we had to talk with the local utility in our area, that's Pacific Gas and Electric, and had to get their approval to deliver the power to the grid. And that's, that's a kind of a complicated process, and it takes a long time, and that's called an interconnection. So PG&E had to do various electrical evaluations of their transportation and distribution system. Fortunately, we didn't have to make any improvements to their system, but we had to install a lot of protective relays and other devices inside our main distribution panel, which is shown at the bottom of the slide. We installed a special meter that measured how much power we were exporting. Ultimately, after about 1.5 years of them doing their studies, us designing our improvements, contractors installing things, them witnessing that everything's working properly, we got the formal authorization. That was called a permission to operate. We got that back in March of 2019 for the 3/4 megawatt generator. So then when we looked at installing a bigger generator, that green one from the prior slide, the Genbacher, we had to go through the whole interconnection process again. Electrical studies, design work, approval of design, installation. That took 3 years to get that done. It was a really kind of a drawn out, frustrating process. But early September this year, we received the permission to operate for the bigger generator, which was great news for us. And then once you're generating this power and you have some to deliver to the grid and you have authorization to do that, you don't really want to deliver it for free. It's better if you get paid for it, of course. So we looked at, well, who would buy the power? So that's either PG&E or Marine Clean Energy in our area. So we reviewed several of their agreements for doing that. And those are called feed-in tariffs. And they're a little complicated, and they have a lot of requirements and restrictions and other things associated with those. So we reviewed those, and we selected a tariff with Marine Clean Energy called a small generator power purchase agreement. And we selected that because they're a public agency that's in San Rafael like us, and the administration of all those conditions is much more simplistic than working with PG&E. And the biggest issue was that we didn't have to forecast how much power we were going to deliver on a daily basis, because there's penalties if you don't deliver as much as you told them you would deliver. So with MCE, it was much easier. So we eventually received what they call a commercial operations date, and that's them telling us that we met the requirements of the agreement and they'll actually buy our power. So shortly after that, we started delivering renewable power. And that little screen from our computer system on the left shows over time. So the blue line is the power that we're generating, and the red line is the power that we're buying. So before export, we always had to buy a little power to prevent us from exporting. And then there's that date of the May 29th on the right side of the screen. At that point in time, we increased the output of the generator and we started delivering power, which is the green line, and no more importing the power. So that was a big day for us. And because now we have the new generator with higher capacity and the potential to deliver more power, we had to negotiate a new power purchase agreement. And that was just approved, end of September. And so they're buying power from us for 8.69 cents a kilowatt hour, which is a good purchase price. So in terms of like next steps, you can see this little timeline here. So all the things I've been talking about are all the way through the right-hand side. We replaced both the membrane covers on the digester, so that doesn't have to be done for another 10 years, so that won't disrupt our organic waste and power delivery programs. We're expanding, the storage of the tank, where we hired a contractor recently, and construction is going to start on installing some, concrete slabs and, above ground storage tanks and pumping mixing systems and interconnection piping and so forth. Then we're looking at hiring a consultant to design the installation of new centrifuges, and that's what we use to dewater the biosolids from the digesters before beneficial reuse. We need centrifuges that are designed to efficiently dewater co-digested material, which has the organic waste in it, so a little more efficient. And then we'll look at outreaching to other types of, food waste generators, breweries, wineries, other type facilities that produce, some type of very clean, liquid organic waste, and work with them to bring it into us so we could expand our program. And for those of you that have never seen a wastewater digester before, its cover coming off, This is kind of associated with the presentation, but I threw it in because it's kind of interesting. So on the left-hand side, you see a digester and scaffolding goes up and they're taking the cover off. Then once the cover's off, there's all the sludge inside and it's drained out. And you can see at the bottom of the right. Then people go inside and they start breaking up the sludge. And there's a belt filter press and they run through that to dewater it. Then on the left, there's some contractors inside. They're cleaning off struvite and other types of materials off the walls of the digester. Then you have some of our engineering staff making sure all the piping and the concrete is sound in the digester. Then the new cover's installed with those cranes and the people working on it. And just a couple of weeks ago, it was inflated. So that's my presentation. Thanks. Any questions?
See, I had one, how much, have you figured out, like, do you get more biosolids by taking in the food waste? Or I've heard, some people say that like practically all the food waste, gets gasified, so you don't, and other people say, well, it does increase the tonnage of biosolids. Have you seen one way or the other?
Yeah, for us, we haven't. So if we look back over the last 10 years on biosolids production, as we've increased the organic waste, feedstocks, we haven't seen any clear trend of an increase in biosolids production. And part of that is because, because these huge flows that come into the plant, the sewer pipelines are oversized. So during most of the year, you get this material that settles out in the pipelines, and the rains come and it flushes all that out. So we get big loads of, settled, wastewater solids that come in that need to be digested. So during big rain years, you can see biosolids productions increasing, but not really with the food waste piece. It's driven really by, the wet weather component. But I've heard there's been several studies that I've heard that once you start feeding the anaerobic digesters with different types of organics, that the microbes get more efficient at processing or eating the wastewater solids. So it kind of balances out. I mean, that's not a very scientific answer, but no, we haven't seen an increase.
Any other questions? There may be some time at the end for questions from all three.
Sure. So I'll go and turn off my my video now.
Okay. So our next speaker is Roberta Franco, and she works at the California Department of Food and Agriculture, and she's working on 5 programs for reducing methane emissions, and particularly those from dairy and livestock operations.
Thank you, Lauren. Today, actually, I'll be talking about the dairy digester development and research program, though. So let me just share my screen with you. Let's see, can you see my slides well?
We can see them.
Okay, nice. Okay, so yeah, if I'm, I can start. Thank you, Lauren, first of all, for the introduction. And I'm Roberta Franco. I'm the supervisor for the California Department of Food and Agriculture, the methane emission reduction programs, which, as you can see, there are 5 of them now. And that composes the Alternative Manure Management Program, the Dairy Digester Research and Development Program, which we'll be speaking today about it. We have the CDFA side of the SB, the Senate Bill 1383, which is the methane reduction program. Then we had just developed a new research program that is called the Climate. And we also have the AB 1981, which is the organic composting waste. So first of all, before starting my presentation, I really would like to acknowledge and give thanks to my team. So we have Rosie, Alyssa, Dana, and Charles. And also like to thank our Deputy Secretary, Virginia Jameson, our Secretary of Agriculture, Karen Ross, and all my peers at the Office of Environmental Farming Innovation, and all the collaborators, since without your support and help, I wouldn't be speaking here today. So first of all, before I start talking about the program itself, I would like to share some statistics with you about the dairy industry in California. And that will help us kind of understand and set up the stage for why the dairy digesters will serve as a wonderful tool and can help us today and in the future in terms of methane reduction. So the dairy industry in California is the #1 in the United States. It accounts for the production of 19% of the fluid milk in the nation, and this does not count with cheese and other dairy products. We have about 1.7 million milking cows, and those are distributed across 1,250 dairies, commercial dairies across California. The milk, so the dairy and the dairy products generated, they generated actually $6.3 billion in revenue for the state of California. And more than just a statistic, I would like to point out that the California dairy sectors not only provides milk and milk products like cheese, which are highly nutritional, safe, and affordable foods for children and adults, and they play an important role on the local, national, and international food security. So this, more than just methanes and emission, this is why we produce milk and milk products. So one thing also I'd like to share, which I thought was interesting, is that we are seeing a rise in consumption per capita of dairy. And in this case, I showed the butter consumption because it's really steep, and just to show that even with the rise of dairy alternative products and other types of food, consumption per capita in the country of dairy and definitely across the world is still increasing. And so to show that this dairy and methane from dairies are not going to go anywhere anytime soon. So we have a lot of opportunity there to work with. So also I'd like to show you this graph to give you perspective that the dairy herd size in California has been drastically decreasing over the years. So in 2008, actually, we had our the maximum number of cows, and since then it is decreasing rapidly. But you can see that at the same time, although herd is decreasing, the production of milk is increasing over time. So what that means is that we are producing much more milk per unit of animal or per animal. And for you to have an idea, cows, nowadays, the cows produce about 24,000 pounds of milk per year, when in 1964, they used to produce only 10,000 pounds of milk per cow per year. So this is about the 225% increase in production. And what also it means that when you have more milk per cow instead of a large herd, is that you are reducing the amount of methane not only per cow, but from the whole herd. You are decreasing also the amount of feed necessary to feed the cows, and water as well. It was all win-wins. But although the previous slides are very exciting, at least for me they are, we cannot ignore the fact that agriculture still produces and emits important greenhouse gases to the atmosphere. So in this slide, to the right, you can see the the latest inventory, so the 15th edition of 2022, where it shows the percentage of the contribution of agriculture and forestry for the whole greenhouse gas inventory, and that represents about 9%, which is about 31.6 million metric tons of CO2 equivalent per year. As you can see, the majority of the agriculture and forestry portion of this GHG are coming from manure management and enteric fermentation. And so you can see that so that represents about 72% of the total ag and forestry. Of the manure management, or let me start, so of the enteric fermentation, about 10.52 million metric tons of CO2 equivalent is coming from cattle. And then if we break it again, this number not in two pieces, we'll see that about 2.95 million metric tons of methane will come from beef cattle, so 28%, and the other 72% will come from the dairy cattle. Then on the manure management side of this, which is the 11.58 million metric ton of CO2 equivalent, we see that about 2.5% of that comes from other animals, so swine, poultry, goats, and sheep. And then the remaining can also be broken down in two pieces. So 3.7% of the manure management comes from beef cattle, and the large majority of 94% or 10.86 million metric tons of CO2 equivalent comes from dairy cattle. So that's why our program really focus, and the state is really focused in the dairy sector in specifically. So what the state of California is doing about methane reduction. So we have two fronts. We have the legislative and regulatory measures, and we have the voluntary measures. So in terms of legislative and regulatory measures, we started in 2006 with the Assembly Bill 32, which required a reduction of greenhouse gases of 20% from 1990 levels by 2020. And we successfully achieved that even before the deadline. And with that, we noticed we had opportunity to do even better. And so in 2016, the Senate Bill 32 came, and it's the expansion of the EB 32, which requires a 40% reduction of greenhouse gases by levels of 1990 by 2030. So kind of on those lines, in 2014, we have passing of the Senate Bill 605, which requires the Air Resource Board to develop a plan to reduce emissions of short-lived climate pollutants, which in those includes methane, black carbon, and fluorinated gases. And then to continue our story and make more specific to livestock, in 2016, we had Senate Bill 1383, which that established a methane reduction target for California. So the case of livestock, because those targets are for several of sectors of the state, but in the case of livestock, we must achieve a reduction of 40% methane below levels of 2013 by 2030. And if there is no progress, or by some reason the Air Resource Board, in conjunction with the California Department of Food and Ag, sees necessary, regulations may be put in place on 2024 or later. So this is that side of the approach. In the California Department of Food and Ag, we went through offering the carrots instead of the stick so far, and we are noticing this is working really well. So we have developed two incentive programs that serve to incentivize dairy and livestock farms to reduce manure management emissions from the implementation of digesters, which is done by the Dairy Digester Research and Development Program. And we also have the Alternative Manure Management Program, which is alternative to implementation of digester. And that program, and we have both programs because although if you get per unit, the digester has a higher decrease on methane, AMP also, may be something that somebody may not have the economics to implement a digester, or the location is not appropriate, or there is not a market for the renewable energy, or just for pure preference. And so we have these two programs that we call sister programs because they work really well together. So on the front of enteric fermentation, we still don't have a incentive program in CDFA because, as you may have heard and seen, that enteric fermentation is still and mitigation strategies are still under research and being evaluated by the FDA, the Food and Drug Administration. So we still don't have an official strategy that can be put in place that is commercially available. So, but those are coming. They are moving really quickly, and as we speak, several products are being analyzed so far, and hopefully soon we'll have something for us to incentivize on that front too. So now just to give you more details about the Dairy Digester Research and Development Program. It is a competitive grant solicitation process that is administered by us at the CDFA, and has already mentioned many times, I guess. The purpose is to award funds to California dairy operations and digester developers for the implementation of dairy digesters that result in manure methane emission reductions on California dairies and minimize or mitigate adverse environmental impacts. Just a little bit on funding and duration about on this program. Actually, on October 7, we just finished the 2022 round of applications, and we awarded 14 new projects at $18.7 million. And we already, due to the budget, the passage of the Budget Act of 2022 in July, we received allocation of $48 million that will be available for the 2023 DDRDP and AMP, and that is to be given priority to AMP. So kind of how the money flows, that state general funds in this case allocates money to CDFA. CDFA does a competitive process, and then those that score higher on the rubric and do well and meet all the requirements and eligibilities are awarded the grants. So nowadays our grant amount is up to $1.6 million, and a 50% match is required. So for example, if you ask a grant that is $1.6 million, you need to contribute with another $1.6 million or more to be able to be awarded. And the project maximum duration is of 2 years. So for example, the ones that were just awarded in October, they are going to start construction and the process in January 1st of 2023, and they have until December 31st of 2024 to complete the project. This is really summarized some of the requirements, but I thought for the purpose of today, these are the main points that we should talk about. So first of all is that methane must be used for energy production or transportation fuel. So this is just to say that flaring the biogas has a sole use for the biogas produced is not eligible for funding. It is important also to note that 80% or more of the dry weight of the feedstock to be given to the digester must come from manure from dairy livestock. And that's due to, as I mentioned before, we have a target to be met by 2030. So we need to focus on dairies at the moment. Total NOx emissions cannot be greater than 0.5 pounds megawatt hour for electricity projects. So that's why sometimes, and I will show later, we have several renewable natural gas projects instead of electricity, because we are using one of the most stringent regulations for NOx here. So all projects must comply with all applicable state and federal regulations. Recipients must not change their herd size beyond their existing permits during the project term. And all the applicants must use the latest DDRDP, California Air Resource Board quantification methodology and benefits calculator to estimate GHG emission reductions and the co-benefits. So next slide, I wanted to show you how these projects are divided across the state. As you can see, it kind of follows where the concentration of dairies is in the state. So the Central Valley goes all the way from Modesto to Bakersfield. And you can see that we have funded so far 131 projects, where 130 were incentive projects and one was a demonstration project. And we awarded already $214 million to these 131 projects. We have, with these projects, and about 65% of them are ready, accounting for the ones that just joined in. We are accomplishing 23 million metric tons of CO2 equivalent reduction over 10 years. And so that's not to snuff at it. About 9 projects of the whole 131 projects are electricity generating from biogas. The remaining 122 projects are for generating renewable natural gas for heavy duty vehicles. So another important thing I think to say on the slide, since we are talking about numbers, is that the Dairy Digester Research Development Program is the most cost-effective greenhouse gas reduction emission program funded by the Greenhouse Gas Reduction Fund and now the General Fund, where a metric ton of methane only costs the state $9. So it's really effective. So, well, first I show you how our digesters look like and go a little more in detail. I just wanted to show you how, how the manure flows through the system and how gas is processed. And Jason already did a great job explaining some of it, so I'm sorry if I'm repeating myself. But here in the case of California, about 75 to 80% of the dairies and those located on the Central Valley are going to use some sort of flushing with or without scraping to manage the manure in their farms. So you see that, and I'll see if you can see my arrow. So it starts here with the cows, and as you already heard from Dr. Kafka in the morning, cows and Jose, the cows can poop a lot, and so this waste is flushed. It comes to this processing pit, and there is several names for this, and it's homogeneously mixed. So everything is really across similar. And then it goes to the solid liquid separation, which for us, the majority will be this dual screen type of system. So there, and there's actually the solid liquid separation happens to all our digesters funded so far. And so portion of it, the solid fraction of it, goes to the manure pile. So this can come here on the bottom, become soil amendment, become animal bedding, or other innovative products, such as pellets or biochar or whatever your creativity can give you. The liquid portion goes then to the digester. And there is where it stays for about 30 to 45 days. And after, so the liquid portion after the 30 to 45 days can be used, it's called the famous digestate, and can be used as a great fertilizer to the dairy farm, or if there is a way you can export it. But yeah, very rich. The gas then produced on the digester goes through several conditioning and upgrading steps. So the first step, it's moisture removal, because since there was a biological reaction, there is a lot of water also on it. This biogas the raw biogas coming right out of the digester has equivalent about 45 to 65% methane composition, and being the remaining CO2. And so the first step is to remove sulfur. In the case of manure digesters, we don't have much siloxane, and this has Jason mentioned before, it's more the case of food waste and other types of waste. After that, it goes to a compression process. You can, at that point, separate the biogas, and you can use it for heating, electricity, or other industrial uses. And if you continue to this chain of upgrade, you will go to the CO2 removal and removal of other impurities, again compressed, and then you're ready to inject at your utility pipeline. So at this point, the renewable natural gas, which started really, really dirty, it's about more equal or more than 96% of methane. And then that methane, as I mentioned to you, goes for powering heavy duty vehicles. So now I'd like to share some pictures just for you to see some of our projects. So similar to that little picture before, this is a station that is one of our recipients is using to fuel trucks, heavy duty trucks that are related to the dairy industry. So this is really exciting. Then here's a picture of one of our digesters. You see it's like we have the lagoon, and it's covered with the heavy tarp, and it has a lot of sensors and systems, even though it's very simple in design. And here to the right, the bottom right, it's the CO2 removing membranes, and this is a lot of energy goes to this process. And some of our recipients are already thinking to even reuse that CO2. So that would be even greener, because instead of releasing the CO2, which actually at that point is carbon neutral, because those cows ate those plants that did photosynthesis, you are even closing the cycle by using that CO2 instead of emitting back to the atmosphere. This other set of pictures, it's our developer that has installed a 2 megawatt fuel cell in their farm. So they are really far from the pipeline, but they still wanted to, be part of the movement and have a digester and produce renewable energy. So they installed these fuel cells, which are extremely clean. They do not emit any criteria pollutants or anything, and they are working so well that they are talking about having a hydrogen facility close to this, because then at the same time you are producing electricity and making hydrogen out of that biogas. So it's really exciting. And I'm almost finishing. Here is a picture of the upgrader facility. So this is when the gas from the dairies, they all come here, and it's where it's the sending to the utility. So here, if you see inside the fence, you have another fenced off place where is the utility portion of it. So after removal of CO2 and compression and so forth, you can send it to the utility, which is then to the general population. And here the utility will do measurements instantaneously and see if the gas is meeting specifications. So if it's not good, they send it back down the line to further cleaning. If it is good, it goes back, it goes to the pipeline. And one more or two more slides is that these projects are not just being beneficial in terms of methane reduction, but they also provide several other co-benefits. So I'd like to show you that we accurately measure through the calculator tool, and even the tool, it's kind of on the conservative side, but that's okay, because even like this, we have really good numbers to show you. So the calculator tool, we started to measure co-benefits since 2019. So that's actually just half of our projects are being accounted on these numbers. We have the other ones since 2015 that are not being accounted. So the calculator has given us that we are, these projects have, since 2019, have reduced 1,500,000 gallons of fossil fuel. About 102 billion gallons of renewable fuel have been produced since then, and that is equivalent to 22,000 vehicles being removed out the roads every year for at least 10 years. The projects that produce electricity have generated 565 million kilowatts hour of electricity, and that's the equivalent of light or giving electricity to 7.8 thousand homes per year for at least 10 years. Then we have the criteria pollutant reductions, which is really exciting. So we have reactive organic gases reducing in this amount, have nitrogen oxides, the local PM 2.5 and diesel PM, because we substituted diesel with renewable natural gas. And since all the digesters have that solid liquid separation, we produced about 32,000 tons of composting. And all these projects, and again, since 2019, not even before, have produced 4,379 full-time jobs, which you can see here, the breakdown. Yep, so that's for me. And thank you for having me. And please don't feel shy to reach out if you have any questions about our programs.
And we had one question from Jacob Collins, but it sounds like it might be for all three of you. We'll do that question at the end, Jacob. We'll try doing that at the end. Okay. And our next speaker is Cassandra Ferrant. She's the head of environmental credit at AMP Americas, and she has been working for 15 years on the air quality and greenhouse gas emission consulting, and she handles credit compliance and new project development. So Cassandra, go ahead.
Hi, everyone. I'm Cassandra, and I'll be talking about what the last two presenters had been talking about as well. It's an exciting field that we're going into, but manure digestion to low carbon fuel. It's not letting me.
Cassandra, I can pull up your slides.
Okay, that would be great. If you can see them. So for As I said, I'm with AMP America. We've been around for over 10 years. We have multiple dairy to low carbon fuel facilities across the United States, and we supply fuel into California for transportation fuel and making green hydrogen and other uses as well. So you can go to the next slide. Our vision is to make 100% renewable fuels. Although as I'll talk about today, we're a primary dairy digester company that makes dairy RNG. Our goal is to reduce methane from the atmosphere and create a carbon benefit for that. As we do, we own, operate, and build our own portfolio of assets, as well as deal with other third parties who do RNG from organic waste, landfill gas, or co-digestion. Next slide. We are a leader in the United States on US dairy to RNG facilities. We had some of the first facilities built and certified under the California Low Carbon Fuel Standard, as well as the RFS program. Our goal is to reduce greenhouse gas emissions, and we do create a negative carbon intensity fuel from dairy RNG. So we're not only just displacing fossil fuel, but we're removing methane from the atmosphere that would have happened, creating a negative carbon intensity score. Next slide. So what is evaluated for a low carbon fuel? We look at the life cycle emissions for the fuel. So that would be the well to wheel type model that CARB uses using the simplified CI calculators, or if you're thinking about the Inflation Reduction Act that just came out this year, they use a well to gate model with the GREET 2.0 model to calculate that. When looking at that, we look at the baseline and project emissions. The baseline is looking at the emissions that would have occurred. And on the image here is an example of what California uses for their compliance offset protocol for their boundaries. But it's an example of what is looked at, included in a well-to-well analysis of how the manure is collected, how the manure is treated, as the previous presenter discussed, and the process it goes through. And so we look at everything from the generation of manure, collection of it, processing of that manure, the end result of where that digestate then goes, their field application, bedding, it's usually used for beneficial use and has additional uses that then also displaces other materials that were being used, such as fertilizers or straw or bedding that may have been used previously. We then look at the project emissions that are associated with taking that raw biogas and turning it into renewable natural gas, the electricity use, natural gas use, any combustion or use of that fuel on site as well. And that together in those models is used to calculate the carbon intensity of that fuel. We typically think about that in total grams of carbon dioxide equivalent per megajoule. Next slide. So for the baseline emissions, we look at what was currently happening at the farm prior to a project going in place, as well as the total avoided methane that is going to occur. That is being done. We look at how the manure was being managed. Did it go to a lagoon? Was it used for bedding, composted, dry lotted out in the field? These are all the things that go into the model to calculate what methane would have occurred without our project. It should be noted that dairy projects all are in line with a farm's operation, and the farm does not change how it is doing day-to-day operations based off the project. It's the manure is received and then typically sent back to them. It's just a small facility within the larger farmer's operations, and those don't change based on us coming to help reduce emissions. I did provide some examples of different models that are used to calculate the carbon intensity, but could also be used to calculate the total avoided methane. In California, there's the compliance offset protocol. Federally, we use the ANL GREET model, and then in California for the low carbon fuel standard, we use the Tier 1 simplified calculator, specifically here for dairy as well. Next slide. So project emissions are the emissions that go into running and operating our facilities. This would be electricity use for running the membrane systems, for the compressors, the knockout tanks, everything that the gas needs to be processed through. Natural gas is used to ensure that our digesters are operating properly, depending where your facility is located. There's different types of digesters. Some digesters are just a lagoon cover, or other digesters are enclosed vessels. And enclosed vessels, we want to ensure we have the right temperature year round to ensure we have the right anaerobic conditions to ensure appropriate biogas creation. So those are all items that go into project emissions. We also look at any biogas or natural gas that could be used. So if you have excess biogas, we could be using it on site as well. Or if there's biogas that meets injection specifications, if that's destroyed on site, that is taken into account as well. But we also look at the fugitive emissions. So we've captured all this methane, and some of it does get out. And so, those are taken into account when calculating emissions. And main ones are feed loss, venting emissions, any gas that is not captured. A lot of these emissions are calculated based on models or based off of a mass balance to ensure that we're getting a true picture of what the carbon intensity of the fuel is. Next slide, please. So for biogas collection, once we have the gas from the digester, and this is the same for any type of feedstock that you have, not just dairy RNG, but wastewater treatment plants, landfills, anaerobic digestions of organic waste. Once the gas is collected, it's normally for dairies we normally say 52 to 65% methane. That manure goes through the process for approximately 20 to 30 days in the digester, then it comes out. We do take that digested material. It is used for a variety of reasons, beneficial use. And then we take that material and it is the biogas, and we do upgrade it. The upgrading process is basically removing the hydrogen sulfide as well as carbon dioxide and any moisture that's in the gas to get a material that is equivalent to natural gas, at approximately 98% methane. That gas can be used for multiple things. Anything that natural gas is being used for, we could use RNG for instead and be delivered in the same fashion. So a fleet fueling at a station for CNG can fuel up with RNG, or it could be provided to our power plant or a refinery to make green hydrogen, or many different uses as well. It can also go directly to electricity production. Instead of upgrading, though, you can also send the raw biogas to fuel cells or jet engines to make electricity directly as well and have low carbon intensity of electricity for use as well. Next slide. So when you're looking at the whole process, we go from having a biogas form to RNG, renewable natural gas, and that's the final byproduct typically of these types of projects. And the whole idea is that we've removed methane that would have been emitted, so we're taking a big step forward in meeting California's goals under AB 32 and SB 1383 and other rules, as well as displacing natural gas or diesel or gasoline that would have been used. In transportation, RNG is typically used to decarbonize heavy-duty fleets. So those are fleets that electric vehicles are not available for large trucks or agriculture or other uses. And those fleets can easily switch over to a CNG fleet and a renewable CNG fleet. Next slide. So turning avoided emissions to the large carbon fuel, as I said, gets you to about 98% methane renewable natural gas. And that can be injected into the utility pipeline and sent anywhere that the pipes connect. And so anywhere nationally, gas can be sent. So it can be used to help decarbonize anywhere, all different industries and all different things. In the future, hopefully it can go to utilities will start purchasing it more to go to homes and industry. and not just transportation fuel, but there's so many uses for it. The main items that, when we're getting to that 98% methane are really trying to remove those other items of hydrogen sulfide and carbon dioxide. As I said, that carbon dioxide, our AMP is working on multiple projects to capture that and use it for beneficial use or inject it as well, which would be taking additional carbon dioxide, which would be considered a biogenic carbon dioxide source, and removing it from the atmosphere as well, which would be additional benefit to the climate. Next slide. So as you can see here, California uses emissions come into a large variety of sectors, and I've highlighted all the areas that AMP currently supplies renewable natural gas, which is reducing fossil fuel use in those industries. So it's from the refining process, that includes green hydrogen manufacturing, agriculture, electrification. AMP does have a biogas to electricity project where we do make low carbon CI from the biogas directly on site and put it on the grid for use. Heavy duty transportation, forklifts, these are all examples of things that where AMP is helping reduce methane emissions and carbon dioxide emissions from the atmosphere. Next slide. So when talking about low carbon fuels, they're all measured based on their carbon intensity. As I said earlier, dairy RNG is a negative fuel. As you'll see on the middle of the slide, you'll see the green circles are where dairy RNG CIs typically lie. The bottom one is first rate RNG or CNG replacing CNG. And then the top one is if you're going to use dairy RNG for hydrogen production to make green hydrogen. And then the orange ones are where your standard fossil fuel gases are. You'll see the standard fossil fuel CI is around 100 grams of CO2e per megajoule, while dairy RNG on its own ranges typically between -150 and -600 as shown, and then reduces the hydrogen again from a positive to a carbon neutral to negative CI score as well. And RNG is the only gas that's currently available to help with this process. And the green ones are where, AMP is currently doing it. Dairy RNG can also be used for LNG as well. You just take the CNG and then make it a liquefied compressed natural gas to then be used, and it's just slightly more energy intensive. Next slide. So AMP has been doing this for over 10 years. We were the first dairy RNG to provide fuel to the RFS, the Renewable Fuel Standard, to make RINs. We were the first RNG to fuel project to be certified by CARB and get a pathway. We had one of the lowest CI score initially when the program was being started back then. And we are currently building new projects as we speak. So we are working on expanding and investing and trying to remove emissions from the atmosphere all over. In 2022, we are projected to have removed approximately 500,000 metric tons of CO2e from the atmosphere and converted that to a low carbon fuel. Next slide. So here's a map of some of the locations of our assets. We are developing projects across the United States, not only to work in California's programs, but to work in new programs that will be coming up and are developing, as well as we are working on developing a California project as well. It's one of our important goals for this year. And on the right, you can see some pictures of some of our facilities and what they look like. Next slide. And I think that's it. So any questions?
See, Steve McCorkle had a couple questions. Let's see, I guess one of them's mainly for Roberta, I think, but it says if the digestate is land applied, does it calculate, Does the calculator account for the additional GHG emissions from the land application?
So no, the calculator does not calculate for the land application of digester or the manure in the case of the alternative manure management. That's, yeah, it's, that portion is still under study to see what is the effects of manure versus digester being applied to the soil. So yeah, still in progress.
For projects that do partake in the California Low Carbon Fuel Standard, we do report the emissions associated with the end use of that, though. So it depends on at which stage you're applying it to the land. So we do report it, and it does have it has defaults that go in and calculate the project emissions associated putting it, if it goes back to an effluent pond, if it goes for bedding, if it goes to land application or goes to solid storage. And we do, some of that is calculated for it is calculated for all projects that do report to CARB under the LCFS program.
And Steve had another question. Has AMP considered gas to liquids technologies to convert the anaerobic digester biogas directly to diesel and SAF, sustainable aviation fuel products?
I'm sure our engineering team is probably looking at that and talking about it now. If you had more questions about that, like, feel free to reach out, and I could set you up with the right people to talk about that.
Okay, and we had a question from Jacob Collins from Listec, and let's see, he says, is it true that if we were able to reuse all organics produced in California as soil amendments or fertilizer, it would still be less than 1% of the fertilizer needs to produce food in current California agricultural production system? And why is it so hard for growers to access these reusable projects and regulations or marketing? What? Take a stab at that?
Dr. Kafka was just here this morning, and part of that report that he has produced, which was funded by us at the California Department of Food and Ag, I think is a little higher than that, because just the excess of manure from even the dairies on the high priority zone 1 of the if you get all their excess of nitrogen, we were accounting for about 5 to 7% of the need for nitrogen. And these are like those dairies already had fulfilled their own needs, and so just the excess. So, and I'm thinking now with food waste and others, but I'm not familiar with food waste, but yeah, I'm thinking it's a little higher than that number.
And see, I got a message that Mary Garaudo is raising her hand. Jose, do you want to let her speak? Or
if Mary, if you have a question, you can talk if you want to ask your question. She's raised her hand, but she's not talking.
Okay, well, you can also type it in under Q's and A's.
Yeah, Mary, you can also ask your question using the Q&A feature.
Okay, other questions? I guess I have, well, one remark for Cassandra, or for all of you, you know, I saw data that the production of manure was going up in California. I'd also heard from other people that more dairies were moving out of California, but that it looks from your data like there's actually more. Is that, have you heard both sides of that, or any of you?
I don't know if Cassandra, you want to go first?
the dairy market is like any market where there is movement, and based on need. It's not that if you look, smaller dairies like many agricultural industries are moving to larger farms due to market pressures that are outside of the low carbon fuel space and what's happening. And so family dairies are often family owned, and as they pass down from generation to generation, it's very common to see changes. I've seen many, I have seen dairies leave the state, but I don't have any backup information to provide expert opinion on that.
And yeah, I just wanted to kind of tag along in your answer, Cassandra, that yeah, we are seeing, and now we have Sigma and other water regulations that are really going to affect, I think, more than methane reduction, which we are on path. We think we are going to meet the 40% reduction by 2030, but if we don't have water to farm, then I think we will have problems on keeping these dairies in California. So yeah, for us at least, we are seeing a trend, and like Cassandra said, a consolidation of the herd. So smaller dairies kind of migrating, and that has been happening for more than 40 years. It's not like a new thing, it's just a trend. Like we used to have 18,000 dairies in California back in the 60s, and now we just have 1,250. So that is a lot of consolidation happen. But there is also, and CARB put a really nice report in the beginning of this year showing the trends that the herd size is also going to decrease in California. So consolidation and herd decreasing, that's, I think, the future.
Yeah, and one thing to note is in California currently and federally, there's no requirement to collect methane emissions. So a lot of the regulations that would try to drive farmers out of the state aren't set with air quality. They are set to other items such as water and other things, reasons, costs that and items that go there for a variety of reasons. Most farms, to one of the previous questions, for any fertilizer that, or any manure that goes to land application for farming, farms always use it themselves first prior to selling it based on need. And so, normally it would go for their own crops, to grow crops to sell or to feed the cattle directly, or that manure would go to bedding instead of buying bedding for the cows as well. So a lot of the on-site use is being used and goes into something prior to looking at what excess is being sold into the marketplace.
For any of you, do you see future funding sources? Roberta had talked about some of the current, or the ones that they have, grant money for the next couple of years.
So the Inflation Reduction Act, the IRA, has significant funding for renewable projects that include dairy RNG, as well as other types. There are thresholds and requirements in there, but they are tax-based incentives primarily, but are expected to draw and create new projects throughout the United States.
Any other questions?
I was going to mention, like our project, you saw that new cogeneration system that's installed. It probably won't, the commissioning probably won't be wrapped up until after the first of the year, so it will be eligible for IRA funding, which is a good thing. And probably the investment tax credit, but it's going to be another, months before the U.S. Treasury has those regulations and applications, prepared. And so we're, as a public agency, we won't receive any tax, credits, but they do have a direct pay program too, which would be about the same amount as the tax credit value. So we're looking forward to that.
Other questions? Any final points any of you want to make?
I enjoyed learning about dairy operations. That was really educational.
Good.
The same to you. I really enjoyed your presentation and Cassandra's presentation as well.
No, it was very educational, and I live in San Rafael, so I drive past the, the plants all the time. So
Come by for a tour then.
yeah, we can compare power generation for different plants.
Okay, well, we'll take a break until 3:15, and then the second portion of the treatment processes and siting, Chuck White will handle that. So see you all back at 3:15. Thank you.
Thank you.
You're spotlighted, Chuck. We're good to go.
All right, can you hear me?
We can.
Good. When do I start? Right now?
Yes.
Well, welcome everyone to session number 4 of our conference, which I believe is going quite well. A number of different topics that we have covered. We got a few more to cover before the day is over, but don't forget we're going to be starting up again tomorrow. I'm Chuck White. I'm a senior advisor with Manette Phelps and Phillips, LLP. We are mostly a law firm, but we also do help clients on consulting issues on navigating California legislative and regulatory requirements. My focus is on energy and environmental issues. I spent many years working for the state of California. I spent many years working for waste management. And I tried to retire in about 2015, but I just couldn't do it. And I'm still enjoying myself and trying to get as much done in moving things forward, like trying to find more exciting and interesting and profitable uses for organic material that has historically been largely wasted. And there's so much going on right now. It's just been amazing. I spent 2 weeks ago, I spent 2 days in San Francisco with the ABLC next conference, which is the Advanced Bioenergy Leadership Conference that is sponsored in part by Biofuels Digest. And it's just amazing. There's about 4 or 5 years ago, there was maybe 35 participants over the 2-day conference. And this last couple of weeks, there was 750 attendees attending 2.5 days worth of conferences with 4 overlapping sessions. And there was about 100 different topics being covered during that 2.5 days. And it ranged all the way from energy, bioenergy, to biomaterials, to bioproducts. It's just amazing what a boom is happening right now in investments in these kinds of technologies as we try to steer ourselves away from relying on fossil materials to produce products and energy and services that we need and become used to. And it's really encouraging to see what is all happening out there. And for this session, I am going to ask 3 folks that are well known in their respective areas. Uzziah Hunt is with Pacific Biochar, and I don't know that much about biochar, but I'm about to learn. It is used to really increase agricultural and productivity of soils and help keep carbon in the soils rather than in the air. Next, I'll come back to Uzziah in just a second. After that, we have Michelle Applegate, who is with the Canary project, and they are in the process of trying to encourage there to be greater monitoring of all methane emissions, focusing initially on fossil methane emissions to minimize the impact on climate change and global warming, but also on biomethane to ensure that if we are producing these better than fossil fuel products, making sure they don't have the same kind of consequences. And Michelle will tell you about what their plans are. And then wrapping up our 1.5 or so session is going to be Steve Wertel. Now, we had Steve with Core Industries here last year, and it's an interesting issue, one of which I've been very much interested in over the last 20 years, is how can we more effectively and efficiently recover energy from waste organic material or any kind of waste product. And Steve was here last year and talking about their core gasification project that's in LA. And they're taking municipal solid waste and using gasification type technology to produce fuels and energy and this kind of thing. And you say, well, how can that happen? California's got a very difficult. Well, Steve's doing it by doing an RD&D project. And the thing I'm interested in looking at Steve's project and his company is how are they going to be able to provide this RD&D project, evidence that these kinds of technologies can be expanded to more than just R&D projects, but can maybe play a much larger role in managing our organic wastes and our municipal solid waste. So I'll come back to each of them. In fact, I'm going to return right now to Uzziah Hunt with Pacific Biochars. Let me see if I can, I think I have a little more about Uzziah. Uzziah is actually, are you still in Hawaii, Uzziah?
No, I'm California based.
Okay, good. Well, for a long time, his resume said he was from Hilo in Hawaii with a BS degree in agroecology and environmental quality. And he lived on the Big Island, I guess it is, and he developed pioneered methods for biochar production, processing, and application. And he's managed to bring that over to California. I suspect you're finding there's a much more, there's big demand for your product, and we're about to hear more about it. So, take it away, please.
Thanks so much. Yeah, so thank you for that introduction, Josiah Hunt. I'm the founder and CEO of Pacific Biochar Benefit Corporation. We are a California benefit corporation. It's essentially a C Corp for tax purposes. And we produce biochar right here in the state. And here in the state of California, my company registered the first biochar carbon credits in all of North America at a facility, a bioenergy facility right here in California. I'll go ahead and do a presentation share and tell you more about it. All right. So what is biochar? Effectively, it's biomass charcoal, which is even redundant in that because charcoal is from biomass. So biochar is charcoal. That's it. But there had to be a new word because attached to this material became a concept with ideas of climate change mitigation and long-term soil productivity. And those concepts just couldn't be held in with the word charcoal, so they had to come up with a new word. It's been around for a long time. As long as fire and plant life have coexisted, biochar has been part of soil development. And in the past 20 years or so, there has been a proliferation of research. A lot of this driven by, again, the climate change mitigation and agricultural productivity. I love this article. It's a systematic review of 26 global meta-analyses. So, there's more than 20,000 research articles. They're now doing review articles of the meta-analyses articles. So pretty powerful stuff here. This represents enormous amounts of research showing that there's in general benefits in crop yield, in water use efficiency, in additional soil organic carbon development, in available phosphorus, plant nitrogen uptake, reductions in greenhouse gas emissions of nitrous oxide, as well as reductions in plant uptake of heavy metals. So a lot of benefits of the material in ag. And then I'm telling you, it's a doozy here. There's a lot wrapped up in the whole concept of this biomass charcoal material that we now call biochar. So the whole concept is that we're utilizing waste materials. There are piles of biomass so large now we call it waste. So we can utilize this waste material in an energy positive process. So that waste material becomes incredibly hot, releasing gases. Once it becomes really hot, that biomass basically can break into two fractions. You get your gas fractions, and then you have the material that stays as charcoal. Those gas fractions are energy. It's combustible as basically a natural gas, which can be combusted for electricity, or if you want to get really fancy, potentially make some renewable natural gas or drop in fuels. But that gets pretty crazy to try and do that. So mostly what we're doing is just generating electricity. So in this energy positive process, we generate the charcoal material, and this charcoal material is a changed form of carbon. The carbon that remains is a new form, this form of charcoal that is recalcitrant, meaning it can resist decay for hundreds of years. As long as you put it somewhere safe. You could burn it, but as long as you sequester it somewhere safe, such as plowing it into the soil, it will stay there for hundreds of years. And other uses could be asphalt and concrete for materials that have potential contamination. Of course, here with the outcomes of, let me minimize that, with the outcomes of, food security, water conservation for generations, and carbon sequestration beyond 100 years. So it's a durable carbon removal. So that's what I'm saying here, that all that's kind of packed into this word called biochar, the term biochar. Why is it not advancing? Okay, here we go. So this is what my company is doing. There's a lot of different ways to make biochar. My company has really been focusing on modifying existing bioenergy facilities. Certain types of biomass power plants can be modified to co-produce biochar. So that's what we do. We modify biomass power plants to produce biochar. This causes either an electrical reduction, an electrical output reduction, which is not favorable, or an increase in the biomass input, which is favorable, particularly here in California, where we have a glut of forest biomass waste. So this is a plant here in California where we are utilizing forest residues and producing biochar. The biochar produced just simply loads into standard trucks. This is a live bottom belted trailer. Oftentimes it lands at compost yards where there are some synergies, but ultimately most all of it's going out to the field. This is one of California's largest vineyard management companies at a field in Salinas Valley, where the biochar has been part of a field trial for more than 6 years, showing significant benefit. And now this company is utilizing biochar in most all of their new vineyard deployments. How do we make this whole thing work? So the whole basis of my company, as it took me a while to figure out, is that this simple statement: when the carbon is worth more in the ground than it is in the furnace, a business we might have. So we have to make that true, and we have to make it true at scale, because this charcoal material, it's as good as anthracite coal, basically. We could burn it for energy, or we could put it in the ground. My company has to make this worth more in the ground than it is in the furnace, otherwise we're going to burn it. So we make that true with agricultural sales, and now with carbon credits. So we survived barely for more than a decade on ag sales alone. And I feel like that decade was kind of like a proof of concept, while my company and many others were doing a lot of research and development on how to make this work and how to make it work at scale. And then as of recently, there are carbon dioxide removal credits in voluntary markets that are supporting our ability to actually grow and to scale this at commercial scale. This is a really important part here, that as the price of carbon goes up, it becomes viable for biochar to be an ancillary product. And at some point, with a sufficiently high price of carbon and a sufficient demand, not just the voluntary, I think we'll have to, well, more on that, but if there's a sufficient price and sufficiently stable demand for that price of carbon, then at some point the energy could become the ancillary product in some of these facilities. This is the registry landscape for the voluntary market. This is how we're helping make this happen. There's published protocols and there's active platforms for trading. IPCC actually has a intergovernmental panel on climate change, has a carbon accounting methodology for biochar. Find that interesting. Here's just a snapshot of active and idle biomass power plants in California. Not every single one of these is ripe for being modified for biochar production, but many of them are. There's 24 active plants in California. That number varies depending on how you filter it. 163 in the US, and the global capacity is 81,963 megawatts or thereabouts. So just in modifying existing infrastructure, there's quite a bit of a runway there before we even have to build anything brand new. This is at Humboldt Sawmill. This is one of the places, this is one of our pioneering facilities where we're producing biochar right here in California, and also the site where we registered the first carbon credits for biochar in North America. We're continually producing biochar at this facility, utilizing forest residues and sawmill residues. This is one of 2 sites in Georgia that we're going to be bringing online pretty soon here with biochar production. And this is another site here in California where we're going to be bringing online, hopefully in the first quarter of next year, which I'm really excited about this facility because it's almost exclusively tier 1 high fire hazard forest biomass that is utilized at this facility. There's 4 more in the Western US that we're hoping to bring online sometime in 2023. That's just kind of a snapshot of like how this is growing. And this is kind of our expected carbon dioxide removal run rate growth schedule. We're doing this with a pretty small team. Thank you very much. I know that that's just kind of a snapshot of what we're doing, and I just kind of felt like I wanted to go through that fast. We could get an idea of what we're doing and what biochar is, because I feel like the interesting part will probably come in the discussion. So open for questions anytime.
Yeah, why don't we have a few questions now? If no one else steps up right now, we can do some more at the end, but I have a couple I'm holding here for you. So we'll see if there's anybody out in the audience that would like to ask a question right now. I'm not sure I know how to see if anybody is, but I'm sure someone will let me know.
There's no questions right now from the Q&A that I can see.
Okay, well, I'm a proud member of the Sierra Club, and the Sierra Club has for many years raised concerns about biomass energy because they feel we're harvesting trees, or they feel that we're harvesting trees that should be allowed to grow. And I was wondering how much of a concern that is from your standpoint of producing a biochar. I mean, you made the comments you're producing mostly for thinning forest to prevent wildfires. But do you run into this argument from various organizations that we're harvesting biomass rather than using waste biomass?
Yeah, I'm very familiar with the argument. For none of the facilities that we work with is that even remote possibility. Harvesting the biomass, going out there and harvesting the trees is a lot more expensive. There's lots and lots and lots of waste material to be dealt with first. And 2, it's problematic in many ways. And thankfully in California, there's a pretty robust regulatory system to ensure that kind of those kind of activities wouldn't happen, that we're not out there just cutting down trees to make biochar. If it was just like magically expensive, particularly, I think that, and if there was not a regulatory landscape to mitigate the potential for negative outcomes, I think those concerns would need to be dealt with more quickly. But at least, particularly where we're at, there's just not enough money in it to support going out and chopping down perfectly fine trees. And there's a very robust system of regulatory compliance. There is an incredible amount of forest residue, just waste material, particularly for the fire hazard reduction and from the fire cleanup, as well as PG&E power line clearing and sawmill residues. So just from those resources alone, there's just an incredible amount of resources. And an additional layer is that in the carbon credit registration process, there are very strict guidelines as to what can and can't be used to specifically address that concern. And so if we were not able to meet those guidelines, we'd be missing out on the key element that's making it possible for us to survive as a company. So with those in place, those concerns I feel are pretty well addressed.
I drive up and down Highway 50 to Lake Tahoe quite a bit, and I drove down there last night in a snowstorm, but I could still see the remnants of that fire, the Caldor fire that's still there. And boy, it sure would be nice if we could make beneficial use of those forest residues, because they're not going to be growing anymore. They're dead.
You nailed it. That's exactly what we're trying to do. We're trying to provide the maximum benefit pathway for some of this waste residue. There's no need to go cut down trees that are perfectly happy where they are. There's so much waste to be dealt with first. And we think that by taking some of this waste organic material and transforming it into this fixed form, which can serve as carbon removal and long-term soil fertility, it is one of the most beneficial, like human and ecosystem beneficial pathways to utilize that material.
Yeah, and is there anything you're doing that would help support the reforestation efforts? I mean, I can understand taking away the dead trees and use them for biochar and energy, very low carbon energy. But what about restoring those burned forests that you remove the trees from? Is there some aspect of your operations that can facilitate that?
Primarily, I think that the biggest lever to help in that, I think, is that we are helping provide a pathway for those residues to go. Because currently they're like just in the Tahoe Basin, I'm not sure how much there is in California, but just in Tahoe Basin, there is 750,000 burn piles that will be just lit on fire and burned in place, leaving a burn scar on the ground, letting all that CO2 evaporate in the air, and without any emissions control that would reduce your soot, methane, or nitrous oxide emissions from those. So that's it. I mean, if we can just start making a small dent in reducing those burn piles and give them an alternative pathway, we're doing pretty good. And so that's the biggest lever to help the cleanup. As far as the biochar going back out into the forest, they are using biochar as part of the potting media in the saplings that are replanted. That's already kind of happening, and it amounts to a very small amount, but it is a little bit of a return to the field.
I see Dan Noble has his hand raised. I'll probably hold my other questions I have for you until the end if we have time. Dan?
Okay, thanks. Yes. So you mentioned, Josiah, that, and by the way, thank you for adjusting your schedule so you could show up. That's great. That when you were trying to get the price of biochar to be higher than energy, but energy prices seem to going up. And when you're trying to get energy off of the biochar unit, is there any benefit to that in terms of the capital costs of trying to capture the energy? Because you got to effectively burn it in a low oxygen environment, right?
Yeah.
So,
yeah, no, it's a really tricky relationship between biochar and the energy. The production of biochar is exothermic, right? So you are generating. You can have a biochar production facility which is optimized for producing as much biochar as possible, and it will still generate electricity.
Right.
But every ton of biochar that you harvest could have been burnt to produce even more electricity.
Right.
So at some point, the equation comes that would we be better off installing a few more solar panels and wind turbines to generate that extra little bit of energy? And so that's part of the equation. And generally, with the equation that we have to make fit is that the biochar has to be worth more than the waste feedstock that would replace it.
Gotcha.
So the cost of biomass replacement is basically, that's the number that we really have to meet or exceed, if that makes any sense.
No, it does. And that's tells me that when you look at local economies, it's almost somewhat of a competition or a trade-off, more of a competition, it seems to me, between the energy market, the green energy market, versus the soil or the green ag and soil market. And yet, so yeah.
Generally, biomass power is not the cheapest form of power. In
Sure.
very few cases can it outcompete wind or solar. And in fact, in California, many of the biomass power plants that are still in operation are partly in operation because of a California state subsidy that helps. It forces PG&E to purchase power from a certain minimum amount of megawatts. But it says, all right, if you want part of that contract where you get a good rate from PG&E, you shall utilize no less than 80% designated high fire hazard material. So it's basically the state was having trouble figuring out what to do with all this high fire hazard forest biomass. And they realized that some of these bioenergy facilities were some of the best currently existing pathways to utilize this material. And that if they went out of business, the state would be in even bigger trouble than they already are. So they helped create a subsidy to keep a certain key locations in operation if and only if they utilize that high forest biomass material. And there's still an excess of forest biomass material to be dealt with. So by producing a little bit of biochar in combination, we can marginally increase the throughput at a given facility and help increase the ability to utilize that excess forest biomass.
Great, thank you. I know Chuck probably wants to move on to the next speaker.
Well, actually, I have another question, much related. I'm not going to hold the end. I'm going to, right when I was last heavily involved in bioenergy facilities, they were falling off the so-called cliff because they were getting reduced financing from the power facilities. I think there used to be something like 38, even maybe 40 biomass facilities in California. Now that, as you pointed out, they're down to 26. Now that this biochar option has come along, is this going to be helpful in keeping some of these biomass energy facilities operational and maybe potentially bring more back online?
We are now in the early stages of being able to answer that question. Yeah, and when it was ag sales alone that was driving it, I think there was no reasonable way that we could actually make a dent. Now that we are getting the voluntary carbon markets to help support, now I think there's a reasonable pathway. And I think the big step would be those voluntary markets are hard to be heavily reliant on because they're voluntary and they could disappear. And so larger kind of institutional, state, federal, or international level guarantees on that carbon removal credit for biochar would definitely help ensure that the biochar could play a role in that.
Well, I've got another question related to that, but I'm going to hold it off until the end and give the other speakers a chance. But you're not leaving, are you?
I'll stick around.
Good, I appreciate that. Well, next up we have Michelle Applegate, whom I've recently met, and they've got a really interesting company called the Canary Project, and I guess it makes sense as a name because it's kind of like a canary in the coal mine, which I'm sure Michelle will make some reference to. But they're kind of building on a matter that the Environmental Defense Fund has been really highlighting, and also has European Union and various other European countries to encourage the monitoring of methane and making sure that a minimal amount of methane is being produced both from fossil and biomass operations. And I think EDF estimates that about a 30% reduction in greenhouse gas emissions could be affected if all methane was reduced to 0.2% of the overall methane that's being produced. And it's not 100%, but it's very low. And they would be going a long way to really addressing climate change. Well, lo and behold, I think somebody at Canary read the EDF report and said, I think there may be a business opportunity here. So that's what we've done. I think the initial focus of Canary is on fossil fuel emissions of methane. But I mean, think about it. It's just a matter of time before those fossil fuel methane emissions are going to be gone, but we're going to be worried about bioenergy methane emissions and things like landfills and things like compost and things like other types of operations and dairies, for example. So Michelle, would you take it over from here and let us know what Project Canary is up to?
Absolutely. Well, thank you everyone for the time today. I'm really happy to be a part of this panel and excited to share some information with you all. Project Canary is a B corporation. We are actually based in Denver, Colorado, and we buy into this idea that methane is a pretty dangerous, short-lived pollutant. And we think that there's something that can be done by providing technology to the fossil and bioresources industries to be able to measure and therefore mitigate their methane emissions in the upstream. And so Project Canary was started about 3.5 years ago by folks who felt that it was important to start there. And what we've really found in the industry is that both the fossil and the bio areas of this industry, of the oil and natural gas industries, are already taking steps in these ways. And they're getting pressure from a variety of outputs across the marketplace. Largely, we're seeing investors requiring it. We are seeing sustainability-linked lending. We're seeing stakeholders and shareholders demand ESG goals in the fossil areas. And we're seeing the increase of environmental disclosures and required environmental disclosures. My area, I'm actually over our public policy for all 50 states, regulation, state policy, all the way up and down. So everything from federal all the way down to our county commissioners are making decisions on energy policy that impact how we measure and monitor the emissions that are coming off of these industries. And then we really have our operators and our consumers. You know, consumers are starting to stand up and say, we really want to understand where our energy comes from and how we are handling the environmental effects of our energy. And this is driving LNG exports. It's driving utilities who purchase a significant amount of natural gas. And it's really driving even us as the general day-to-day consumers to start to ask questions. And so one of the things that we are really excited about is seeing all of that magic start to happen. And those pressures are really causing everyone in the energy industry, upstream, midstream, and even downstream, to take action. A little bit about Project Canary. We really do, we are a data company, we're a technology company, and we do two simple things. We develop technology and sensors and partner with sensors such that operators in the fossil and bio spaces can understand their methane emissions and mitigate them. And then we provide software and dashboards and software as a service such that folks can quantify actual leaks, measure them, monitor them, track them, and then also prove when those leaks are mitigated. And so there are a tremendous amount of technologies that are in this space now. We'll talk about that in a little bit. But all those technologies play a role. Not every well is the same. And what we've really learned is that there are different solutions for different wells, different ages that are in a different point in that curve. But what's really important is to measure and understand the actual data that's coming off of those locations. We believe in what's called the digital canopy. You know, California has made some news in investing in satellites to measure methane, but there is a variety from the space all the way down to the ground of ways to monitor and measure methane emissions. And we talk a lot about methane, again, because we believe, excuse me, it's the strong starting point. But frankly, there are sensors to measure ethylene, there are sensors to measure CO2, there are sensors to measure hydrogen as hydrogen hubs begin to build. And what's really important is how do we allow operators to take that data, put it into a control center, and then really allow them to net zero or even real zero. Chuck alluded to this a bit, but what we've used for the past couple decades is really emission factors to report on emissions in this industry. And the EPA average last year was a 0.454%. There have been several studies from EDF, from Stanford, S&P Global, and others that have said, you know what, we think that number might be a bit underestimated. And our thesis is if we can get down to fugitive methane emissions in the 0.2%, not the 0.454%, and hopefully not in what might be actual emissions of 2, 3, and 4%, we can make a significant impact in our climate today. Essentially, what we can do is the equivalent if California went from a 0.48% to a 0.2%, it would be the equivalent of taking about 8 million gas-powered cars off the road per year. And so this is a really interesting component. It does not change the way that gas is burned at the burner tip, but it does take the methane leaks out of the process to get to the burner tip. We often hear that this is a short-term problem, but we believe that while we are in this energy transition, it's important to address those leaks now. We really believe that we don't have time to wait, and the best way to do that is to measurement. This is a chart that was put out by S&P Global. They also fly satellites, and they have looked into what the methane intensity is for various basins across the country. Methane intensity is a fancy way of saying what's your leak rate. It's essentially the volume of your leak over the volume produced. And what you see is that it really varies across the country. And as we are making purchases in energy, it's important to know and understand where energy comes from and how much of the pollutants are actually going up into the atmosphere. We have seen a lot of action in the policy space around methane in the last couple of years. The federal government has a tremendous amount of activity going on around methane, And we really believe that the idea of measuring methane is the harmonizing factor across all of these rulemakings. Many of you are aware of the Inflation Reduction Act and what that does. And it offers, it's a huge bill with a tremendous amount of information and a tremendous amount of opportunity. With respect to methane specifically, there is quite a bit of direction to the EPA to revise their Subpart W rules to look at using empirical data instead of emission factors. It also, the BLM is looking at how you put royalties on emissions, not just production. There is an EPA methane rule ongoing in addition to the methane rulemaking for Subpart W that would be implemented by the IRA. We're also seeing the SEC take action. They have put forth the climate disclosure rule, which is already in the rulemaking process and really seeing a fair number of challenges up and down the space. And really, this is the federal government, but we're seeing this across the world. The European Union is tackling this issue as well. Canada, Brazil is interested in this. And so what we're finding is that globally, we have partners who are ready to step up, and we have partners who are really developing and trying to get there. And so the ability to measure and prove that we are cutting methane becomes really important. We are but one of many technologies, as I mentioned earlier, and I kind of love this slide because the reality is that we were using emission factors 20 years ago because the technology didn't really exist to be able to measure affordably, and it wasn't widely available. And with every kind of uptick in requirements and regulations at the federal level, we have seen the number of patents for technologies that can detect methane almost go in an exponential curve. And it's been really exciting to watch. And so what that has done is that has brought the cost down of these technologies, but it's also really made them much more available, and you can find the tool that you need. So a little bit about what we do. We have our digital canopy, which is our software where you can really take data coming in from a variety of different places, put it into a dashboard and really understand what's going on in your system. We also do certification where we will go out and assess a company's operations based on a 600 data point assessment based on petroleum engineering principles and how those operations impact the air, the water, the land, and the communities that surround them. We have a smart technology and a learning technology that will take what's going on a well pad and alert operators, quantify emissions, and help them to identify where those leaks are coming from. And finally, really looking at down the road when we are not as concerned about methane, at looking towards things like carbon sequestration, hydrogen, how can we be a measurement, reporting, and verification support system for the industry? A little bit more on the digital canopy. We really believe in a top-down and bottom-up. You know, we see satellites, there's drones, there's flyovers, there's regional approaches, and then there's data that is consistent and kind of every day, every second. Project Canary was based on direct measurement, which is where we would have 3 canaries to Chuck's point, canary in the coal mine, a tool that helps to alert you when you have a problem. And so we would put 3 canaries up on any well pad that are triangulated specifically for the geography of that well pad and for the equipment that's on site. Those sensors are monitoring every second. They're averaged every minute, uploaded into a cloud every day. So it really gives operators actual real-time information as to what's going on. You may not need that on every well, but you can pair that with great satellite information. You can pair that with drive-bys and flyovers and really get a great picture of what's going on. And that sensor agnostic approach allows for folks in any situation to take advantage of measurement. I know I'm going long, so I'm going to kind of go fast through these. We do believe that quantification is really important, the ability to actually monitor not just when leaks happen, but to actually get an emissions profile and understand the volume of emittance. It's what's really going to help us go from, you know, the challenge we have now to really improving our industry in this industry. And we believe that this information allows companies to deploy capital appropriately. This is an example of a dashboard that any operator might see. That top line with all of the lines are the data coming in from each sensor. You'll notice that a lot of the leaks are intermittent, and that's one of the challenges in this industry, regardless of of whether it's fossil or a bioresource. And so what this allows operators to do is they understand the wind direction, they can understand the sensor data, and it helps to pinpoint equipment on site. And it also, in this upper right corner, you'll see that there are alerts that require the operator to annotate what happened. And so what it really does is it allows any operator to prove their emissions. And so this is an actual data from one of our operators. As you can see, they had a lot of noise going on, some spikes, some peaks. They pinpointed it, they made operational improvements, they were able to quantify their emissions, but they were also able to show and prove that their emissions were reduced. And so we really just believe that the measurement economy is here, and that in order to cut it and count it, you have to prove it. And that this proof of performance is really what we should expect of all operators, but also how we can really make a difference. And that's it.
Great. Am I back on again? Can you people hear me?
Yep, we got you, Chuck.
Great, thank you. Well, I did get a question about why am I facing away from the camera here? And that's because I've got two screens, and one screen is what I watch, and the other screen is what I have to talk into. So it gets two screens. But I will take any questions we have for Michelle right now. I have a couple myself, but we won't spend too long on this. We'll get to our next speaker, and then if we have time at the end, we'll circle back, and you'll be able to stay with us. Are there any questions for Michelle from the audience out there? Let's see if I can. Yeah, I don't see anything right now, but I'll just get started. Let's see. So I remember the argument some years ago about how certain climate pollutants have a global warming potential of 25, but other kinds of climate pollutants like methane have a global warming potential. Well, in case of methane, I think it's like 76 or 80, and then others are even higher than that, 300, 400, 500. So how do you make the case? Because I think California right now says everything is going to be on the 100-year time frame, and everything is measured. So methane has only a 25 global warming potential, when one could argue it should be 80 or even higher. So how do you guys feel about that? Doesn't the current 100-year time frame kind of dim the spotlight a little bit on your issue?
It absolutely does. And you know, to be fair, the global warming potentials are picked, and the 100-year versus the 25-year are often picked with the goal of, are you looking at the longer term? Or
uh-oh, you're frozen on us. Does anyone know what happened to Michelle?
The shorter term. You know, the good news in the short term, you do get to the 80 and 82 numbers for a global warming potential. We also recognize that, for example, when you look at an organization like the Air Resources Board, who picks a 100-year GPW, they are looking at a different picture, but they also are very understanding and aware of how methane plays into that role. And that's why you see methane task force. That's why you see, kind of separate methane reductions and goals.
Well, in California, has focused on short-lived climate pollutants with focused legislation. And I think there's some rethinking going on over there at CARB. In fact, today, earlier today, they had a workshop on the low carbon fuel standard. And it's clearly there's some things going on in the minds of CARB about how they might want to change the low carbon fuel standard. The one that really stuck out most to me is they're looking at maybe even reducing the amount of use of RNG, renewable natural gas, which has some of the lowest carbon intensities currently available in the low carbon fuel standard, because they want to see that RNG used for other things and use other kinds of energy for powering vehicles like electrification. And to me, that doesn't make any sense, because you've got the lowest carbon intensity fuel available in California. And I know the focus right now at Canary is on fossil energy, but if there's concerns being, for an example of dairies, where dairies are maybe having fugitive methane emissions, is there a use for your kind of technology and your kind of things, not only on fossil emissions, but also on biomethane emissions? I know yesterday CARB also announced the refocusing of methane emissions on landfills, for example. A big workshop coming up in a couple of weeks, I think. And that's going to be very interesting to pay attention to as to, well, so I mean, I guess my point is you really can't ignore biomethane. It maybe plays a lesser role, but maybe right now, but you have to start thinking about that. I assume you are.
Absolutely. And the bioresources, I wouldn't even say are a lower priority. I think it's just getting into the market. As you'll hear from a lot of companies where they're getting into a market, it's evolving and you have to start somewhere. And we started with fossil, which we felt was the biggest opportunity to make an improvement in the climate situation. But absolutely, Chuck, we are piloting with renewable natural gas facilities. We're piloting with landfills and really making sure that our algorithms are able to monitor plumes across those different structures and different facility geographies, if you will. But it's definitely the way we're moving.
Okay, good, very good. And maybe one last thing before I move on is, okay, so you're trying to make fossil energy less of an environmental concern. Do you ever get any criticism that you're kind of, helping maintain the fossil fuel industry, which many believe has been really kind of one of the reasons why we have climate change? How do you respond to that criticism, if there is any?
Oh, there's definitely that criticism, and it's a fair criticism. And our response is, look, we don't know how long we're going to be consuming fossils, but we are today. And even if the goal is ultimate electrification, we've seen studies come out from our utility friends that say, look, we're trying to get there, but natural gas is in play for at least, the next couple of years. And our point is simply that we can make an impact today. We can't afford to wait a few more years to be off of it. So while we are using it, let's use the cleanest version of we can.
Well, good. I see my pal Dan Noble's got his hands up, so he's got a quick question. And I think, I got another question popping up from Steve McCorkle. So maybe we'll deal with those two. We still have time. We're going to go to about 4:45, and I'll come around to Steve Wortel after these next two questions. But after that's it. So Dan, the floor is yours.
Well, thank you. So Michelle, really interesting technology. I mean, I remember working with the EPA like 20 years ago for performance-based regulation and real-time monitoring. Now it seems to be coming to pass. Do you see this changing the way regulations are put out as well as monitored? Not only, mainly for methane. Are you looking at like VOCs in California and stuff like that? Yeah.
Absolutely. And I think you're exactly right, Dan. We have technology now, and not just ours, but many others that are actually able to measure and identify these. And so regulation is a slow and often frustratingly challenging truck to move in some cases. And so we do find that we can be much more agile and effective with local community regulation. But we are also seeing the change slowly, even at the state and federal levels. And so when you have a state like California that has been very proactive in the space through agencies like the Air Resources Board and the CEC, and even public utility commissions who are authorizing, utilities to still procure significant volumes of natural gas, you have the ability to start to manage these in a way where we can see improvement. And so I do see regulation starting to shift, but that, as you probably know, will take many years and potentially lawsuits, and we will get there, which is why we really want to focus now, because by encouraging producers to do this on their own for all the reasons that they might, there can be an impact made.
For some, the wheels of government
Thank
move slowly. For others, the wheels of government move too fast. So,
right.
One question I've got from Steve McCorkle, one of the attendees. A high percentage of methane leaks from oil and gas are from stranded gas flares that go out and vent raw methane until detected. Using some of the technology you described, the appropriate personnel could be alerted as the problems occurred, which would be great. These flares are supposed to be automatically self-reignited if the flame goes out, but apparently that is not happening. Do you know why these flares are not automatically reigniting, and does Canary have a plan to address this?
No, and Steve, it's a great point. And the idea of why they aren't reigniting is something that we have seen some of our operators try to deal with. But the fact that they are alerted as soon as it happens allows them to get out faster. And so those huge volumes of methane being released into atmosphere can hopefully be shortened. The lifetime of that leak can be shortened. We are also seeing flaring and venting restrictions starting to come out at state regulation levels and state laws. Texas, New Mexico, North Dakota have all implemented some version of, requiring reduction in flaring and venting, same with Colorado. And so this technology really allows operators to know immediately and be able to address it. But I don't have an answer to the reigniting challenges.
Great, thank you. Well, let's move on to Steve Wortell. As I mentioned when I first started, we had Steve in last year, I think, to talk about his project that was in development at that time. And it's, as far as I know, it's the only solid waste to gasification facility operating in California, because California has, and I'm going to go in and try to explain the legislation and the regulations, but it discourages, in fact, there's been some people that have just kind of gone out of business because they couldn't site one in California. But Steve has a background in civil and environmental engineering. Steve is a business development executive with 30 years of experience in water and wastewater markets. He has been involved with other companies, and he's seen $20 million business development budgets, and really is focusing now on trying to see if there's a door opening for these kinds of technologies to help California reduce emissions and manage its solid waste. I know it can be a very controversial issue, but I think I'm going to be looking for Steve, and I may ask him a question related to this at the end. Is okay, we got an RD&D facility growing. What's the next step? And hopefully he'll provide us an answer with that. So Steve, welcome. Thank you very much for joining our show. And I look forward to hearing more of where you are now that your facility is actually up and running, and how is it running?
Well, thanks, Chuck, and thanks for inviting me back to speak again. I will talk about how the facility is running, but it is running very well. Last year at this time, we were just getting started. So now we've got a year of operation on our belt, and we've accomplished many goals. So this is the facility here. I don't think I had this snappy picture last year to show you, just to give you a sense or how close it is to downtown LA. It's on a site owned by Southern California Gas, and the facility itself processes about a ton an hour of biomass feedstock, so about 24 tons a day. And we are fully supported not only by SoCal Gas, but also the South Coast Air Quality Management District, who is interested in our technology for its ability to produce zero emission transportation fuel, specifically hydrogen. So over the last...
Steve, you're in your presentation view. You might want to switch to slide view.
Oh, I didn't. I thought it would just show that. Okay.
You're good.
Good now? Okay. So over the past year, what we've done is confirmed the mechanical and thermal integrity of these systems. Operating chemical conversion or biomass conversion at temperatures north of 1,000 degrees Fahrenheit has many challenges that we discovered along the way, but we were able to overcome those and have now essentially de-risked the technology from a mechanical and thermal standpoint. And we've had Leidos reviewing our operation, and they've written a report testifying to that fact. Our next steps now are to move on and test as many commercial feedstocks as we can, as well as start to optimize the process for both the biogas production and then from there, hydrogen production. And I'll put this notion out now. The site that you see our facility at, our agreement with Southern California Gas ends at the end of this year. So we are going to be moving this facility. It's one of the advantages of having a standard design factory built skid mounted system is that we can unbolt it from the slab, pick it up and move it to another site. We've got a few candidate sites that we're looking at, but the decision hasn't been made yet. So if there's anyone out there that is interested in potentially having this system at a facility that they operate, we will move it to your facility at our cost and operate it there. Just reviewing last year why this technology even exists or what our business case is is that there's really this push and pull, as I describe it, of legislation to, first of all, be pushing feedstocks away from traditional uses like biomass power plants, like landfills, in particular SB 1383 with its landfill diversion requirements. And on the other side of the equation, we've got a pull from the LCFS program and now the Inflation Reduction Act and its production credits, providing incentives to produce these fuels. And what we need as a society is conversion technologies in the middle that can utilize those on the left to produce those on the right. And we know that there's lots and lots of biomass available in California. Here's the oft-cited study by Kafka and Williams that shows we're generating in this state on the order of 100,000 tons a day of waste feedstock when you consider all of the material that can be extracted from the forests to reduce fuel for wildfire risk. And most of that material is lignocellulosic, which means it can't be managed in an anaerobic digestion process, making it ideal for this type of a system. So again, just a little bit of background. We're talking about biogenic feed here, which originates with a plant, originates with the photosynthetic combination of atmospheric CO2 with water and sunlight to produce carbohydrates that take on many forms depending on the plant. You have cellulose, sugar, lignans, etc., plus oxygen. And that's biogenic feedstock. Then that biogenic biomass becomes the feedstock for our process. It is a pyrolysis process, so it operates at high temperature, zero oxygen environment. Traditional gasification technologies utilize some oxygen to produce a more traditional syngas. Our focus is operating high temperature, slow pyrolysis to maximize the non-condensable gases. What we typically wind up with then is a gas that has a calorific value about half that of pipeline quality natural gas, or on the order of 500 to 600 BTUs per cubic foot. And it's largely comprised of these four molecules in different proportions depending on how the system's operated. We also produce a biocarbon, also known as biochar, which Josiah did a great job of describing, so I'll hardly have to talk about that at all. But those are the two products that we produce, and generally speaking, the carbon tends to move about half and half in each direction, half into the elemental carbon char and half into the gas. But of course, that depends on the fixed carbon and ash that come with the feedstock. So I want to talk about the range of renewable energy products that we can produce from that biogas that we generate. So beginning with the biogas then provides a flexible renewable energy platform. So if we take these ag residuals, demo wood, biomass from forest management, et cetera, through the process and generate that biogas can then be used to produce steam, for instance, in steam flooding operations. It can be used to produce natural gas for any number of applications, such as power for campuses. And it could even potentially be used in a fuel cell to decarbonize the cloud, for instance, and use that technology in a server farm. And again, because we're able to sequester the carbon in the biocarbon, the entire process is carbon negative and the energy that's produced is carbon negative. Now we can also take that biogas and upgrade it by separating the hydrogen and potentially also converting the CO, carbon monoxide, into more hydrogen using steam. We could produce renewable hydrogen then that can be used in many different mobility applications: fuel cell electric cars, trucks, buses, trains, forklifts, etc. And those applications are growing rapidly in California in particular. Now, those are the typical applications that we've been working on with the technology, but lately we've been getting a lot of inquiries and calls about how this process could work with anaerobic digestion. And through those conversations, we've really found that the process complements anaerobic digestion nicely to increase RNG production. Let me go through the strategy and approach for why that is the case. What we're finding, or what we're hearing from digester operators, is that nutrient removal is an increasing problem for these digesters with limited options for nutrient disposal. And I'm primarily talking here about dairy digesters, manure digesters, food waste digesters, and even green waste digesters. After anaerobic digestion, the process is incomplete, and there is a digest state that's left over that traditionally has been used as a fertilizer for land application. But the problem is that that land application can create excess nutrients that have the potential to contaminate local ground and surface water supplies. And so dewatering is typically one of the approaches that's utilized to help solve that problem, but dewatering doesn't solve the entire problem, because we still have nutrients either in the dewatering liquors that are left behind and or in the digest states, which may be used for land application and composting. So these, in many parts of the country, these anaerobic digestion facilities are hemmed in by managing the nutrients that they generate. So pyrolysis can help solve the problem of solids management by implementing the pyrolysis process. And typically these feedstocks are going to have a high moisture content that we're going to want to reduce before pyrolysis. And so there'll typically be a drying step up front. That could be mechanical drying, or it could be solar drying using sun and wind to dry those feedstocks and produce that biogas and biocarbon that I discussed earlier. But in this case, we're essentially transferring the nitrogen problem into the biogas, because the nitrogen becomes volatilizes with the biogas. And if we want to recycle that biogas, for instance, back to the digesters, we run the risk of overloading the digesters with ammonia and creating toxicity conditions. So what we've come up with is a proprietary process to remove the ammonia from the biogas and create a fertilizer product that can be then used for sale. And in that case, then we can utilize that biogas to increase the RNG production of the entire facility. We need a methanation process, though, to convert that biogas into methane, and that can be done either chemically or biologically. And again, returning the biogas to the digester is one biological methanation approach that these opportunities that we're talking about are considering. And we could take this whole process one step further. Now that we've got a fertilizer product that could potentially be used, we can utilize that to grow fast-growing plants. Fast-growing plants would include things like miscanthus, bamboo, hemp, or potentially even algae, so that we can in real time be removing atmospheric carbon that can then be brought into the pyrolysis process to produce more biogas, to produce more RNG. And with this approach, we can produce multiples of what the previous digestion process was able to produce with RNG, and we don't need to bring in external fertilizers to do that. We can utilize the nutrients that were a problem for the process, making them into a strategy for a solution. Now, with respect to the biochar, it's again primarily elemental carbon that could be used as a soil amendment, as a substitute, as a coal substitute, as Josiah indicated, and that could be interesting in particularly difficult to decarbonize industries, and I'll mention one shortly. And of course, the carbon negative attributes can be sold as voluntary CO2 offsets. So as a soil amendment, this material has many benefits. Because it acts like a sponge in the soil, it will reduce irrigation needs, which could be less irrigation water required, improves nutrient retention, which can reduce fertilizer, as well as reducing nutrient runoff, which leads to non-point pollution problems. and it enhances soil microbial activity, creating a healthier soil. And all of these lead to increased yields for the plants that are grown in biochar amended soils. And then, of course, there's the carbon sequestration aspect of it. Again, because of the way that this material is formed, it is recalcitrant, will not revert back into CO2 or methane. So it will be sequestered as elemental carbon in the soil for centuries. And in California, this biocarbon can substitute for fossil coal in difficult to decarbonize industries like cement manufacturing. Little known fact that California cement manufacturers import about 900,000 tons of coal and petroleum coke used to generate heat in the kilns that produce the cement. This biocarbon would be a very interesting replacement for those fossil coal products. And California has recognized that. The state has recently issued Senate Bill 596, which is a low carbon cement standards, which compels CARB to develop standards to reduce the carbon intensity of cement produced in the states over the next 20 years or so. And as I mentioned, this technology is operating at commercial scale here in downtown LA. If anyone would like to see this facility, please contact me. My information is below. And if you are interested in working with us or partnering with us on relocating this equipment, I would certainly be interested in hearing from you as well. Thanks, Chuck.
Great. Well, thank you very much, Steve. It's great hearing from you, and we may have to bring you back every year just to kind of give us a sense of how where CORE is going.
Well, I hope we have as much to talk about next year as we did this year.
Okay, well, I'm opening it up to anybody has a question. I'm trying to navigate here. I don't see everybody on the. Oh yeah, there's a woman named Mary. Oh no, that's who is Mary Giardo asking a question of? If I could ask Jose.
I think she had her hand up briefly and then lowered it. I'm not sure. That was a while back.
A while back, sorry. Okay, good. I'll just move forward then. So one question I have, Steve, is it's not related to my issue of, I'm a solid waste guy, but working on solid waste issues. I have 25 years with waste management. I kind of get the issue, but as I alluded to, right now, California's legislation really discourages gasification pyrolysis for taking in mixed solid waste. And I was wondering if you've looked at a way to try to get around that, either by maybe not by separating the waste into its component parts and then treating it perhaps as a recyclable material, or have you formed any alliances with other similarly companies that are involved in pyrolysis and gasification? Do you have any plans to approach CalRecycle or people in the legislature that have concerns about that? See if there might be some way to look at the experience you've gained working the facility in Los Angeles to see if there might be Los Angeles, for example, the city and county have been long-term proponents of these technologies to handle municipal solid waste, but it just has been very difficult to get anything started. You're kind of unique in that regard.
Yeah. So one thing, let me make clear that we're not processing MSW in this facility, not a mixed municipal solid waste. We would be looking at segregated biomass feedstocks. So construction and demolition wood, green waste, forest thinning debris, low moisture agricultural waste, orchard removals, nutshells, et cetera. In fact, next week we're going to start processing pistachio shells here. So we're looking at those types of biomass feedstocks. And as I understand it, SB 498 allows for a certain amount of that to help meet the SB 1383 diversion requirements.
Exactly, yeah.
So that's our pathway to success to get this commercially viable.
Good. If there's any more questions here for Steve, I know. Oh yeah, go ahead. Is it Josiah or Hosea? I used to have a friend named that spelled it the same way and it said Hosea, and so I was calling you that. But what's the proper pronunciation of your name?
I don't know. I didn't make up I just call Josiah as usual, but Hosea is fine too. I'll answer that.
Good. So you had your hand up, sir. Go ahead.
Yeah, I think with the MSW, so this is a question for Steve. This is increasingly an area of interest for me. I know that the process of pyrolysis destroys pathogens, that's pretty obvious, as well as toxic organic compounds, of which PFAS has been of growing concern. And I'm wondering, it just seems like it could be a really interesting application if done appropriately to help kind of break that cycle of PFAS re-entering the system from municipal solid waste, biosolids, and others. And I'm wondering how much of that you've dealt with.
It's an excellent point, and we've done a tremendous amount of work on paper with this.
Okay.
We actually have some concepts to deal with PFAS and all of its smaller breakdown components. I'm struggling for the word, but in our process, we've got a couple of strategies that we want to test, and we're going to be looking at that in our next year of testing, particularly if we can find a partner that can help us with that process. But we've got sort of a couple of concepts. One is to destruct it, and one is to remove it from the system.
Thank you.
We don't have any, Michelle had to leave for a family issue, so she's gonna, but if anybody has any questions for Michelle Applegate with Canary, provide them to myself or to the organization, and we'll get them to her, and we'll get your answers back to you. I think I had another question here for Josiah or Isaiah. Now, right now, you're relying on the voluntary market for carbon credits, as I understand it. And as you pointed out, that's kind of an uncertain market. It kind of goes up and down, and ultimately, California's been kind of in the lead of establishing a regulatory defined markets in terms of the low carbon fuel standard, the cap and trade. And is there something more that along those lines that you would like to see California implement to provide greater value in your biochar product?
Well, thanks for the question. Yeah, I mean, there's been a lot of discussion about the 45Q, especially since the Inflation Reduction Act just dramatically changed the landscape on what the 45Q can and can't do. I mean, basically just bumped up the numbers. The 45Q is not applicable for biochar production at the moment, primarily because it's focused on carbon that was already released. You're capturing the carbon theoretically like moments after it was released. And with the biochar process, the carbon was never actually released. So you don't have the release that would then require the capture. So, and there's other elements, there's other reasons why the biochar has a hard time fitting within the box of 45Q. But that's one example on the federal level. I think there's others that at the federal level, the feds, they're working on quite a few number of things that could be applicable. At the state level, the first thing that comes to mind would be CARB, would be if a biochar carbon accounting methodology could be adopted at the state level, that could have significant impact. I put some huge caveats on that. I think that the California cap and trade market is it's a mix of kind of emission reduction and carbon dioxide removal. And right now, the price, the credits that we're getting are in the category of durable carbon removal, which is a kind of a niche category where we're able to get $150 per ton CO2 or more. Numbers that are an order of magnitude greater than what the California cap and trade system is trading at. So there's a couple parts. Like one, I think if California Air Resource Board was to work on developing a biochar carbon accounting methodology, that could be very useful. But then there's some other elements to that as well as to how to make it useful.
Seems to me if you're putting carbon into the soil that's durable for 100 years or more, there ought to be some kind of credit system that could be done under cap and trade. I'm not an expert on cap and trade, but I would think that would be something you would want to pursue, or at least to have some serious conversations about.
Yeah, and in a very general sense, it's very straightforward. But when you get into the details, there's a lot to work out there. There's a lot to work out. As I think I'm forgetting the name. I think it was Kevin asked some great questions about like kind of the consistency or the composition of the biochar, potentially varying composition and how that relates to the carbon sequestered. Those are all things that are being managed in the voluntary market, but they need to be managed with great attention to detail. For instance, the biochar that you put in the ground, it's not as though 100% of that carbon is 100% stable for exactly 100 years, and then it goes up. It's a decay rate, right? And that decay rate is incredibly slow as compared to the organic materials it was created from. But it is a decay rate. And so there has to be an accepted, by all parties involved, an accepted method of determining that decay rate per given material. And so the IPCC has developed a methodology. I guess it's kind of a methodology with training wheels, guidelines for methodology that I think are pretty applicable, as well as there are now 3 methodologies in the voluntary market that provide templates for how to deal with the assessment of that decay rate and how, what sort of carbon equivalent would be allocated to the biochar.
You must be using some kind of platform to get voluntary credits. I mean, there has to be an organization through. There used to be a California voluntary organization, but I haven't dealt with them in years. I don't even know if they still exist. But
Climate Action Reserve.
Climate Action Reserve, yeah, right.
Climate Action Reserve is developing a biochar carbon accounting methodology. I'm on the working group for that methodology. We were hoping to have it done this year, but it's looking like we should have the internal draft ready soon, and we're aiming for a public, a draft ready for public comment. I got to be careful, like I don't want to like put too many promises, but next year, it'll be next year, hopefully in the earlier half of next year before we have a draft ready for public comment.
There were various other issues that were being thought about for the cap and trade program years ago. They always said that was the first step, is to get a protocol adopted by the Climate Action Reserve, and once that gets out there, then that CARB can step in and take a look at it and see if they might have more of a regulatory requirement. Because if you graduate to the cap and trade, that puts a burden on the obligated parties to find ways to buy credits for projects such as yours.
And that's exactly the pathway. That's the pathway that we anticipate, is that the California Air Resource Board, it'll be a lot easier for them to get involved after the Climate Action Reserve has developed their methodology. We anticipate that that's the likely outcome. And I just wanted to note too that the Climate Action Reserve methodology is being funded by the U.S. Forest Service Wood Innovation Grant. And then also CAL FIRE created a matching funds to help pay for that protocol development process. So CAL FIRE and USFS are helping pay for it because of the wood utilization, the excess forest biomass wood utilization potentials.
You have discussions with the Sierra Club on any concerns they might have about biochar production and from forest materials?
I've had some discussions with Sierra Club, yes.
I won't go any further and ask on the tenor of them, but
yeah, it's positive and negative. I mean, it depends on who you talk to there. It's not a monolith. There's multiple different things, and there's there is generally a tendency to be anti-biomass power plant. But then there also has been concessions from a number of folks with the Sierra Club that, hey, we love what you're doing, we just don't like the whole biomass power part. And I don't want to put their words in their mouth for them, but we've had many different conversations. It's not a monolith, and yeah, it'd be interesting to have more.
Certainly wish you and Steve on your respective technologies good luck. I don't see any more questions. Hussein, do we have any more people out there at all, or are we pretty much done? I've kind of run out of questions.
There are a couple of questions in the Q&A.
Oh, I don't have a Q&A. Okay, good, thanks.
Yeah, there was.
Oh, I got him. For Steve, besides air permits, what other permits does a facility like yours need at the pilot stage?
Yeah, when somebody finds out you're doing something like this, they all come out of the woodwork wanting a permit of one kind or another. I think at last count, we have over 20 permits for this facility. So besides air, there's water, there's solid waste, there's fire, there's permits from the city, from the county, from Public Works. Hazardous waste permits, even though we don't have any hazardous waste, we have to demonstrate that we don't. Building permits to build it. So there's a lot.
Welcome to California.
Yep.
Go ahead, Uzziah.
Yeah, there was a question here that was that Hussein directed to me, and it was about are forest residues your company's greatest feedstock, or does your company use other sources? What can you tell us about the properties of biochar from different sources? And I think the IPCC did a great job of kind of breaking down some of that, and others. I'm referring to that again because the carbon accounting has come up in it, and I want to kind of house it with that. But they basically break down into pyrolysis and gasification. Gasification is basically pyrolysis with one extra little kick to it. And then you kind of break it down after that. You get those basic two categories, and then you can have kind of temperature. So above 500 degrees C is very different than say 350 degrees Celsius. And I forget exactly the different tiers they have, but it's 2 or 3, I think. And then generally with your feedstock types, you've got you got your general woody biomass, and there's some minor differences, but most woody biomass has pretty similar characteristics if you run it through the same process. If you're cooking it in pyrolysis above 500 degrees C, woody biomass is going to look very, very similar again and again and again. And then you have, when you get into municipal solid waste or biosolids, it's just really reflective on whatever the feedstock was that went in is really going to be reflective on what comes out the other side, as far as your mineral composition and your potential heavy metals contents.
I remember there was issues years ago that concerned about municipal wood waste that might have various types of chemical treatments on them, like treated wood waste and this kind of thing.
Yes.
There was some concern that they might be hazardous, and then therefore you'd have to have the bioenergy plant get a hazardous waste facility permit, which they weren't that much interested in doing. What has been your experience with that issue of treated wood waste?
Well, Steve was talking about how fun that is, the permits up the wazoo. And then for the biochar utilization, I'll get to Baitong. I hope I'm not butchering it too bad. Baitong Chen answered in the Q&A here about the other uses with biochar that have potential contaminants. There are other uses if the contaminant level makes it a risk to utilize in food production. There are other avenues for it to be utilized, such as asphalt and concrete. So like construction and demolition materials make a great candidate for reutilizing in the built world by putting them into asphalt and concrete, which can be very large resources for utilization. And then it usually kind of negates the word biochar because you're going to be combusting it, but then you can take these biocarbons and utilize them for, as Steve was mentioning, steel production, and other things like that. So, and the steel industry is very interested in utilization of biocarbons, and it might be a good avenue when there's potential contamination risk. But then Steve, maybe over to you for the permitting parts of using that kind of stuff.
Well, it's going to depend on what the contaminant is that's been used to preserve the wood. So, creosote, generally speaking, is organic and will be broken down in the process. Pentachlorophenol, which is also another chemical that's used, is going to be dangerous to the equipment from the chlorides that it could produce. And then what's the other one they use? Chromated copper arsenates. Now you're talking about problems in the biochar. So, there's different solutions depending on what the treated wood was treated with.
Right. Okay, well, I'm out of questions. We're going to be able to end this 5 minutes early, which I probably won't be that many objections to. So why don't we just, if we were had an audience, we'd be asking for a round of applause to all of our participants, Uzziah and Steve and Michelle. And so I appreciate your contribution. Great. I've certainly learned a lot. I always do when I'm discussion. So It's great. I wish you both the best of luck. And if there's anything we can do to help you move your projects and your technology along, we'd love to be able to do that.
Sounds good. Thanks, Chuck.
All right. Thank you all.
Thank you,
Thank you,
everybody.
Chuck. Thanks to the whole team.
Thank you. Have a good flight tomorrow.
Oh, and for the audience, don't forget we're doing this tomorrow too. So don't forget to come back. Oh, there you go. Yeah, he's got the slide up. Good. All right.
Yeah, and we'll have the bios of the speakers available hopefully by tomorrow morning. So if you can check that out on EPA's website, and then yeah, we'll make sure that everybody gets those. So if they want to contact speakers in the future, they can.
I'm sure that the speakers that would be very much interested in hearing any questions or inquiries or requests for more information about their technology. So we would certainly encourage that. That's the reason why we do this thing, is to try to get the information about what people are doing out there.
Great. Well, I guess we'll see you all tomorrow then.
See you tomorrow.
Yeah.
Thank you. Thank you.